All right, thank you everyone for coming here for the 7th Procedural Content Generation Workshop. This is my third. My first one was on the boat, most recent boat, I should say. But I think that one of the exciting things to me about procedural content generation, I came from industry. I worked as a professional game developer for like 10 years. And when I got started in this community, academic community, I felt like industry wasn't really paying attention very much to what was going on in academia, and I think now there's a lot more collaboration that's happening, especially on Twitter. I really see a lot of people paying attention to what's happening and what we're doing here. So it's pretty exciting. One of the things in our call for papers, we reached out and said, like, please don't submit a lot of Super Mario Brothers stuff, which is pretty awesome because we actually have 0 Super Mario Brothers papers. Although I will say that I published my first Super Mario Brothers paper this year, and so I no longer am anti-Super Mario Brothers. We're going to have a stream, thanks to Michael Cook. If you do not like to be streamed during your talk, then just let us know and we won't do you, that's fine. We're going to do something called lightning talks, which is like 3-minute talks. We're going to do 10 of them, or as many as we can fit in, at 12:30. We have a sign-up sheet down here, so please sign up. There's 9 slots left. I'll give preference to people. We'll give preference to people who are not giving talks, right? So. But I encourage you to come and talk about whatever you want. You know, you want to show you something. We're also going to do demos at 5 o'clock. So if you're giving a talk today and you want to show off the software that's behind your system, please do so. I didn't introduce myself. I'm Aaron Isaacson. Amy Hoover is another organizer, and Rafa Badara is our third organizer. He's also running the conference, so not here this morning. Just some logistics. For internet, use something called the cloud. You have to enter in a surprisingly lot of personal details, which you can just lie. I did it. It seemed to work. So, but anyway, the cloud is sort of, or ED-ROM for internet. If you're a speaker, everybody has 30 minutes. That includes your time for questions. I will give you after 20 minutes, I'll give you like a 10-minute, like double hands, and then I'll give you 5 minutes, and then 3 to, down. But if you go over, your talk goes long, then you're going to have less time for questions, and I will like stand up when you get to 30 and cut you off. So we're going to keep on schedule. That is everything. Again, lightning talks, sign-ups over here, so feel free during the first break. We'll have the schedule. We'll show that later, but whatever. We're going to do 3 talks now, and then a coffee break, 2 talks, lightning talks, break for lunch, come back. I think it's 3 more talks, coffee break, 2 talks, and then demos. I think that's what we're doing, yeah. All right? Okay. And then we're going to also, instead of me mispronouncing people's names, I think it's easier for people to self-introduce.
Mispronounce their own names.
So you can pronounce your own name and get started.
Okay.
Thank you. Thanks, everybody.
Thank you, Aaron. Hi, I'm Adam Summerville from the Expressive Intelligence Studio at UC Santa Cruz. This work was also done with Sam Snodgrass and Santiago Otignon at Drexel. And today I'm going to be talking about the video game level corpus. So I'd say over the past few years there's been a fair amount of interest in sort of machine-learned level generation, machine-learned PCG, of which we've had a lot of Mario. This is not exhaustive. Myself, I'm not up there. I know there's plenty of others in this room who have done this, and they're not up there. But we've all looked at Mario and are done with Mario. I'm giving a Mario talk later this week, so please come. We've also done Zelda, or at least I've done Zelda. I don't know if anyone else has done Zelda. I think other people should do Zelda. But was that it? It was those 2. The only other one that I know about that has been published, I know there's one in the pipeline, but is Lode Runner. Now, I don't know about you, but I'm pretty sure there's more than 3 games out there. So why only 3 games? Why have we only ever looked at 3 games? So I'd say there's nostalgia. All of us love Mario. It's good, but is it that good? Is that why we want to do Mario? Is it because it gets press because people care about Mario? I don't know. I'd say a large part of it is that there's just an annoying grunt work task to it. It's either you have to have sitting down and annotating levels and writing out stuff. It's annoying. Or using computer vision, and it's fiddly. It gets stuff wrong. You have to go back in and make corrections. And then the other one, maybe it's cynical, but it doesn't get you publications. It's no one cares that you're doing other levels, or maybe they do, but it's not really a big thing. Or does it? I'm up here talking. But there's a lot of other games out there, and so we present the video game level corpus. 12 games, 428 levels. We have 3 separate file formats, along with the original source images / files that they came from. We have parsing scripts and analysis scripts for some of the games. It's open source. The website's there. Please go to it. Please use it. Please contribute. Please make suggestions. Really, this is going to be a pretty short talk. This is mostly just trying to present something here for the community. It's a resource that I hope gets used, and I hope people like it. So the games. We have a lot of Mario, but so it's sort of broken up into a couple. We have, oh, this is the wrong, anyway, this is slightly wrong, excuse me, but we have mostly tile-based platformers, large number of those. You see here it's sort of the number of them and also the sizes of the levels. We have some sort of tile-based overhead levels. We have the 2 Dooms, or the first two Dooms, along with Legend of Zelda, the first one, the first quest of the first one. We have sort of graph-based topological for the Legend of Zelda's sort of room-to-room based topology of the dungeons. And then finally, we have vector-based ones that was sort of an overhead view for the 2 Dooms as well. So I'm now going to go through the sort of 3 file specifications that we have, and then finally just some discussion of sort of what we hope this will be used for. So the tile format, it's pretty self-evident, I would hope. This is the beginning section of Mario 1-1. Hopefully you can recognize it. We have the ground along the bottom, the enemy, the blocks, the question mark blocks. We have the pipe over there. So for each sort of tile in the level, we have an ASCII character that sort of represents it. It's very intuitive. You can look at it. You can see what's going on. It makes a lot of sense. Each of our file formats comes with a legend, so it's all in JSON, so easily readable, easily usable across multiple different software platforms. So it has each ASCII character along with sort of annotations of what that means. So the X is solid, it's the ground, so that you can sort of use sort of the different semantics of the things if you want to in your work. The tile format, it's good for tile-based games. A lot of earlier games, Atari, NES games, tile-based. Although non-tile-based can be done since we rasterized Doom and Doom 2. It's currently quite lossy. We're working on sort of future iterations that aren't. Like here we have E for enemy, but is it a Goomba? Is it a Koopa? Is it a Piranha Plant, etc.? We're hoping to sort of correct that in future iterations. We're open to suggestions on that, but we have our own ideas, which I'll get to. And then finally, it's sort of well suited to a large number of PCG or machine learning techniques that are already out there. Convolutional. I don't know if anyone's done with the tile-based format yet, but I think it seems natural. Sequence-based, which is what I'm presenting later on this week. And then I know like NOR did like matrix factorization, tensor factorization based as well. So, sort of readily available, and I hope people start using it quickly. The graph format, we piggybacked on the GraphViz dot file format. So I don't know if any of you have seen this before. Maybe you have, maybe you haven't. But we have a directed graph along with node IDs. And then the associated labels. The labels are really the sort of annotated portion here. Along with down at the bottom, then you have the directed edges. So we see that room 13 is connected to room 24 by a big K, which in this is from Zelda, the first level, and that's the sort of boss key, or this is that would be the Legend of or Link to the Past. And then here's the sort of, we chose the graph viz because you can easily spit out a graph. It's maybe not the prettiest one, not the most one-to-one mapping with what is visually seen in the game. But again, it's readily parsable by different things, and so and also easily visualizable, so you can at least see what's going on. And again, comes with associated legend. So we have the nodes, and then these sort of annotations for the nodes. Is it a room? It has an enemy in it, etc. And then the edges. And again, this is entirely open to whatever labeling other people would want to do. This is the format that we chose, but we're sort of open to suggestions again. Right, I'd say that certain types of structures are better suited to this graph-based format. Sort of the inspiration came from Joris Dorman's work at looking at Zelda. Sort of like the room-to-room topology of Zelda dungeons, I think, is good. It's also able to capture like gameplay semantics based on the edge labels, I forget his first name, but Londonio's work, where it was like, you had Mario, and it could be jumped to, could be jumped from, can be walked across, things like that. So we don't have that in there, but the format is able to handle that. And again, this one's currently very lossy. It's just for right now for our Zelda, it's just what's in there. But you could pair it with like tile-based, like this one maps to this room, etc. But we don't have that in there yet. And then finally, vector-based format. We chose SVG because again, easily visualizable. This is a map from Doom where the walls are represented by lines, and then each of the little objects is some object in the game. I think red rectangles are enemies, like the green squares are power-ups, things like that. Again, its own associated legend based on what is in the SVG file, like what color of the line represents what different semantic properties. Or what object in it. The rectangle that's red is an enemy and also walkable space. The blue-green is like a decorative, etc. So again, each of these files has their own legend. And the vector format, I think is capable of handling nearly any 3D game. You'd have to sort of overlay things, and it's maybe not the most pretty to look at after the fact, but there's a lot of games I think that the vector format really hasn't been explored at all. I really hope people start exploring it. I want to start exploring it, but anyway. So now what? Why did we present this? Why are we here? There's a couple of different sort of things that we think are natural evolutions of this this can be used for, but really I'm here because I want to present this and hope to get conversation sparked about how to use this. We've seen a lot of corpora-based PCG. I'm not saying that Mario has been solved, but I solved it. So after this week, no one should ever look at Mario again. And no. But there's a lot of other games to look at, and I really hope that we start looking at other games. But we have one platform, we have Mario, but with more than one, now we can start to mix them together. We can incorporate multiple styles. We can interpolate between styles. I'd say only the surface of Zelda has been scratched. And Nintendo is not the only people to make games, so look at other games. Design analysis. I'd say there's been some looking into the designs of games, like Dalskog's work, Joris Dorman's work. The corporate-based ones. We have input that then goes through computer science magic and gets you output. The design-based, I'd say, is the input, and then a human thinks about what is actually going on in the designs, creates a system that sort of reifies those, and then produces output. But you actually need the input to do this. So hopefully here we're providing the input so people can start to analyze other games. As I said, Mario and Zelda have been examined, but I think it's still open to work on those. But again, other games. Let's look at other games. And then finally, style transfer. We've seen image-based style transfer has become huge. Maybe you have Prisma on your phone and can take art pictures of things, but can we apply it to games? Could we make a Kid Icarus level that feels like a Mario level, a Doom level that feels like Zelda? or beyond just cross-game transfer, could you take a level that there's a bunch of WADs of Doom levels online? Could you take it and John Romero-ize it? Could you, take someone's Mario Maker level and, Shigeru Miyamoto-ize it? I'd be interested to see if that works, if that produces interesting things. So the next steps for this work were, as I said, working on sort of a lossless or nearly lossless semantic compression. For instance, if we have a cloud in Mario, currently that just gets mapped to an empty character, the sort of hyphen, the empty space character. The sort of new idea is that would go to literally an image file that then has sort of different levels of the semantics. It's a decorative thing. Maybe it goes from cloud PNG to cloud to decorative to empty. And then, users could specify the level of fidelity that they want in their output to then work on, or have, perhaps even take advantage of that hierarchy for their generation and say, that this is, a meta thing that has decorative properties that then goes down into other things anyway. And we hope to add more games. And if you have any work out there, I know that there are some floating around, but please contribute. Please make suggestions about other games you'd like to see. Please make suggestions about other changes to the file format. And with that, I'll take any questions.
So yeah, I mean, first of all, it's a great resource that I think will be very, very useful.
Thank you.
And of course, you've got to say something positive first, and then sort of start tearing it apart. No.
Yeah, sure.
But basically, I was one of the people that brought up before that it doesn't currently have a fidelity like E for enemy doesn't allow you to recreate a playable Mario level.
Yep.
It's different. And the thing that I was just thinking ahead. I'm going to suggest something like exactly like what you brought up on the last slide, where you have different levels of abstraction, which makes a lot of sense. Also in the case of, say, Zelda, because in many cases the room might not be the minimum functional element.
Yeah.
So could you also, there are levels of abstraction, but there's also like the decision whether you're looking only for the semantically meaningful content in a level or also a decorative aspect. So cloud is typically a decorative aspect of a Mario level.
Yep.
So I would like to basically be able to get it with a filter that I want everything that's semantically meaningful, but none of what's decorative.
Yeah.
But where someone doing style transfer would want all the decorative stuff, for example.
Yep. Yeah, that's the hope with having like the different level. You could say like, I don't care about the decorative stuff. That should just get mapped to like empty and give me all of like those, semantically meaningful things. Give me the things that only have, different, like this is the goal, we haven't done it yet. So hopefully, a year from now or something, we'll be discussing how the problems with what we're doing in the future. But yeah.
This relates also to basically. So I guess one of the reasons why you have E for enemy instead of Koopa, Goomba, and so on is that you want some generality between levels.
Yep.
So there's a tension here between a universal language for things in levels and being able to be at high fidelity.
Yeah, definitely.
It sounds like you're going to build if you're going to have all these SPT, there's a lot of ontology building here, right?
Yeah, there's probably a bit of it, yeah,
So that, you have Koopa, and then you specify that level 3, this is Koopa, and this is like maps to the generic concept of enemy.
Yeah, and so one of the ideas that I've talked with Joseph Osborne about is actually capturing like having state machines for the different things, so that you could actually start to like then get across different games of like, well, this is actually the functionality that's going on here, and like this is how it operates within the game. But it's again just sort of future work at this point.
Will it still
I have to cut you off and go to someone else. No, joking.
Will it still be just a bunch of files you download, or will you be able to send a request? I want this level, but with these filters or at this resolution or something?
So it would be. So I'd say it would be a bunch of files, sort of like. There'd be like the sort of high-level source file, which probably is not used, and then scripts that that you then run on it, and it just gives you. So that's the request that you make is through the script. But if there's stuff that's not incorporated, maybe you talk to us. But Jillian?
Have you had any thoughts about multiple representation types for each game? So, for example, with Super Mario Brothers, which I know I never want to talk about Mario again. Now I keep doing it. Like we've done a little bit of work with building a graph-based representation of Super Mario Brothers levels because it lets you reason about things sort of more on a semantic level, and then like on the way other extreme, there's like the video game maps, like VGMaps.com.
Yeah, which is where a lot of our yeah.
Rasterized pixelized.
Yep, exactly. Yeah.
So have you thought about how you might, like, I think this is awesome, and I want to only add to it, but maybe more accurately, I like want you to add to it. But like, have you thought about how you might grab
Undergrads. We want undergrads to add to it.
Undergrad research assistants
Yeah.
and but yeah, have you thought about how to grapple with like multiple levels of representation for the same?
No. I think that's definitely a good point. And I like, yeah, for like the Mario as well. Like, I'd like to see different levels of the abstraction to it. I'd like to see. I mean, like we have the original source images with it, so you can kind of do that yourself right now. Or if we go to the one where it's like literally there's an image file that it references, that then you could recreate the original pixel one and then have the different levels. So hopefully that would start to get to it. But as you said, like it doesn't get to like the sort of the graph-based like, well, here's the jumpable things and here's how you can actually move through the level, etc. I think a little bit with like the Zelda one, I've thought a little bit about like we have the graph-based one, which then can map down to the tile-based one. So you could have like, you could have the high-level structure that then gets mapped down to the low-level structure, which I've done a little bit in my work as well. But I'd like to see more of. So mostly it's just, yes, it's something I've thought about, we've thought about, but it just needs more, I think.
Is the GitHub thing like, how do we contribute if we have things to contribute? Do we just
Make a push request, or make a branch, or do what? I mean, email me a zip file. I mean, we can make it work. Aaron?
So on that point of how you contribute, if you come along later on, you say, okay, E no longer is an enemy, and now I'm going to have lowercase g for Goombas and T for
Yeah.
Now my code that I wrote.
The backwards compatibility issue of it.
Versioning becomes an issue and stuff. So one thing it might want to do is just have folders that, once you put something into that directory, like only the owner can change it.
Yeah, and we might even.
Right? You can have 25 different map versions.
Yeah, we'll probably have different like that. We'll have this version, and then we'll have future iterations where hopefully not trying to break anything and just keep it around. Although we can also make tags on it, whatever. But yeah.
In terms of the Super Mario bashing, the conclusion that I finally came to was that it's still important for everybody to have a reference that we all run our algorithms on, right? So in computer vision, they use MNIST. It's not like anyone really needs to solve.
Well, they did, right? They've moved, right? Say MNIST is, I mean, like now it's like CFAR, whatever. Like,
Right.
I'd say that Mario is our MNIST, and we haven't yet gotten to the point where we're past our MNIST, but I'd say within a few years, hopefully we've all moved past Mario and are moving on to more interesting things. But I agree with you, that it's nice to have the reference point as well. But
assuming we haven't agreed upon
file format, goal, yeah. Dark?
So do you have any idea for the sort of 3D qualities of some of the maps as you go along? Like Doom 2, I think, has some overlapping units.
Doom 2 is entirely planar. Like there is different height values, but there is no overlapping to things, I believe. I could be wrong, but no. I mean, or I have ideas, nothing set in stone. We might need to start thinking about other ones. I'd say that the 3D based is the least looked at least in terms of this sort of machine learned, corpora-based approaches. So I'm interested to talk more about ideas that people have. But I mean, I think for a lot of them, you could just have, again, just different sort of color values to set, do like height values within a level. There's a lot of I'd say like in the 3D games, often there's like a portal-based approach where it's like, you go through and suddenly it's it's non-planar, and I don't know exactly how you'd want to handle that. So it's an open question, I think. You had oh, okay.
Tommy, do you want to start something up?
Sure.
Yeah, sure.
Is anybody bothered by the bouncing screen?
Yes.
It happens on the other one.
It is the same thing?
I think it's the fan in the projector is making it.
Just bad mounting on the thing or something. go tighten those bolts or something. Anyone have a wrench on you?
I have a quick question for you, Adam, actually.
Yeah, sure.
Have you started using your framework? Like, is your Super Mario Brothers paper, is it based on?
Yeah, so that's how this all started actually as a conversation at AID last year, where the Super Mario Brothers. So we have a couple different ones. Super Mario is represented multiple times in here, but so it started with like that. I have my Super Mario version format. Sam had his. They have their own. So yeah, I've used my Super Mario Brothers. The Legend of Zelda is all the stuff that I had done with it. Yeah, so it has been. There are papers that have used it so far. But is that the only question, or?
Yeah, that's the question. I'm
Yeah.
excited that you've done all this work for us.
Oh, no problem. glad to help. I wanted to do this mostly as like a service to the community because it felt like there's a lot of people reinventing the wheel of going through and annotating Mario again and again, and hopefully no one has to do that again, or hopefully soon no one will have to do that again. So thank you. Oh, yep, sorry. Yep.
Thanks, man. Green light still on? Yep. Looks good. And that can just go on your tag. Yeah. It's finally useful.
This thing could also probably not. Do you want like a clicker?
If you've got one, that'd be great. Someone stole mine. Not anybody here, sorry, just to clarify. Put it back. There we go. I've got that. Sweet. Thank you very much. All right. I don't need that. Alrighty. Are we good? Are we live? Should we go? Oh, I'm going to try the clicker in a second, but let's see if... There we go. It does work. That's great. Oh, God, motion sickness already. Hello, welcome. My name's Tommy Thompson. I'm from Anglia-Ruskin University in Cambridge, the other university in Cambridge. I'm also here representing Table Flip Games, which is the indie company that I head up alongside my colleague Matthew Syrett. And this is a talk a little bit about, well, Adam's just went and gave this really nice talk about how he's providing resources for the community. We're just stealing everyone's good ideas and then trying to put them in a commercial product. So sorry, guys, I didn't mean to do it in such a fashion, but that's how it's turned out. So we're talking about kind of phase one of a little game that I started working on called Sure Footing. And the idea was we were really interested in trying to manage, generative scale. Like this notion that, certainly when everything started out, procedural generation is great. We can have all the content, we can do all the things, it'll scale amazingly. Players can have as much experience as they want. We'll have 20 million levels. It's going to be, no, not really. Thankfully, things have matured since then. But one of the things that we were really interested in was how, when you're doing this sort of thing, how can you ensure validity of content, the quality of content, and how much of that is managed at a designer level, and then how much of it you can leave within the confines of a artificially or computationally intelligent system to do the rest. So, when I'm talking about validity and quantity, when you're dealing with kind of passive interactive content, this quality can be variable. What you're seeing here is a bunch of guns from Gearbox's Borderlands series, which can generate, I think it was something like 4 million guns, if I remember it, something along those lines. Though the general consensus is that while it could generate 4 million guns, 99.99999% of them are crap. And the core game loop is actually about trying to find that tiny little proportion of guns that are actually really useful. But the way that game works is that it's built around this promise of good content eventually, so you can get away with having bad content. But ultimately, that content is still scaling because the guns that are being made are always a reflection roughly of where you are in terms of your gameplay journey, what level you are, maybe even where you are in the world and what story mission you're in the middle of trying to conduct. We see, issues of quality and scale are actually far more critical, though, when you're dealing with elements of the game which are kind of absolutely critical to its execution, such as levels. So there's kind of two opposing ideas here, one of which is the far left is Mossmouth Spelunky, And that's actually using a bunch of design-driven templates, which are then configured in appropriate sections. They know that there will be an element of consistency in terms of the content that's being generated, and then they actually add some rules to then add and remove parts of those levels as things go on. But you can also look at it from a far more computationally intelligent-driven approach, and the image on the far right is from mini dungeons, which Antonius has been working on. And one of the big parts of that is using player metrics and then being influenced by aspects of that player's performance and how you can use that to then guide that player's experience. So what we were thinking was generated content should always scale as the player progresses. And as we scale it upwards, we want it to reflect the challenges that the player should be facing, and the overall difficulty of the current experience should be going up. But we're trying to maintain a reasonable level at which that's going to increase. And we wanted, wow, you know what, let's talk about budget. What if we were to constrain essentially the expressive range of the generative system, as Gillian's spoken before about the notion of expressive range of a procedural generator. What if we try and impose the limit on it, and then we can actually dictate when it's allowed to grow over time? And so we thought, oh, you know what, let's apply this to an infinite runner. This will take 6 months, and you know, no problems. The knock-on effect is actually because we decided to make a game around it as well. So 6 months became 18. And it became a little game that we call Sure Footing. And it's an infinite runner, if you're not familiar with the genre. It's a series of platforming games where the idea is that you have a continual forward motion, and that the game will actually continue to expand the longer you survive. Ultimately, you have to then avoid all sorts of obstacles that come your way. And this is just an ideal avenue for any pseudo-random generation, procedural generation, because we can't have authors sitting trying to make large expanses of content, because we don't know whether or not the player will ever reach the content that you build, but also they could actually surpass it, and then what's going to come after that. So these are some kind of famous examples in sort of current day from Clockwise. We've got Cannibalt, which is still, in many respects, the template for the two-dimensional approach, but then we also have the over-the-shoulder method, which is Spider-Man Unlimited here, and also Tempo Run, and Jetpack Joyride, which is also probably these are pretty much just the 4 infinite runners I play. But there's many others in this genre, because it's quite popular. So it's all, like I said, it's all about trying to make sure that you have these systems in the world, because our game, like any other, you start off with an empty world, there's nothing in it, you tell it where to go, and boom, it should actually be creating some content. Now, I did have some video, but it's a bit broken, so provided we actually have some time, I will actually play the game on the machine, because I've got a nice build with me. But I wanted to talk about how we got to this, and really what's influenced us to make a game that's Mario-esque, but not Mario. So I think I've already spoiled what some of the answers are in the coming slides. In fact, one of the first things we looked at was Gillian Smith's Launchpad work dating back to 2009. And it was this notion of rhythm-driven generation. It was actually running on context-specific grammars, this grammar-driven method. But it tied into something else that I've also been working on with, for example, Becky Lavender, who published some work on, she actually demoed work on Legend of Zelda here last year, about decoupling function from construction. So what we were interested in doing is having this notion of grammars, which allow us to express how the world works and how what kind of experience we want players to have, versus the reality of then how you actually build that. So you do it in a 2-phase process. And this, as we're going to see, we've got our framework in place, but it allows us a much larger range of opportunities moving forward, which is quite exciting. But also, there you go, the obligatory Mario slide for any PCG talk. We were really interested in this kind of new phase that's going on in Mario research, which I often refer to as reverse engineering the Mario method, whether it's Steve Dalskog's work, which was in understanding how design patterns and how we can actually express particular aspects on a both micro and a macro level of how a Mario level works. And then subsequently, this has been pushed on ever more. Both Adam Summerville, but also Matthew Gusdile have been continuing on in a more machine learning driven approach to then start to, essentially, if we can look at enough Mario games over time, sooner or later we should be able to converge and actually have a model that allows us to express what Mario looks like. So we decided to take some of these concepts and apply them in our own game so that I could get to stand here and say this isn't a Mario paper. It's just, well, it is, but. So this whole principle, like I said, it's about budget-constrained level generation. So I'm going to give a quick overview of how the system works. And some of the very first generators we have written, to actually clarify, this is work that's about 9 months old. And I'll talk a little bit about some of the stuff we're doing now and actually the current spate of generators that we've got. Currently sitting in my version of the game that I call the Branch of Doom, because it's always broken, and then only whenever 6 months after I'm finally happy it works does it finally get transferred into the trunk branch, and then everything breaks, and all the designers go, what's going on? As everyone else plays the game, and they're like, what have you done? I'm like, seriously, my job's great. So the principle is that we take a slice of what's happening in the game at any particular point in time, we get an understanding of the player's progress, and we pass this into our action generator system. Now, the action generator understands that there's a series of actions that we kind of want players to have, in terms of these are actually design patterns that we've encoded within the game, but also then have a collection of different action generator grammars, which allow us to interpret that world in different ways. And we show 4, I'll discuss 4 in this paper. I now have about 12? 9 in code, 3 more still on paper, because I ran out of time on the train on the way here. But then subsequently, once we've established what our action sequence is, what is it we want the players to do for this next fixed segment, we will then try and pass this to our geometry generator and ask it, turn this into a playable experience. Actually put this into a series of platforms in a nicely arranged fashion, and we have coins and obstacles in the way that then is actually something worth playing. And this is actually being derived also from a lot of game assets that our art team has been developing. And boom, just punt it straight into the game and away you go. So the action generator process is, we have these generative grammars where we have terminal symbols that are indicative of the action that we want a player to have. Now, when I say an action, I'm talking about things like just a flat run. Maybe you're going to run up a set of stairs. Maybe you're going to run up a ramp, run down a ramp, fall down somewhere. Maybe we're going to give you the opportunity to split off into one of 2 paths. So ultimately, these are all kind of design pattern ideas of kind of traditional platforming tropes. Sometimes it'll be a little bit more exaggerated, that maybe it's a spring. Maybe we've got an opportunity for you to reach a higher point, and you have to progress to that higher point by hitting a spring, which will shoot you up in the air. Now, each grammar that we have then allows us to set their own production rules and non-terminal symbols. So in essence, what I'm explaining is that we want to be able to dictate how you can go from an empty string to this fully iterated set of actions, because every action generator interprets the world in its own unique and wonderful way. And the budget that we're using, we actually said we have this budget system that each action actually has its own cost attributed to it. So it's actually a constraint optimization problem, as the system has to figure out how many actions it can get with the amount of budget that it's got. And certain actions will only be available to it once a certain threshold in the budget has been achieved, because otherwise it can't ensure that there will actually be a certain amount of actions to actually make the gameplay playable. So to give an idea, here's 2 of the examples that I put in the paper. The first one is pretty much random, the safe random grammar as we call it. What's happening here is that it's able to turn this into anything it wants, so it's using a run. It's going to have springs, stairs up, stairs down, taking ramps. But there's actually 1 or 2 particular instances here where it corresponds to the A, where actually we're dictating a very specific rule that we don't want you to follow up with, so for example, in the safe random, we don't want you to then do a spring, which shoots a player up very high, and it's quite a fast thing to do. The first time it happens to you, it kind of throws you off. And then to move into a hopscotch activity, because that's a very large number of jumps within a very short period of time. So we can enforce this and say, well, actually, in this instance, when you've done a spring, you will automatically do a run and then something else. So we always make sure that they have that extra moment to breathe. And conversely, we've got something such as the height intensity grammar. I realize now I should have actually put the table of what all these symbols mean. I do apologize. This actually is split up into 2 phases, the gain and the fall phase. The height intensity, what it's doing is it's actually calculating the delta on the y in terms of your progress, and that will suggest whether or not it's becoming more intense. So it's actually creating a literal wave. And you can see that when this generator actually works, and I zoom it out in the game sequence, it creates this massive wave effect, because the player it's assuming that it's going to become more intense the higher up the player is going, and then it will reach a certain cut-off point, and it decides to then go into the fall sequence, and it will then fall back down. Now that action generator then decides at what point is the cutoff. It figures out how much budget it's got, and it says this is how much I'm going to allocate to the gain sequence, and then this is how much I'm going to allocate to the fall sequence. But to the other two papers, the other two generators we have in this in the paper, one that's purely random, so it just lets you do whatever you like. But another one which is an intensity grammar, which is actually using the intensity metric that Gillian Smith came up with for the modeling expressive range of a generator. And it creates a sort of Left 4 Dead style director in the sense that it's actually trying to figure out what are the most intense actions, and then once it's really stressed you out a little bit, it then eases off into letting you do flat runs or falling down kind of ramps or falling down stairs because that's not as intense. Once you've got that, we then translate that action sequence into what we call a sprint. And we actually separate sprints by short streets, which allow the player a little moment of respite. And we're just interpreting those actions into our own model in the kind of separate geometry generator. Now, the budget, once again, the budgets for the geometry generator are always driven by the budgets of the action generator. The game dictates the budget to the action generator, and then the geometry generator always has a minimum budget of the cheapest interpretation of that action sequence. But we can actually have them independent of one another. So there is a lower bound that's been exhibited on the geometry generator's budget with respect to the action generator. We only put one geometry generator into this particular build for this paper, although I'm going to talk a little bit about some of the ones we're doing right now. And this was actually design driven. We sat down as a team and we started sketching out ideas of, so this is actually this is a two-path pattern that we've established. So you have two options of how to navigate a particular fixed segment of play. How would I go about doing that? What's an interesting way to do that? And we started coming up with a lot of different interpretations of how to achieve that kind of fixed segment of play. You'll cross this in less than 5 seconds. It's a very fast game. You'll run through it really quickly. But then the other thing was, well, how expensive do we think that is? So the very first iteration was a very much allowing us as designers to enforce how this game should work. Because particularly when you're trying to show it off to people for the first time, you want to make sure that a generative system isn't going too haywire. We thought we'd play it safe to begin with. So these are actually crafted in engine. We use the Unity game engine for sure-footing. And we build these sequences up, and then we decide, oh, well, this is a really cheap one, because this doesn't look too hard. You know, you land on this platform, you'll run across. If you want, you can go up here. There might be some coins that have been spewed out for this particular instance. But then we gradually make it more and more complex. Here, where you've actually got a little bit more of jumping to do. Here, there's actually springs here, here, and here, which will launch you in certain places. One of them is actually a bit of it's a fake. It will actually hurt you. But also, this one here, where we've got, you can join this on either the top or the bottom, but you've then got to navigate this middle sequence here. So they're gradually becoming more difficult to navigate. So as far as our geometry generator was concerned, this particular geometry generator, it will only use these ones if it has sufficient budget to actually pull that off. One of the things that's actually been really important for us in terms of this as well is that you see that we reuse a lot of existing art assets, the certain crane platforms, and also these kind of long ones and this kind of shorter blue ones. Part of this is because that when you're working in this infinite runner experience, we don't want the sequences that are coming up in front of the player to be too alien to them. I mean, ultimately, you want to have that notion of familiarity, albeit, you know, with a little zest, a little bit of something special or something different every time. So, for the purposes of the paper that we've published here, we then assessed a very specific configuration of the system. We were actually focused on whether or not we can show this increase in scale and whether or not it has an influence on any expressivity metrics that we have that allows us to model what's actually happening in the level. So we took the base action generators, random, safe random, intensity, and height intensity, and the one geometry generator we've just explained here, and then we model it in 3 different configurations. One where we always have the exact same action and geometry budget, and we got it to generate about 5,000 levels. So just to see what kind of range are we getting, how is this actually going to be expressed within the kind of expressivity metrics that we're using. Also, if we keep the action budget fixed and gradually increase the geometry budget, are we going to see any variability subsequently in this expression? Because we're now getting it to use different sets of collections of prefabs. The actual space that it's using is going to be different. And lastly, which is actually was more our key focus, was if we keep the geometry budget fixed to its absolute minimum, but we increase the action budget, are we actually then seeing broader and larger interpretations of the game world, which we thought would be kind of cool. So I've just blown up a couple of the graphs from the paper. This is actually when we're running on a fixed action and geometry budget. I think it was about 200 action budgets, so the levels were a reasonable size. And the geometry, no, it was at 50, I can't remember, sorry. But the geometry budget's also fixed. And you can see here that depending on how the action generator is interpreting the world, this is running on linearity and leniency metrics, which Gillian Smith has long battered into our brains for the good of the community, I would say. And you can see here that we're actually beginning to isolate particular pockets of this world depending on what type of action generator I'm using, because my generators have a different interpretation of the world. Now, notably, the safe random and random are remarkably similar to one another. In fact, this one's a bit tighter, which is to be expected, because ultimately I've just said be slightly more constrained than purely random. But when we're having intensity versus also the height intensity, we're actually focusing on very particular areas. Not very lenient gameplay, which is not surprising because it's far more jump-oriented. But yeah, notice how there's suddenly like all this weird expands down the bottom. And again, the linearity, I mean, everything was kind of, this is the thing with the linearity metric, is we kind of expected it never to actually achieve on one extreme or another, because ultimately this is an infinite runner, and we're always going to have this kind of variability in the Y value as you play through it. When you move into having the increased geometry budget, you don't really notice much of a difference until I start moving between the slides. And ultimately what we're seeing here is that the action generator is using exactly the same budget constraints, and I'm only using one geometry generator and tweaking how much resource it has to use. Sorry, I went ahead. But we're getting a tiny amount of variation here. Now, I'm not surprised that the variation isn't huge. That's because the geometry generator at that point when I was working on this paper had had the least amount of work. God, I really want to show you what we're doing now, but I can't. But then if we move on a little bit to when you have the geometry budget fixed, but you increase the action budget from the lowest minimum that we have, I think, which is about 10, up to about 200, you're seeing that it's actually beginning to spread out a little bit more over time, because we're giving it more and more resource to work with, and then subsequently it's kind of gradually dragging itself out. And you're going to see that again in a different set of metrics in a far more explicit fashion. Another set of metrics that we used was also length and verticality. What is the actual length of the level, as well as the kind of Y delta that we're dealing with. Random and safe random on the fixed. You know, ultimately these are pretty much what I would expect. Height intensity is interesting because it kind of levels out. Because like I said, it's a roller coaster, so it goes up and it comes back. So you tend to find the variations very small because it ends up roughly on the Y level about the exact same place it started. The intensity, on the other hand, the sprint lengths tend to be very long because it focuses on these long, kind of really high intensity sequences of jumping, which we deliberately put in there to kind of keep players on edge. Again, when you increase the geometry budget, there's not much variation going on there. Oh, whoops. Again, not much variation, but a little bit. Once again, hopefully we'll talk about that another time. But when you look at it purely from the action budget perspective, you see that there's this massive increase that's taking place over time. So it's originally actually bottled up quite heavily in the corner here. You can see these reds, which suggest a large amount of generated content. But as we begin to increase that action budget, it's beginning to slowly bleed itself out. The levels are becoming longer. The verticality is also beginning to, well, in some cases, it starts out really high, and then it begins to taper in. But we're ultimately really happy with this because it suggested to us that we're actually scaling, at least in terms of the physical length of that particular instance, we're scaling it through the use of that budget-driven system. So to quickly wrap up and talk about what we're working on now, we're continuing the analysis of this data set because in the paper I only used 4 metrics. I've actually, at the time I ran this experiment, I also used another 4. At the moment, I actually have now embedded about another 5, and we have them running whenever the system is making levels. So every time it makes a new level, we actually get a profile about what that level was and get a little bit of information about how it adheres to these metrics. Hopefully, we'll do another paper on that soon. Now, one of the things that's really interesting about this is that now that we have all these, this budget, but we also have a certain amount of configuration in terms of what do you start with, but also how does those budgets increase over time. But also the thing is with these action generators and the geometry generators, I can turn them on and off. Every time a player finishes a sprint, I can tell it to swap out because we decoupled how this system works. I say throw in a new action generator, take the current one out, put in a new geometry generator. This actually allows for difficulty settings. I can create very simple levels that effectively young children can play, but also perhaps people who really have difficulty playing these sorts of games. I can also crank this game up and it becomes insanely difficult for perhaps, hardcore players. And I find this really interesting. So we've been looking a little bit now at preference learning because this gives us this opportunity to essentially not only allow for people some vanilla difficulty settings to work on, but whether we can give them a base game and the game actually continues to shape itself over time and it says, right, I figured out roughly what your skill level is. I'm going to give you a little bit to challenge yourself, but we can then seed the generative system with a particular set of parameters to do that, which is really cool because I love this idea of having this game sort of accessible and still entertaining to everyone. Another thing that we're working on is validation playthroughs, that if we have, say, an editing tool that allows you to then build another level in front of you, can I then validate whether or not that level is playable? This is the obligatory, someone has to say Monte Carlo tree search somewhere in a procedural generation workshop. So we're working on our MCTS bots and FHEA bots right now to see if we can actually get a little bit of validation going on, and it gives us an indication of, based on how you're configuring your MCTS bot, whether or not the player is going to be able to complete that based on their perceived skill level. Long-term work, some other stuff that the other thing I actually forgot to mention is slide prior. Geometry generators, we currently have about 4 more in development, 2 genetic algorithm-based approaches where we're actually using the prefabs but allowing for variability. One of the things I didn't mention is we have 4 playable characters. Each of the characters has their own speeds, acceleration, jump strengths, and also they actually are more powerful using certain power-ups within the game than others. So we wanted to see whether or not we can then have it tailor itself based upon the particular character you're playing as. So the same gameplay sequence will look slightly different when you play as, for example, Blip, who's a tiny character who couldn't jump very high, versus Plunk, who's our sort of Hulk-like character and can jump very long, large bounds. Also, we've been looking at using genetic algorithms with cellular automata and L systems, and then having essentially a grammar built within a geometry generator, which is drawing primitive shapes. And I was so close to having a playable version of that to show today. But some long-term stuff. We're looking at player loadout recommendation. At the moment, we have 4 characters, 9 power-ups, 10 buffs, and 10 costumes, each with their own attributes which influence the game. Could you actually predict a good combination for a player based upon their skill set? But again, I want to come back to this idea of bad level design and how we can extrapolate whether a generated pattern is good, also using human data rather than just being reliant upon an AI. And that's it. Thank you. Now, one thing I do want to mention, I'm going to quickly show the game, and I'll take questions from anyone. I think I've still got about 5 minutes, is that right? One of the things we do want to mention is that this has been, what was meant to be a 6-month project has then turned into an 18-month project as we actually started working on it as a game. And we're kind of looking at how to move forward with it. So I'm really pleased to announce Sugarpudding will actually launch next month. In HIO, in the refinery, in early access.
3.
What does this mean? It means it's not done.
2.
But it's getting there. One of the things we want to do is scale the game up so that we are, first of all, turning on our online facilities. The game has online leaderboards, online player profiles. We're also going to be having daily and weekly challenges, which are all procedurally generated, by the way, which also does weird game mutators. That's next year's talk, I promise. We've also been looking at how we can start running experiments with our player community. We actually have a lot of people who've came to play our game over the last year or so, and we still get a lot of people interested. So we're going to launch on itch.io, and one of the things we're going to be doing is running experiments with our player community. Once the servers are actually up and running properly, we're still working on that part. But ultimately, we want to be able to run player feedback experiments with the community and get their feedback, not just from academics who are going, oh, cool, do me a favor and play my Mario level generator, please, which I think everyone here has done that at one point or another. We wanted to give it to our community of people who are interested, and we've got adults, we've got kids who like playing our game, and we want to get them a chance, kids with the parents' permission, of course, with the parents' permission, and give them an opportunity to try out the game, and then we can learn something from people who actually play these sorts of games rather than just the same 20 or 30 academics who are all working on generative AI stuff. But yeah, I'll have a little build later on for people to play today. It's terribly broken because we've been so busy. But in the meantime, if you want to learn more about it, please keep an eye out on Twitter at Tableflip Games and Surefooting Game. And so exciting! We're finally going to launch the blasted thing. But yes, does anyone have a question while I decide to play it?
Tommy, can you make sure to repeat people's questions?
Yes, I will do.
Thanks.
Everyone is bludgeoned. Yes, sir.
Have you looked into the influence of the screen size of what the player can see? Imagine having a more elongated, wider screen with a big influence.
The answer is no, but that's a very, very good point. One of the things that is interesting is that, like you say, you're dealing with this very fixed frame. You're playing a two-dimensional game versus a 2D game, so you don't have that notion of long-term depth. One of the things that would be interesting to note is whether or not the player, how the player is actually seeing the world. One of the things that's happening, I'll show you in a second, is that we have 3 different camera angles that the player can view the world from, and one of them is reactive. It actually zooms the world out based upon the delta Y, because we were suddenly concerned that you're so high up in there you can't actually see anything that's going on. Let Deletion Dave do his work. All right, let's go. So as you can see here, I can't actually see a large amount of the world straight away. I can shift the camera angle if I want, and that's actually quite an interesting idea to explore, is how players perform, there we go, based on what angle they're using. Oh, generator's not quite kicked in there yet. But also you can actually just look solely behind you, which is kind of like this kind of weird kamikaze approach to playing this game, I guess. Woo! Antonius.
Hi. So I had a question about the action generator. It creates, first of all, the actions are a low-level representation of the level. And
Yes.
then you interpret it into geometry.
Yes.
It's basically more of a geometry interpreter.
Yeah, so we have sort of a design pattern collection, which it will then select which ones it thinks are appropriate, and then, oh God, sorry, I'm trying to multitask here, and it's incredibly difficult. And then trying to figure out how to then translate that particular set of design patterns into a playable sequence.
Okay, and are the actions just one string of pearls, or do you actually take multiple paths into it?
Now, multiple paths actually is something we have been looking into doing. I've been working on this for a little while now, because if you have multiple paths, when do you stop a particular path? Do you actually let a path trail out? One of the things I've been mucking around with was the notion that you'll have 2 paths that actually fork out, and based upon whichever one that the player took, you then just terminate the other path. I died because I wasn't paying attention. I'll just kill that. But yeah, that's something I've been looking into at the moment. One of the other things we were looking at is that we're focusing on single player at the moment. We actually have a 4-player multiplayer mode. And one of the things we were looking at is if you have it split screen and then you give 4 paths, we then have to generate these paths and ensure that they also ultimately converge back to a single point at some point, because that's when it gets fun, because each of the characters can bump into each other, they can smack each other around and stuff like that. So.
Actually, you'll need to design, sorry.
Yeah, take it out. Thank you.
So, oh, yep. You need this, sir.
Tommy, you can bring that for the demo chapter, right?
Yeah, we'll show you game talk at 5 o'clock. Let me get the little dongle.
Yep.
Oh, thanks. You need it? Yeah. Thank you. Sorry, I think there's it's like this. We'll probably let you go next.
Take a look.
Maybe, is it on?
No. No.
It isn't on.
Okay. Ah,
Yeah,
look at
there
that
you go.
magic.
All right. Make sure you introduce yourself. Thanks.
Okay, no worries. Hello everyone, my name's Andrew Pech. Today I'll be presenting to you my associate's paper, Identifying Attributes for Characterizing Game Area Types in Virtual Terrain. So during this presentation I'll introduce to you the problem of not having a standard set of metrics which can characterize known level design elements, and then how we attempted to address this problem. I'll cover some of the related work, which is mostly just current terrain generation programs which incorporate some form of level design. Then I'll describe what isovist are, since this was a large part of our research, and many of you probably don't know what they are already. And then I'll cover the metrics which we use to characterize some known game area types, and the experiments we conducted to validate how effective they were at this. Then, of course, quick summary and time for questions. So, I mean, you all know that procedural content generation is pretty big at the moment. Still rare to find a PCG technique which generates three-dimensional game levels which incorporate a large range of level design elements. So we think that the main reason behind this is because there isn't a standard set of metrics which can characterize these elements. So we attempt to address this problem by using isovists. So isovists are a common technique used in architecture for space analysis. From an isovist, we can get a set of measures which characterize the visible space from a given point. And we use these isovist metrics along with some graph connectivity metrics to characterize some known game area types, and I'll be demonstrating to you their effectiveness at this by showing some results from some classification experiments which we conducted. So related work, as I said, some work has been done in incorporating level design into virtual terrains. For example, Olsen used a combination of Voronoi diagrams, pink noise, and an erosion algorithm to generate terrains for real-time strategy maps. This technique had a few adjustable parameters to influence how much flat area the terrain had for placement of buildings and that kind of thing. Freyd et al. Used a genetic algorithm to generate terrain programs. Terrain program is, well, a program which generates terrains. The idea was that the genetic algorithm would find a terrain program which could consistently generate random terrains that had a large amount of flat area for their character to run around on. Another technique introduced by Tegelius et al. Used a multi-objective evolutionary algorithm to generate real-time strategy maps. This approach considered a number of design elements, including optimal positioning of player bases and resources, and even map symmetry. And the last approach I'll quickly cover is introduced by Smelek et al., who proposed a framework for maintaining designer-specified constraints during the generation of virtual worlds. So, for example, a designer could specify a constraint, such as a line of sight constraint between 2 points, and then as the virtual world got generated or edited, this constraint would be maintained. So, although some work has been done towards incorporating, level design into virtual terrains, there's still so many elements out there which, receive little to virtually no attention in the literature. So, for example, Hullett and Whitehead described 10 common first-person shooter level design elements, such as sniper locations, arenas, strongholds, hidden areas, choke points, flanking routes, galleries, vehicle sections, split levels, and turrets. Generally, every first-person shooter level will contain some subset of these elements, and yet it's rare to find PCG techniques which include them. So, as I said, we attempt to address this by using isovist, which is defined as a set of all points visible from a given vantage point in space with respect to an environment. They were originally defined by Benedict in 1979, and if you'd like to sort of visualize what an isovist is, I think his diagram does it best. So here you've got 3 top-down views of a room layout, and you've got a point in the room, which would be the isovist origin, and the shaded grey area is the visible space from that point. So as you can see, as the room layout changes, you can see how the visible space from that point changes. Isovists are commonly represented as a set of radials, which are really just vectors. They all originate from the isovist position, and they expand outwards in all directions. The magnitude of each radial is equal to the distance between the isovist origin and the nearest occluding obstacle along that radial's direction. And if there are no occluding obstacles, then the magnitude is set to a maximum view distance. So I've got this image over here to help, help demonstrate what isovist would look like. here you can see that the yellow lines are all the radials. You can see that some of them are reaching a maximum view distance along here, while others are hitting occluding obstacles like this wall. So from an isovist, we can actually extract we extract 12 measures. They're listed in that table to the far left. These measures include things like the isovist volume, so just the amount of visible space from its origin, the minimum, maximum, and average radial lengths, and even the isovist sphericality, which is how well the isovist volume approximates a sphere. Aside from these isovist metrics, we also use 4 graph connectivity metrics, including degree, betweenness, closeness, and centrality measures. And it's these total of 16 values we actually use to characterize an area within a virtual terrain. To give an idea of how we do this, we've got this top-down view of a virtual terrain here. It's actually a player-made game from the video game Savage. And we have then superimposed this graph on top of it to show you the physical layout of the level, where each green sphere is a node in the graph, and each node in the graph corresponds to an area within the level. And the areas in the level are connected by these paths that lead between them. So to get these measures from a particular area, it's easy enough to calculate the centrality measures for a node in a graph. For the isovist measures, we simply just generate an isovist from the center of a desired area. Then we can calculate the measures from that. And that is what we did to generate our data set. So our data set contains 70 points, 70 data points, where each data point was simply a collection of those 16 measures. Each data point corresponded to a particular area type, so either a hidden area, an open area, a vantage point, a choke point, or a stronghold. And these data points were, the areas that we used to get this data from were manually identified from player-made Savage levels based on descriptions given by Hullett and Whitehead. So, with our data set, we actually fed it into 3 different types of classifiers: a J48 decision tree, naive Bayes probabilistic classifier, and multi-layer perceptron, which is an artificial neural network. And then we used 10-fold cross-validation to get some reliable classification accuracy ratings to give us an indication of how well these metrics actually can characterize these area types. Our results were not too bad. None of the classifiers really outperformed any of the others, but they all received an accuracy, or obtained an accuracy rating of between 82 and 85%. On this slide, I've actually included the confusion matrices from each of these experiments. So you can see the diagonal cells in the matrices contain the correctly classified instances, which is where the majority of the values are, which is a good thing. One thing that we noticed when we were actually looking at the results is that some areas quite commonly got misclassified as specific other area type. For example, our open areas, whenever they got misclassified, they were only ever misclassified as strongholds. And strongholds were, whenever they got misclassified, were only ever misclassified as open areas. This was not, completely unexpected, because these 2 area types actually do share some physical properties. In fact, many area types share similar properties. So, for example, if you were to get a particular area in a terrain, it might even be suitable as a number of different area types, not just one optimal area type. So it's kind of unrealistic to expect that you will get perfect classification accuracy with a task like this, but personal opinion is that a misclassification would not be catastrophically incorrect either. So just to summarize, currently there's no real set list of metrics which is used to characterize game area types or level design elements. So we've just taken a step towards trying to fill this gap by defining our own set of metrics and showing the potential of these metrics by showing you guys the results from our classification experiments. And, well, that's all. Quick presentation. Any questions?
So which of your
Okay, we actually did have a list. I think we published it in the paper. The most important one, working from memory here, I think might have been area size, or might have been the area size, which is sort of the sort of flat traversable section of the area. It's not the actual, it's not the amount of visible space, but it's the amount of traversable space in that area. I can definitely tell you that some of the least influential attributes were the minimum and maximum radial lengths. They seem fairly constant since our isovis were always placed a set distance above the ground, so the minimum isovis radial is generally going to be from that point to the ground. And of course, open sky is all above, so always reach the maximum radial length of, maximum view distance for the maximum radial length. Hope that answered your question.
On the classification matrices, it might be interesting if you could have like a likelihood estimate.
Okay.
So that you would know, like, oh, it's 60% stronghold, 40% open area.
Okay.
Then this classification is not as strange as saying like 99%.
Yeah, actually, since writing this paper, we've been using a probabilistic neural network to classify things, simply because it does give you an estimate of how close it is to each of these area types. Useful in things like genetic algorithms, where you kind of want to know, is it heading in the right direction or not?
Yeah. And how does it work?
How does that classifier work? Yeah. Or how well?
What quality does that?
Actually, it's doing well. It classifies them at about 91% accuracy generally. Yeah, but it works a little bit differently than your standard thing, because I like to normalize my data points using z-scores. And to do that, every time you look at a particular point, you actually compare it, how far it is away from each of your known data points for, say, how close is it to a hidden area? You get all your known hidden areas, get distance values to each of those hidden areas, and you find out, generally how close it is. So every time it's being compared to a particular area type, I actually have to normalize it using the standard deviation values for all the hidden areas. And then when I'm comparing it to the open areas, I have to re-normalize it using the standard deviation values of all the open areas, which is different than most probabilistic neural networks work. But aside from that, it's just a standard PNN.
Some probably naive questions about the isovis method. What happens, for example, if you have a circular room with a pillar in the middle, or another room in the middle?
Okay, where would the isovis be placed in?
Yeah.
Like in the center?
Yeah.
If the isovis is placed in the center, you're only going to, geez, I don't know how to answer this question properly. If the isovis is placed in the center, it's not going to reach the edges of your circular room, because you've got a sphere, like you've got a cylinder around it. So it's only going to reach the walls of the cylinder. And that's
but that isn't a practical problem with the method in your case, right?
No, it's not a problem that we would come across in in our experiments, because we're not using rooms. We don't have objects in our rooms. It's just terrain.
So, final follow-up question to this. This comes from architecture, and probably assuming it's humans viewing a room and how it functions. In a game, you can have other possibilities. You can have different sizes, for example, but you can have different abilities, and the environment might be very important. If you have a circular room without anything in the middle, but you have a ring of lava around you,
Okay, yep.
that would give the same measures as one without lava, right? Because it doesn't matter
Yeah.
what you hit, right?
Yes, that's true. So you'll notice, for example, Hullett and Whitehead describe a whole bunch of elements.
Yeah.
We can currently, with this method, only characterize sort of certain room types, like arenas and strongholds. Things like vehicle sections, there are obviously elements that this won't be able to work out. how's it supposed to work out whether it's the section that a vehicle is supposed to run across, for example, you know? So yeah, it can't do everything, you know, just trying to step towards it there.
Have you any ideas of how you need to modify this simple architecture to work in space games?
Not yet, no, sorry.
What happens with caves and dungeons?
Caves and dungeons? Haven't done any experiments with caves and dungeons. The only thing that we've so I haven't really given it much thought, can tell you that some of the attributes that we've got here, as I said earlier, you know, at least significant attributes like our minimum and maximum radial lengths may become more important in indoor environments.
Yeah, exactly. Yeah.
But that's as much thought as we've given it, so I can't really. Sorry.
I first just wanted to say this was really interesting. I'd never come across Isovis before. It's really useful. I've got a question from the stream which says, is this generally an offline approach, or have you tried using like real time or on the fly kind of, is it fast enough for that kind of thing?
We haven't tried it in any online approaches. We've only tried it for evolving terrains using genetic algorithms, too slow for real-time approaches. Isovis themselves can be generated, you know, fairly quickly though. We have created a sort of a real-time tool where you could actually have an Isovis in your virtual terrain. You can move it around. You can see how the Isovis adjusts, radials hitting, you know, new occluding obstacles and stuff as you move it around. So Isovis can be calculated fast enough for real time. All depends on how you utilize them, I guess.
So some of these things, like flanking paths, for example, it seems like they depend on a functional relationship between several spaces. You can't actually just start in one space.
Yes, I know, which is why we didn't include them in our.
But I guess you could define like a structure of several isovists, for example, in this case.
Yep. So there is this people who created the game supervisor for training people working on oil rigs, and they did something like that. We actually did like a uniform grid of Isovis, and they could create like heat maps for various properties of the Isovis over the entire area. So things like that is definitely possible. I'm really hoping that people definitely think about doing something more complex like that, but we just haven't got around to it with our research at this point. Oh.
When can you use 2D isovists and when can you use 3D isovists? Like in this work, did you try 2D? Did it work? Or?
Originally we did 2D, yeah. Kind of thinking back to it a bit now, where our 2D Isovis basically just, the radials just went in a flat plane along the X and Z axis. It just seemed 3D Isovis was the next logical step. 2D Isovis is probably very useful for 2D level designs, 2D environments though. Don't really have a lot to say on that.
But in these environments, they're kind of, they are 3D environments, but you're basically operating on a 2D plane, right? There's no heights or anything like that.
There are actually. In these virtual terrains, you do have different heights. For example, vantage points. Don't have any in here, in this particular level, but yeah, we do, where vantage points sort of look down over areas, so we do work on multiple heights.
Have you looked at how many rays you need to cast from your sort of central point for your Isovis to be useful? To do like how little work do I have to do to get an Isovis? I'm really lazy.
Geez, I don't have any numbers with me, but we have done work like that, mostly with calculating the volume of the Isovis, because naturally we want to get quite an accurate, volume of it. So we did a bunch of experiments estimating the volume based on the length of the radials. And we use 1024. Of course, the more you go, the better. I couldn't really tell you what a good minimum number is, but that's the minimum number we chose for ours. We thought that was a fairly good one.
Thanks.
Oh, sorry. You had a question?
So I have a question. You actually checked player-made maps with these Isovis, etc. How could you generate terrain using these Isovis? I'm just afraid that it will just try to create one huge area because you're trying to maximize area size or things like that.
Okay. The way that we have worked on generating these terrains is we evolve a graph like this one here, where you do have area size and that kind of thing, and we actually modify the terrain. So if we've got an area placed here and it's this large, we flatten out the terrain there and try smoothing it out so it doesn't look too unnatural. And paths, same deal with the paths between the areas. And then we generate an isomorph at each area location, and then we compare them to, we see whether they match our desired areas that we're looking for in our terrain.
Okay, so there's a range of valuable, valid area sizes.
Yeah, well,
Right.
yeah.
Just wondering if the amount of rays you're shooting can be performance problem, and if you considered any way of parallelizing these. Skin that on GPU, for example, very easily.
So you're asking whether we've considered optimizing it by parallelizing the ray casting?
And possibly with that shoot a lot more, if needed.
No, we always talk about maybe looking into what sections of this approach we can, run in parallel. But no, we haven't done any work in it. We use the Unity engine for this, so we use the Unity's physics engine for ray casting. Don't know what they do, but looking at your face, it's obviously not very good.
Nothing wrong with it.
Okay.
It's not the fastest thing on Earth, but if it's just wondering if that's an issue or not, if you would need to make it
If you needed to make it faster, definitely I don't see any reason why it wouldn't be why you couldn't make it parallel. Okay, well done.
All right, we have a coffee break. Again, if you want to sign up for a lightning talk, 3 minutes talk, we'll do them after the next papers.
Replugging. That normally works, right?
Cool. Hi everyone. Mike, do you need...
That is the wrong title.
Alright, while Mark is teaching the title.
Fascinating.
Great, we have 2 talks on languages. Got a couple people signed up for landing talks. Sure we'll
Fantastic.
Alright.
Cool, thank you. So, hi all. Before I give this talk, I need to explain something, which is that on the train here last night, some complete bastard spilled water on my laptop, so all the keys are now fried. So I had to go out and buy a new keyboard, and as such, all these slides had to be basically typed between a broken keyboard and a working keyboard this morning. And therefore, some of the slides, I don't really know what they are, so we get to discover them together. So that should be tremendously exciting, I think. Okay, so this talk is something about procedural languages, and that's me. And basically this talk is about the game I make in my spare time and how it creates languages and how those then create sentences kind of within sort of broader sets of how a certain culture should speak. And I will basically talk about the game first and then talk about those 5 things. And seeing as this talk is slightly more haphazard than I would like, feel free to kind of ask things throughout, so it's a more kind of back and forth thing than a sort of didactic lecturing thing. Okay, so this is the game I make. I've been making this for about 5 years now, since I started my PhD, since clearly I needed more than one big project in my life at the same time. And it's basically a kind of classic roguelike-ish game, except it has 3 goals, of which only the first is kind of very roguelike standard. So the 3 goals are 1, that, 2, that, which is kind of the focus of this talk, I guess, and also to kind of explore PCG graphics using ASCII and ANSI and to see what we can do with that. And number 2 is the focus of this talk. So extremely quickly, this is what the game looks like. So when you start the game, it makes a world, and these are the kind of different nations of each world, and it PCGs the flags based on the kind of nation it is. And then if we zoom in further on the kind of little black spots on the map, which I'm not sure if you can see, then we get things like cities, which are the thing on the left, and a town in the top right, and a fortress in the bottom right. And then if we zoom in further, every single bit of that is a building. So in the top left is a religious building, then next in the middle is a hospital, then a cathedral in the top right, then that's a mint in the middle left, a parliament building in the bottom left, I think, and a mansion in the bottom right. And all of these have architectural styles which are PCG'd by the game at World Gen, and then every building within each nation looks not the same, but kind of similar-ish, so that you should be able to tell which nation you're in based on the buildings you see. And then if we zoom in further, so every single character there is also an item, and the look of every single item is also PCG'd. So we have things like clothing, chairs, altars, vases, tombs, blah, 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 etc., etc., I mean. And then also people, so we have PCG ASCII faces and clothing styles, and then there are some people in the bottom left walking around a cathedral. Okay, so right now I'm working on 4 kind of big things within the game, which are these things, and all of these should be completely finished by the end of the next academic year, I guess. But the focus of this talk clearly is the third one of these, which is PCG Dialects. And this is not quite, that's cool. And by this I don't mean languages, which I suspect is what the next talk's on. I mean kind of ways of speaking within English that mark out different cultures as being different from each other. So why did I do this? Basically, I have a real kind of issue with games which have NPCs who just repeat phrases, and this is a screenshot from The Elder Scrolls Oblivion, and for those who played this, you will know that every guard across the entire world just speaks in the precise same way and with the same tone and with the same voice actor, and when you ask for rumors, they say the same rumors and so forth, and that I think at least is very immersion breaking. And so the idea was here to create people who are varied based on where they are from. So if you get someone from a desert nation versus a kind of polar nation, then they shouldn't speak the same because they are from different lands, of course. And also, I'm not a computer scientist at all. I'm a social scientist who sometimes sneaks into CS conferences and workshops to give talks about this game. And so the idea here was to kind of combine social theory and game design in some cool and new ways, hopefully, and to see what came out of that. And then the final part is that this shouldn't just be background to what the player does. This should be in some way kind of linked in with gameplay and meaningful, and that it matters rather than being kind of background reading like, say, the books in the Elder Scrolls series. And also that final point is that it's quite new and fresh and different, and therefore by default is worth doing. At least that's how I think about it. So firstly, the game's most kind of simple part of this is that it chooses letters and it chooses blocks of letters to use in each word for each language. And clearly a lot of PCG games do this. I think Dwarf Fortress does this. I'm sure that lots of others do as well. And so you get something that looks like this. So for each nation is each row, and so it chooses a bunch of letters and also a bunch of syllables, and then each name for something within that culture, which are the ones listed on the right, should look kind of samey enough so that if you see a name that you've never seen, if you know that PCG world well enough, you should be able to look at that name and say, I think this person's probably from this culture, or from this one, or from this land, or this culture, and so forth. And then, but then from that, things get much more new and complex, I think. So one thing I wanted to do was that how people speak should reflect their backgrounds. So people should always speak in kind of references which make sense based on their cultural background. So the game for each nation, it looks at the geography of that land in terms of its climate, whether it has mountains, oceans, rivers, volcanoes, plants, animals, blah, blah, blah. And then also in terms of history, so quite like Dwarf Fortress, the game creates a huge chunk of PCG history, and what people say will be based on the history of their culture. So if two people from two cultures speak about war, for instance, then they will draw a reference from the wars of their nation rather than a kind of random war. And then the third thing is religion. So those are some PCG religious altars. And so there's a bunch of, there's something like 60 billion religions that the game can make, I think. And each of these will then impact what people say. So if someone from a very from a very zealous nation wishes you a good day, then they might give you kind of blessings from their god. And then lastly, houses as well. So, and this is where it gets slightly Game of Thronesy, but mainly because I wanted to see if you could PCG sigils, and you can. And so here, a lot of people of kind of high rank belong to some kind of noble family house, and that will also bias what they say to you. And so the idea here, and these are some examples, is that basically everything that someone says should in some way be tied to the religious, cultural, blah, blah, blah background of their nation. So the first one is a pretty strong insult, I think. The second is a kind of comment based on that nation's religion, but also based on its climate. The third one is a kind of history thing. The fourth is also history. The fifth is kind of history plus art plus a kind of very strong compliment to the player. And the sixth is a deeply, deeply insulting comment about the nation of Icarit, who are presumably awful Philistines. And then linked to that is kind of different sets of name creation for each in-game culture. So the system creates, so it PCGs a kind of naming archetype, and then within that archetype it PCGs each name. So the idea here, much with the rest of this, is that this should act kind of like a clue, so that when the player learns how a certain nation names its people, when you encounter someone and then they say, my name is X, then you should kind of know where they are most likely to be from. So here's a bunch of names that the game came up with. So it came up with the way of making these names, and then it came up with the names within that kind of model. So the ones in the top left are sort of Homeric-esque names. The ones at the top are quite kind of plants and creatures and these sorts of things. The ones in the top right are 3 words of decreasing length with the same first letter. The one in the middle left is for a kind of very sort of outward-looking expansionist, sort of plains steppe kind of nation. The one in the middle is a kind of Icelandic-ish naming style. The one on the right is a kind of Native American-esque naming style. The one on the bottom left is kind of 3 short blocks with similar-ish letters. The one in the middle bottom is whatever it is. And the one on the bottom right is for a very kind of isolationist-y, defensive-y nation who really don't like outsiders. And then also the game comes up with insults and greetings and farewells and compliments for each nation based on the culture, religion, blah, blah, blah of that nation. So in the left column, we'll see a bunch of greetings. In the kind of middle left column, those are farewells, I think. And then the middle right column are compliments. And then the middle and the far right columns are the insults. And one thing I wanted to do with these is that, of course, what to one person is an insult might be a compliment to someone else in a different culture. So if someone from a very kind of imperialist nation says, you're a pacifist, but that person's from a very peaceful nation, they'll say, oh, thank you, rather than being hurt by this. So there's a kind of a lot, so a lot of these things kind of store a lot of data beneath the hood so that it can check if something that should be an insult will be perceived as being a nice thing, and so forth. And then also there's a kind of cross-cutting aspect, which I've called sentence complexity, which is basically how kind of wordy people from different cultures are. And the idea here was to just kind of further boost how cultures vary, but also to add a kind of gameplay strategic choice. So if you say only have time to visit 2 lands, and in one land you have people who are extremely wordy and will therefore kind of implicitly tell you a lot of stuff, but their items are really pricey, whereas the other land people speak in very short lines, but they have really, really cheap items, then you kind of balance off, is it more crucial to get the info or to get the cheap items? So here's an example. So that's the kind of most basic form of that sentence. And then they could say that. Or if they are a slightly more wordy nation, they could say that. Or they could say that. Or they could say that, which is a really lengthy one, and so on and so forth. And so basically every single thing that people can say, and there's something like 2,000 default sentences, every single sentence is then further modulated based on how wordy the person saying this thing is, to result in, I don't know how many sentences because it's not worth working out, but a pretty gigantic number. So here are some examples, and these I just put in this morning. I grabbed some screenshots off my blog, so hopefully these are in a sense a sane order, but if they're not, I take no blame whatsoever, blame the man on the train. So this is basically what the conversation window looks like. So we have 2 people, and you choose what group of speech options you want, and then the different colors mean how well you can say that in the dialect that you are currently trying to speak in. So you can basically try to fake where you're from by trying to speak in someone else's dialect, but if you struggle, then they will spot you and think that you're a disgusting liar. So this big list, I think, is the list about political questions, and then I think in the screenshot I flick over to the list about past life, and so that's kind of where were you born, who were your parents, etc. And then the third list is the religious questions list. So that's like who do you worship, what is your holy book, etc., etc. And then when you click enter in the middle, it converts the kind of default question into how that culture would say that question, and then says it to the other person. And so if it's green, then you can say it. If it's red, you can't. And if it's somewhere in the middle, then it rolls a die. And if it comes up badly, then you don't say it. And if it comes up well, then you can say it. So the more green, the better. So what's this next GIF? Let's find out. Fantastic, yes. So this GIF shows that also, because of how much there's in the world, a lot of the conversation kind of options can become extremely big, basically, in that if you click on the art option, every single piece of in-game art you can ask people about. And therefore, if you've seen 200 paintings, then you have a list of 200 options to scroll through, and that's just pure agony. So instead, you can just type in letters, and then it'll search for which things that you can say fit those letters. So in this GIF, this just shows us changing dialect. So we started speaking one, and then I go onto the dialect option, which is there, and then wind up speaking a different dialect at the end. And so in going back to the same list of options, which in this case is to do with military things, I think the green and red chances of each thing have changed because you are now speaking in a different dialect. Then this is not a GIF, amazing. So this slide and the next slide show two kind of extreme ends of how the speech system looks. So this guy on the right is from a very, very wordy nation. So on the first comment, he says kind of greetings from our wise people, and we are a great and powerful nation, blah blah blah. And then in the second one, he talks about he kind of gives a very sort of lengthy detail about a certain place that the player has asked him about. And then in the third one, he talks about a certain person who lives there. And then if I, the player character on the left, if I then ask someone from a different culture the exact same set of questions, they just say that. And then there's a kind of whole spectrum in the middle there as well, of course. But then this brought up a kind of weird question, which is that there's something like 200 default options that you can ask, and kind of a lot of options which grow as you learn more about the world. So ask them about artwork X will grow as you learn more artworks and so forth. And so the thing is here, the players like to play games as well as they can, of course, and if that means choosing every kind of speech choice so that you get as much data from someone as you can, then that quickly gets dull because every single person in the game you should ask every single option to, and so on. And so instead there's a system whereby basically people get bored of speaking to you pretty quickly unless you speak to them about things which are meaningful or make sense or flow or have some kind of sense to them. And so the idea here was, again, to make this kind of less of a background lore aspect and more of a kind of gameplay aspect whereby you have to meaningfully think about what you're asking someone based on their status, their culture, their religion, blah, 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 in order to make sure that they still want to speak to you and give you the kind of info that you want to get from them. And also then, so how does the player learn these? A bunch of ways. So firstly, when you hear someone say a certain sentence in a certain dialect, then you can then say that because you've heard it, and so you can just kind of parrot it back. Also, you can learn things through books. So a PCG book might be called that, and if you find it, it'll let you speak on all those topics within that culture. Events as well. So if you go to certain in-game events, then it will kind of note that you were there, and then give you a body of stuff that you can say based on that in-game event. And so the idea here was that there should be lots of methods. They shouldn't be kind of grindy. They shouldn't be essential in that you don't have to fake where you are from and kind of speak other people's ways of speaking, but it can help. And then this is the slide, as it says at the bottom, I wrote 10 minutes ago. So also I realized that conversation can feel very kind of stilted and not human in lots of PCG games. If you play Dwarf Fortress, for instance, a lot of the conversations there, no one, even in Tolkien, speaks like that, basically. And so I thought, so there's a bunch of things here, and I'm kind of still working on this a little bit. But people will say, I'm not sure, let me think, let me cast my mind back, etc. People will also use kind of different things like exclamation marks and full and dots based on how they feel. And then also words with kind of specific values and specific kind of positive or negative connotations. The game will switch in based on how the person thinks about you and how they think about the topic that you're talking about, and also how much people are willing to tell you, and also etc. So two examples of this. Damn, these in the wrong order. Okay, so this was a really bad one. So I felt that the kind of dialogue here was so kind of stilted and very kind of exposition-y-ish, and the people don't really speak like this at all. But then I changed it, and so we now have something more like this, where people make passing comments and they tell you stories, and they use exclamation marks, which we all do in language, I'm told, and these sorts of things. And so I think this is a far more kind of real form of language, even if there's some kind of almost meaningless content in there, in the reading, has no gameplay meaning, it still makes the language feel far more real, and it takes you a tenth of 1 second, and so I think that's fine. So basically, to conclude, the game aims to be the most detailed in all those forms game ever made, and I hope that this will happen. And right now, kind of PCG dialects and the sentences created from them are a pretty big part of this. And they are unique to each culture, and they vary, and they can be learned by the player character and also identified by the player, hopefully. And the aim here is both to kind of increase the sort of social and cultural variation of in-game worlds rather than having every single person speak the same way, and also to have some kind of real gameplay impact in terms of how you make choices, in terms of how you learn about people and progress through the world and so forth. Thanks for listening. I have.
A lot about the thing you made, but I'm not going to make that thing. So what lesson do I have to learn from what you've done?
I think the lessons to learn is that, I guess there's several. I think one is that this kind of detail doesn't have to be just detail, and that you can structure your game so that world building kind of matters in a gameplay sense, basically. And there's not really a lot of games that do that, and I think it's good to know that is something you can do. I think the second is that a lot of games do struggle with language mechanics, I guess, in terms of how do you make learning a language meaningful / intriguing / non-grindy. And that if we look at something like what's the Final Fantasy game with the language where transposed letters? Final Fantasy X, I think, yeah. So that is just atrocious in my view, and that is just the worst conceivable way that you could do this, because since it's just a substitution cipher basically. And I think this kind of thing shows, and maybe the next talk will kind of build on this too, is that you can have in-game languages which have kind of gameplay meaning and are not either trivial or completely obtuse, but are kind of somewhere in the middle. So I think those are the two big things. And also, I guess on a kind of broader note, is that sometimes when you try bizarre things, they turn out quite well. That's a very interesting question, and a few people are smiling because they know what my answer to this will be. Because I don't have a computer science background, when people ask me questions like that, I sort of have no idea what the hell to say, because to me, when a CS person asks me a question, they say, so Mark, did you use a bilateral transient floating point meta array? I have no conception of whether I did or not. So basically, I really can't answer that question all that well. There's basically just a lot of templates, a lot of variation, a lot of stuff that goes through, a lot of kind of filters and layers to add content, take it out, a lot of stuff that checks grammar, a lot of stuff that makes sure that like commas and full stops make sense and in the right places, a lot of stuff which checks gender of the speakers, plurals, their, your, his, her, etc. Yeah, that's the best answer I can give, I'm afraid, to that one. Go for it. I'm ready.
So I really like that you're saying that yes, it should influence the gameplay and so on. But now it seems like it's a nice to have in your design now, and you put a lot of work into it. So I'm wondering, have you considered kind of refocusing what is the gameplay to fit what you're developing here? Because it seems like you have a system which would be great for having to play spies or thieves infiltrating things, doing heists, or being a doppelganger, have to infiltrate many different. There's a lot of those things you could do which would really focus on this.
I mean, that is kind of what I'm doing, yeah. In that it's an optional component of gameplay, but if you want to try and pursue the game's goals by faking your way through cultures, then that's something that the game encourages is maybe too strong, but kind of gently pushes the player towards as being an option. So I don't see it as being kind of tangential to gameplay. I see it as more like games where you can use melee or magic. This is more like the magic option, basically.
And I would agree that would be really nice in a finished game.
Mm.
So, but for your research purposes,
Mm.
to see how people use it
Mm.
and like it, it might be better to force them to use it more.
Yes.
Check.
Well, this basically has nothing to do with my research at all, since it's purely a kind of hobbyist project at this point, at least, in that I'm a social scientist and my work has got nothing to do with this, basically. So, all of my academic employment postdoc work has nothing to do with this. So, I think it will be interesting to see what people say, and I do enjoy that kind of process of seeing people play your game when they don't know it, and you kind of see what they kind of make sense of and how they go through things and so forth. But if someone wants to use it for research purposes, let me know. But I will not, in fact, be doing research using the system.
How does a player learn a new dialect?
If you hear people say a sentence in that one, then you learn that sentence. If you read books on certain topics, then you learn all the topics that book is on in that dialect. And also, if you learn a sentence within a certain group, then you also get a little bit of learning on others within that group. So if you learn how big is your army, then you learn, say, 0.2 more on asking where is your army currently campaigning, say. So kind of each block of sentence options fills up slowly as you speak to people from that culture, or quickly as you go to a certain place or read a certain book or talk to a certain person on a certain topic. It's definitely something that will need a lot of balancing as time goes by to make sure it's kind of not too fast and not too slow and so forth. But right now, at least, that's basically how. And you start off knowing your own, obviously, and depending on the nation you start in, you might start off knowing the way of speaking of a kind of nearby nation. But that's it.
And can you understand all dialects?
Yes, all people speak English, but they speak English in different ways. So it's more like a kind of trade language almost that different people speak in different ways. Julian. Sorry.
I just want to. I think I know the answers, but I just want to.
Sure.
You say like they learn that sentence, like they learn like the meaning of that sentence, or literally like these are words that can go in this order.
Number 2.
Okay, so they don't know what that sentence actually means.
Well, every sentence spoken is in English, so you always know what it means because it makes sense.
Yeah, but I was just wondering, like, dialectically, it might mean, like, that for one culture, as you said, like, it might mean one thing, and for another culture, it might mean something else. So, like,
Excuse me.
do you actually know, like, the full meaning of
Gotcha.
that culture, or do you understand just, like, these words?
You understand the meaning it has for that culture, but you can't guarantee the meaning that sentence said by someone of that culture will have for a different culture.
Okay.
Yeah.
So when you fail saying something, do you actually see the fail?
Yes. It goes red rather than kind of white or brown, and
you don't get like a badly, because you don't see a badly constructed sentence.
no, not yet. Basically, because this version's been in development for 15 months, and I just want to get it out and done finally, and then kind of go back and tweak it a bit. So right now, when you fail to say a sentence in another dialect, it just says it in your home one. But in the future, it will kind of garble it and mess it up, and then they'll say, "Well, that makes no sense." Yeah.
So we have a demo session at 5 later. It'd be pretty cool. I don't know if you'd be available to show us.
Certainly. Though it is an in-build version, or a not ready to release version, so if it crashes and destroys everything, I take no blame.
I've wondered if it is easier for people to, let's say, imagine the use of your name generation, language generation, dialect generation in a game, if it comes with some connection to existing cultures. Like when you showed the page with let's say name building stuff, for example, there were these Icelandic name schemes or Native American name schemes. What is your opinion about that?
Sure.
Is it better to use images that really exist?
I've very specifically tried to make sure that that doesn't happen. So you might find name forms within the game that do look kind of like real world ones, but they should be different enough that you wouldn't say, okay, this is exactly this. Basically because I guess the kind of generated world has a lot of very unpleasant nations, a lot of unpleasant people, quite like Game of Thrones again, and there's a lot of, sort of nations that are racist in some way or sexist in some way and so forth, and so I didn't want to risk basically people reading in real world things that aren't there, basically was my concern, in that in an earlier version, the game did once create the kind of British Empire perfectly, in terms of the flag, a tiny island, a huge empire, naval power, blah, 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 and that was cool and interesting in the sense of I'm glad I've made a system which can do this in this kind of detail. But at the same time, I thought, you know, that's a nation that a lot of people, for clear reasons, have strong feelings about, and I wanted to basically sever the virtual nations from any kind of real world nations or cultures and so forth. So there's in fact now a system where I've coded in what I think the game would represent certain controversial countries and nations as, and if it creates a nation that's too much like them, it wipes it out and creates a new one to make sure that can't happen. All right, thanks guys. I could indeed.
Nice job.
Thank you.
I have one more question I'd like to ask.
Yeah, go for it.
Do you have any thoughts on if someone wanted to do this for Spanish or German or French or some other language?
Yeah.
Is there any?
Someone did ask if I was going to translate this game into German, and although I do speak a bit of German, that seems like an absolute nightmare of the highest order to me, because it would require me to basically rewrite every single sentence generation line of code, and life is just too short. So basically the answer is it could be done, but it would need someone with more time or less perceived value on their time than me to do that. Sorry, I need to unfurl this. I need
Did you take out the?
I did, yes.
Okay. You have your own.
Yeah, I got HDMI.
Yeah.
Cool. Good to go?
Yeah.
Mic check, am I good? Mic check. Okay. All right, I'm James Ryan. I'm at the University of California, Santa Cruz, Expressive Intelligence Studio. And this paper is called Diegetically Grounded Evolution of Gameworld Languages. So in some respects, it's quite similar to what Mark just presented, but it's actually quite different. It's kind of interesting to see how this session shapes up in the end. So a lot of games have game world languages. Here I mean fictional languages spoken by characters in the game's story world. Some examples of this are the Hylian in The Legend of Zelda: The Wind Waker. So this is sort of not central to gameplay at all, light world building essentially with this language. This is what the Simlish language actually looks like. For some reason it has like a runic orthography, which doesn't fit. But I think when we think of the Sims, we most often think of this iconic language, which sort of expresses in icons what characters are seeing and thinking. This language is a cool design move because the language itself is very central to gameplay, sort of like what we were just talking about with Mark's talk. Another game that has a language that's central to gameplay is Myst. So this is the Deny language, and it's actually central to some of the puzzles in the game. And then like a really beyond example, even beyond what Mark just presented, is Chris Crawford's Trust and Betrayal: Legacy of Saboot. So that's a super ambitious 1987 Macintosh game where you construct, using an iconic modular language, sort of like meaning representations that are understood by the NPCs. So you should check this out if you haven't heard of it. But this is an example of a game where the language like is the interface to the game. It's like utterly central to gameplay. World of Warcraft does a cool thing where there's these like languages or whatever in the world, but it actually hinders communication between characters that are in different factions using this narrative conceit that they speak different languages. So this idea of like hindering communication, I'll come back to later in the talk. So many games have game world languages. Few people have tried to procedurally generate them. So when I was writing this paper, I couldn't find like hardly anything. So it's kind of hilarious that we have like a session devoted to this now. Maybe it's like this new wave, but few projects have attempted to procedurally generate languages. Even Dwarf Fortress doesn't procedurally generate or alter its languages at runtime. I think they're actually pre-constructed in data, so I don't think it's even like a recombination thing. So if Dwarf Fortress isn't generating it, I guess yeah, part of this talk doesn't make sense now, given the first talk, but very few projects have looked at generating languages. And that's the focus of this talk and this paper. This is a short paper, so it's sort of preliminary work on this project. And to be clear, this has much different design aims than what Mark's doing. So rather than dealing in the surface level expression of a language, this is about evolving a family tree of languages across a game world, across centuries of game time. So it's sort of this like higher level of modeling, and it's a higher level of like language as a phenomenon, and therefore there's a higher level abstraction. And I particularly use a vectorial representation. So languages look like this in the game, not surface level stuff like what we just saw in Mark's talk. Another sort of aspect of this project that's at play is that I'm operationalizing linguistic theories, particularly theories from sociolinguistics about how language changes. So my undergraduate degree is actually in linguistics, so this project's kind of a labor of love into some of the stuff I thought was the coolest during that period of my academic life. So there's a particular theory, William Lebov's incrementation model, that's the major influence, and I'll explain that in a moment. So this language evolution procedure is played out in a game that I'm developing called Islanders. So like its cousin Talk of the Town, Islanders is a dwarf-like, meaning a game in the mold of Dwarf Fortress, heavy simulation, world generation preceding gameplay. I actually think, I don't know where Mark went, I actually think roguelike's not an apt term for these kind of games anymore with the heavy simulation, like it's different enough. So I use the term dwarf-like. So this is what an Islanders game world will look like. This is a terrain generator, some output that I have from a terrain generator that I built, but I haven't, I built that after I built the stuff that I'm talking about today. So I have to connect those up. Currently, the game worlds look, sorry, I've got some latency on this or something. They look like this. So it's this sort of big blue sea about the size of the Atlantic Ocean, and each yellow rectangle represents an island. So on each island, there's a number of dots here that are specific homes that agents have built. Red ones people live in, and black ones are empty. So if you sort of zoom in on a cluster, see if I can click and, okay, I'm gonna switch over to that. If you look at one of these clusters, that's a settlement. So sort of like very low fidelity graphics. I'm making ASCII art look like No Man's Sky or something. But that's not a goal here. Eventually it kind of is with the terrain generation. So agents kind of live out lives, low fidelity lives in this world. Before gameplay, I simulate several centuries of game time in the mold of Dwarf Fortress and Mark's game. So agents have lived these sort of low fidelity lives. They move about the world. They can move about the island that they live on, start a settlement in the wilderness, move to a new settlement. They form romantic partnerships, which may cause new agents to come into the world. There's some light knowledge propagation. So actually Talk of the Town was a follow-up to an earlier, lighter knowledge propagation system that was in this, if you're familiar with that project. They live, they die, and they do some kind of low fidelity things in the interim. Beyond moving about islands, people can move about the world by seafaring. So the theme of this game is sort of inspired by the Polynesian settlement of the South Pacific, which is like a wild story if you ever want to get in a Wikipedia hole sometime. They settled every island in the area using this like famous seafaring technique in cognitive science. So it's kind of influenced by this sort of stuff thematically. This is a visualization of ship routes that people have taken. So the whiter ones are more ancient in this game world. You can see at the beginning of gameplay, there's a single sailing vessel, lands on a single island. That's where everyone's descended from. So you can sort of see where that island is. Everything's emanating out from there. That's like 500 years, I think, of history here. So like I said earlier, this project's inspired by theories out of linguistics, particularly William Leboeuf's incrementation model. So William Leboeuf's like the most famous sociolinguist. He's my favorite linguist. Just a really cool career about stuff about language change, and even gets into like narrative and stuff like that. So the thrust of the incrementation model is that language changes incrementally with each new generation of speakers. And it happens by a loop that repeats over and over with each new generation. So first, a new generation of speakers is born, and they inherit the language that their parents speak as their parents speak it. And then in adolescence, particularly during their teenage years, they modify that language. They innovate. Largely, these modifications are arbitrary mutations. And these modifications are adapted by, they propagate across peer groups and become solidified in the way that this particular generation speaks. And then toward the, after adolescence, they stop modifying the language and they pass on their modified version of it to their kids, who then repeat, the next generation of speakers, who then repeats that loop. So of course, the modifying part is the coolest part. And like I said earlier, there's like surprising findings that teenagers are the drivers of language change. Particularly teenage girls are the primary drivers of language change. Women and girls modify more than men and boys, but particularly it's this teenage, this adolescent, late adolescence is when languages change. So I'll talk about the method now. Like I said earlier, use a vectorial representation. It's actually a bit array, so it's 1,000 entries, a little bigger. This is 1,000 here. It's a sparse array with some of the bits turned on. The bits stand in for arbitrarily abstract linguistic features that could express in the rules of a language, in its surface representations, in its phonology, orthography, anything. So it's just this sort of abstract representation. And we represent, using this representation scheme, languages and also dialects and idiolects. So all of these three things are examples of what's called a linguistic variety. It's a particular expression of a language. In the case of a language, the speech patterns of all the speakers of it. Dialects, of course, a regional expression of some language. And then an idiolect, that's, if you haven't heard that term, that's how a particular individual speaks. So it's the way that a language expresses in that particular individual. We all have our own idiolects that are actually unique. This is like too much to visualize, so I'm going to use this for the rest of the talk. Assume 1,000 entries here. So everyone's walking around with one of these in their head. This is an idiolect that an agent has. And dialects then correspond to every island and settlement in the game world. So for every language that's spoken in the world, every island that it is spoken on, every settlement that it's spoken in, will have a dialect for that language. Dialects are determined every year by virtue of the idiolects of its speakers in that area. So once a year, you take every speaker of the language that the dialect is of in the region the dialect's associated with, and we build the dialect. We rebuild it every year, simply by taking the majority bit for each entry in the idiolects. For each entry in the dialect, the bit that it takes will be the majority bit given all the entries of the idiolects in the world, in the speakers of that area. And then languages are the same thing. You just don't look at a region, you look at the entire game world. So language acquisition, that's kind of an open question, like how do agents have an idiolect in the first place? The answer is that when an agent is born, we take everyone in the home, say their parents, and simply pick one of these people to have the child inherit their idiolect. So per the incrementation model, this will be the mother if that's applicable. That's another finding from Leboeuf. People speak like their mother early in life. So we represent fluency simply as a floating point between 0 and 1. 1's greater, of course. And as the agent grows and becomes more exposed to the language, they'll become more fluent in it. I use 0.6 as a threshold for proficiency. So when it's like collecting the idiolects to determine dialects and stuff like that, it's only doing it with proficient speakers. And then 1.0 is native level fluency. Another theory out of linguistics is the critical period hypothesis, which states that after puberty, you can never become native in a language. There's just like some weird thing that happens in the brain when puberty ends, and you can never achieve native-like fluency. There's actually like very few exceptions to this, really interesting. And actually, like starting at 9 months, you're getting worse and worse at being able to learn languages. So that's modeled here, where the rate that people can become more fluent in a language decreases as they become older, and it like completely drops off after puberty, and then it really drops off, tailing into the later years. Agents can learn multiple languages, either if they're in the home or they're exposed to them. After age 4, agents go out into their settlements and form social relationships and so forth, and there they can become exposed to more language, and then sort of the same thing happens as if it were in the home. So foreign accents, I said that you can't become fluent in this model past some age, but we also model foreign accents as in the idiolects themselves, in the idiolect representations. So this is done by taking, when an adult learns a new language, that they, as an adult, right, so they cannot become fluent in it. We take the dialect for that language in the place that they're learning it and just start with that, and then take their mother tongue, the language they're most proficient in, and warp 20%, look at all the places where there's a mismatch here, and warp in their idiolect of the new language they're learning the bits there such that they match the mother language. So about 20% of the new language you learn will actually have the bits of your mother tongue as a representation of a foreign accent. And then you get a new idiolect there. And then they'll go on, of course, changing that and so forth. Language deacquisition, so if you are not exposed to a language, you actually lose proficiency in it, even if it was native. So as agents in the world go off to, say, new islands or something, and then are exposed to, are not privy to speakers of their language, they're not exposed to it, they deacquire it. So that's just the fluency level dropping. Okay, so the core of this model is language change. That's the most interesting part. And language change is a twofold process. First, it involves innovation, so mutations in how people speak, and then adoption, which is how those innovations propagate across speaker groups. So in Islanders, innovation happens by an agent simply flipping a bit once a year. And that happens at a certain probability that basically is operationalizing the incrementation model. So you're more likely if you're an adolescent, you're more likely if you're a girl or a woman, and so forth. Adoption then happens by this. We take an agent, this is once a year, it's after that people have mutated their idiolects. You take an agent, for each language that it knows, take that language, look at all of that agent's friends in the settlement. So there's some social simulation, people have friends. And again, this is sort of operationalizing the fact that people propagate change across peer groups. So it's just looking at the person's friends. Takes all of their idiolects, and then for each friend in the town, it determines a power of influence that that friend will have relative to the agent at hand. So this is determined by a couple things. People that are more proficient are more influencing. If the age difference between the two agents is tighter, then the level of influence is going to be greater because people spread innovations across peer groups. So there's some other stuff from the incrementation model that feeds into how these are determined. Now each of these friends is taken one by one, and it looks at all of the bits that don't match up between the two, and using that power of influence as a probability, it flips these bits. So each one in this case would have a 41% chance of flipping. And then it does this for each of these friends and for each agent living in the game world. So after that, you will have potentially adopted changes that propagated to you across your speaker group and particularly your peer groups. The rate of adoption is also, as part of the power of influence, the rate of adoption becomes higher during adolescence. So then after that happens, we reconstitute the dialects by that majority bit thing that I talked about, and then reconstitute the languages in the same way. And this then relates to language birth, because this happening over and over incrementally changes dialects such that ones that are farther apart geographically become more distant in the vector space. And the reason is that people just have arbitrary mutations represented as bits flipping that will like take hold in this settlement, but they're totally arbitrary, so different ones take hold here. And if you don't have speakers crossing between them, they're not going to be bringing those bits that mutated in the different areas. So isolated places grow apart in the real world and in Islanders. So at some point, it becomes more worthwhile to call two different dialects of some language two different languages, because the speakers can't even communicate anymore. They're mutually intelligible. So this happens in Islanders once a year. At the end of the year, this is the last thing. For each language, we look at each of its dialects. And if any dialect differs by more than 25 bits with the language, then we say that that's a new language that is the daughter language of this original one. And over several centuries, you can imagine a sort of phylogenetic tree of the language family in that world emerges. Language death then happens when the last speaker of a language disappears, just like in real life. A lot of languages dying right now. So to briefly recap, agents inherit idiolects from the people in their home. They then go out into their settlements where they will innovate the language during adolescence, propagate changes to people in their peer groups who may adopt those changes in their own idiolects. And at some point they stop innovating, they grow older, and they pass on their modified version of the language to the next generation of speakers. And over several centuries, that just naturally leads to a phylogenetic tree. The languages evolve apart. But what's cool is that this phylogenetic tree is mapped onto the space of the world because there's geographical constraints, because you can't propagate unless you're next to each other. So that's the method. It's pretty simple. It's lightweight. But there's, I want to move toward now talking about the type of playable experience that I want to enable by this work, and this is preliminary still. But I want to kind of thing like what Mark was talking about, where you're going off into different parts of the game world, and the farther apart you get from your linguistic home, the harder it is to communicate with people. One thing that this makes possible, this like primary affordance of this technique, is being able to calculate mutual intelligibility. So any two people, how well can they communicate? And you can simply calculate that as the number of bits that differ between their idiolect. One thing that's cool is that all of the languages, dialects, and idiolects are embedded in the same vector space because they all evolved from that same first language. So you could actually have people that speak different languages, but they're like close enough because they have a common ancestor that people can kind of communicate. So being able to dynamically calculate mutual intelligibility between any two agents in a way that's grounded out in the history of the world. So yeah, one thing I'm thinking here is something like World of Warcraft, where you are dynamically hindering communication. This is kind of what Mark's doing in a way, but here there could be not just different dialects of a language, but different languages and so forth. So one idea, actually, I need to talk with you about this, Adam. Adam and I are doing this project where we're using neural nets to build a natural language understanding engine that takes in player utterances and translates them into meaning representations. But what it spits out is a ranking of the most plausible meaning representations. So one thing you could do here is if people are less intelligible to one another, or if the player is less intelligible to an NPC, you could choose less plausible meaning representations. And you just know how far down you need to go based on the number of bits that differ between their idiolects. So here the NLU thing's like performing worse than it can, but that represents this sort of hindered communication in the game world. Another thing you could do is use the vectors to actually generate surface level constructed languages, Konglangs. So here the vectors would be like a genetic sequence that maps to something that to traits that express in the surface level or rules of a language. So here you need like many more bits than 1,000. So you wouldn't want like a single bit flip to take out gendered pronouns in a language or something like that. For that, you want like many bits so that it doesn't happen often. And then you, for many linguistic features, you need more than 2 possibilities that it can express, right? So then you want multiple bits just to represent that feature. So that would be like a really ambitious project, but that would be super cool. One thing you could actually do is maybe generate something like what the languages are in Mark's thing, where like these bits represent sentence complexity or something like that, or these bits represent the other sort of parameters in his model. And then when you get farther away in the world, like more related languages, in my method will have closer vectors, right, because they're in that vector space evolving, but then they would actually express in more similar things because they have the same mapping scheme. That would be cool. Actually, I didn't think of that sort of middle ground of fidgeting with English with different parameters, which I really like about that project. Maybe the most obvious and promising thing afterward is to evolve socio-cultural concerns that aren't language, beyond language. So one thing is like you have all these bits and it's kind of cool, it's like this abstract thing of a language, but like it's a nightmare if you want to have that actually express in a surface level language. Like what is that mapping scheme? You know, the last thing I talked about would be super ambitious. But what if the bits stood in for things that were like easy to express, like cultural tenets or things like that? And then you could just have them evolve sort of in the same way, where it's probably similar. These beliefs sort of change during adolescence. They become solidified as adults. They're inherited by kids, who then modify them, and then so forth. It's probably an incrementation process still. And then here you could look at different theories to operationalize if that's something, or I could. This is me who would probably do this. But that's the talk. Thank you. Yeah.
Thank you, very interesting talk.
Thank you.
Yeah, my first question was going to be what you mean by a specific bit, but I guess you're saying it's an abstract thing.
Yeah.
But it seems also that you're assuming the language is static in size, so it doesn't vary.
It is.
Yeah.
Like all linguists would say, all languages are equally complex.
Yeah, but there might be new words which are invented because you encounter new things, plants, animals, and so on. So you need to increase the vocabulary.
That's true. So definitely vocabularies aren't equal in size. So I see this as an abstraction that represents language in a complexity space. And I think with a mapping scheme, you could get to different lexica, different vocabularies, and things like that. And then you could always make, there is an assumption that, I agree with what you're saying. You could make the bit arrays variable in size. And if you need new bits, you could add them, and then just add zeros for everyone else. You know?
Because it seems like, if you have these populations spreading around.
Yeah, I should be on 300. That's not a VLSA, actually. That's like a magic number.
But no, just to count your objection here. Makes sense because word to back is basically represents individual phrases or words or something, but this represents a complete language.
Yeah, exactly.
Yeah, so it's like
Just like a next thing.
so this probably if 300 is enough for English, an English word, it's a good argument that much more than 300 is needed here.
Right.
So
Yeah.
it's-
I think there's a few up here, but we'll come back down. I think you guys are going to
Have you, I understand for the purposes of your island-based game that people will explore the world quite slowly. Have you experimented with like really fast travel, like modern day and age travel, that you can
that'd be a cool simulation. I think the result would be the language would hardly, it would change a lot, but everyone would speak it in the same way.
Yeah, exactly. We're seeing a wider adoption of English right now.
Right, exactly. Yeah, because then the change propagates across speaker groups, and the speaker group is the world, because everyone is interacting with each other. I think that's what would happen. That'd be fun to try, but I haven't tried that.
Yeah, especially if you evolve over time. Probably gets faster and faster.
Right, yeah. But that would be cool. I hadn't thought of that.
So it's a really interesting system that you've got beside you.
Thank you.
The thing, if you're making it into a game, you need to have a way of playing with that system. And which, to me, I think the problem that I would see is how do I show the dynamics of the system to the player without having them read a lot of bit strings. And
right.
You talked about the con name idea, but obviously that's really hard. Can you think of a way that you would make this system accessible to a player to play with? What would that look like?
So I think the first idea of communication would express distance between languages in a way that doesn't fully express the complexity of the underlying vector space in this case. But I think that could be cool if you had like a dialogue interface that was dynamic to how intelligible you are to NPCs. That would be a trick of like making that actually surface. But
I'm worried that wouldn't show enough of what's going on here. That would just be sort of it gives me a one number distance from this person, whereas this is much richer than that.
right.
I'd like to see some, not just how much of a misunderstanding you've got.
No, I don't think you are. Yeah, there's one thing I tend to do in game in my work is as a player, I want there to be a lot of complexity in the world, and I don't need to understand it all. But I want to know that each thing I do is an expression of that larger complexity. But that's like a huge service problem when you do that kind of thing. So no, I totally agree. I don't have good ideas about that.
Quick follow-up.
Yeah.
In the game you're thinking about, are you thinking about people playing individuals or playing with languages?
Playing individuals is the design.
Okay.
So you're just like, when world generation ends, it looks at all the rooms, and you're going to be born into the world. You're just a player, you're a character in the world with ancestry and stuff. And you can, of course, imagine like a God game version of this. Playing the language, I don't know what that would be, but I like
No, but it would open up accessing this more, right? So,
Right.
Yeah.
Yeah, there's definitely like a God game.
Okay, yeah, thank you very much.
Yeah, no, absolutely. Oh, me too. There's odds up there.
Well, there isn't.
Oh, yeah. Did you win?
Yes.
Oh, yeah. Okay.
Right.
Probably it's going to be way too fiddly with this, so I can just use the microphone on the laptop and people can hear it, they can whatever it is.
So we're going to do some of our lightning talks now. One of the purposes of doing it right before lunch is to help people kind of meet other people that are doing things that are could be interesting, and then when you go for lunch outside here at 1, you can like get in groups. So start. Sure. If you want to plug in, it's fine. We have 4 people signed up, but I think some people might be inspired. We won't have it too hard.
Right, wrong one. Alright. Sorry guys, I actually don't have any research I want to talk to you about, but there's a lot of stuff that are going to happen in the next few months, so I had to note some interesting deadlines because we all have upcoming deadlines. So we're at the PCD workshop, it's August, and I'm going to start from the end. So on 16th of January 2017, there's a deadline for a special issue, in transactions of AI and CI in games, of which a lot of people We're having a special issue on AI-based and AI-assisted game design. So we're looking at either automated or semi-automated mixed initiative design tools. Papers about that. There's a very extensive list of topics that are interesting, most of them related to PCG. It's myself, Jorgen Akakis, Michael Cook, and Simon Coleman. And as I said, the deadline for these papers is on the 16th of January. Now, on 1st of November, we have the deadline for Evo Star papers. We have 2 tracks that are interesting to this community. One is Evo Games, by inspired algorithms and games. You're doing genetic algorithms and games of any sort, either agents, behavior, or PCG. That is going to be an interesting place to send papers. It's in Amsterdam this year, next year. And we're also trying to add more games in the computational intelligence and music, sound, art, and design track, the Evo Musart track, which I'm going to be also chairing next year. And we're interested in more visual qualities of games, oral qualities of games, music in games, generated music, etc., and game content in general. The deadline is that. The site is there. And finally, let me just give a shout out to AID this year, which happens after 10th of October. But before that, we have a 2-day workshop on experimental AI in games. Exile, it's our 3rd year. It's a 2-day workshop where we have the mornings for talks, and then lunch is pizza, and then during the afternoon, we basically have demo sessions, tutorials, and also fun gameplay activities after those are done. So it's a very relaxed workshop. You really need to attend to know how relaxed it is. We don't really plan for anything. And there's already the call for, the accepted papers will come out soon, by tomorrow. And there's also going to be a demo and tutorial proposal. We also support, coming up and talking about your work, but we would like to also have a more structured tutorial session. Again, it's going to be in San Francisco, over there. Website's over there. It's going to be archived by AAAI, and that's pretty much it. Thank you.
Yeah. Okay. Is there is there any way to just show?
It's on PC.
Yeah. That's all I need, basically.
The PC button.
So I've got 3 quick things to show you. One is actual research. He says as he loads up his Twitter page. But basically, my laptop is currently streaming. But if you were at XAG last year, if you were, let me tell you, and that's not going to get any bigger. You might have seen I did a paper about vision. And that was about this stupid blocks world, where I wanted to have, I make procedural generation systems and also like a game design system called Angelina. And I wanted to build a system that had a concept of 3D vision, so it could like plot out vistas and viewpoints and know if the player had seen something. This is the only video I have of this system at the moment, I'm sorry. About a month ago I started work on this new thing, which is extending that work basically, and actually trying to do stuff with it. A friend of mine said that he thought it was a dog walking simulator, looked really nice, and he posts these lovely vines of his dog. So it now is a dog walking simulator. I can show it to you later. It's really early days, but I'm planning to add in all the vision stuff soon, so the system can actually say, okay, this path through the forest is going to take you this way, and then you're going to look out, and it's going to be like a waterfall in the distance, and I know the player's going to, I don't have to like force the player to see it, I just know their eye's going to be drawn towards it. And in the worst case, I'll just have the dog walk up to the bar. So that's like the thing that I've got going on. I'm going to mention this in my talk later, but if you want to talk game development, I'm currently making a game called Rogue Process, which is the thing. Yeah, it's a hacking game. It's an action hacking game where you break into skyscrapers and steal things from it. So this has got a crap load of procedural generation in it. If
if you want to talk to me about that at lunch or later on or anything. The build, it's currently broken. I can show you some older builds, or you can build a broken one, which has its own charm. And finally, I want you all to go to procjam.com/seeds. Procjam is something I'm going to bug you about later, but it's this year, along with the procedural generation jam, we are making a little zine. It's like a family newsletter for the generative community. I would really love it if you as researchers wrote like 800 words about something cool that you've researched, even if it was 5 years ago. And if you don't want to write 800 words, I know you're all busy people, we would just love screenshots of beautiful things that you've done. And all research is beautiful, I'm not saying it has to look like this, that is amazing. We would love screenshots of anything and everything. Generative things, a bit of info about your research. We're going to send this out to as many people as possible, and we just want to give everyone like an update, like I said, like a family Christmas newsletter about. And this is what the community's been doing over the last year, and that community stretches from researchers to artists to academics, and researchers to artists to game developers, and beyond. So procjam.com/seeds. The deadline is like September 15th-ish, and that's it. Yeah,
Yeah. I need. You have that? Yeah, check me out. When I we have 3 minutes. Right. Yeah, so level generation
It's great, we love it.
Long-lived level generation. So basically, in the general video game community, people are thinking that basically, well, building AI for a particular game is all fun and stuff, but we're not really advancing AI. Because what you do, I mean, you know, world's best startup playing box is basically a mess of if-then statements. And the world's best Super Mario Bros. Playing box can only play Super Mario Bros. And so on, and you do very, very, very specific things. You basically do domain engineering, or as we also call it, hacking. So in the general gameplay community, and now in general video game playing, we make it so that we submit a bot that plays not one game, but any game we give to it. So we just thought recently we'd extend this to level generation. So we have this thing called the level generation track of the general video game playing competition. What happens is that we have this description language which describes video games. And it looks like this. Here's the description of the complete game. And here is an ASCII level description. So in the main tracks of the general video game AI competition, you're given games and you have to play them. So what you have to do is submit them to the places. Now in the level generation track, we want to basically tackle the general level generation problem. So you're submitting level generators. Level generators are given descriptions of games, together with a couple of agents to play with it, and you can also supply any of your own agents. And then you have the output levels, and these levels have to be fun for humans. This is what the general video game AI framework really looks like. It actually has like graphics that don't suck that much anymore. This was actually the game description we just saw before. It's sort of pretty easy to whip up a nice game. So currently we have 80 games publicly available, and every time running to make more games publicly available. So it's pretty easy for you get started with this and come up with level generators, see if it can generate levels that are good for all of these 80 games. This, by the way, is an extremely hard problem. It's much, much, much harder than being able to get level generator for one game. So we just ran this competition for the first time with each game, with slides, and more slides. This is the judging frameworks. And we tested the ability to generate these were completely unknown games for the people who different level generators. This is fun. One of you catch butterflies. one read process in New York. Well, looks like this essentially. And the one we did Snowman, which is a puzzle game. So basically, these level generators would have to basically come up with generate levels for games that are extremely different. Some are shooters, some are puzzle games, etc. That could be different gameplay principles. This here you basically just run from something. Anyway, so we have some of the results levels generated by different people here. These are the winner. The winner of this competition had 4 submissions. The winner submitted basically a similar automata based generator. The generated levels that in most cases were unplayable for most games, but at least they looked okay. The Verbrugge is by Amy and Gillian, which also generated levels that look pretty nice in many cases. And I mean, this is a very, very hard problem. We're going to keep running this every year, so I'm just here to introduce you to the beyond level generation, general level generation.
Will this one be locked at lunch?
I don't know. Probably
I'm not too. I mean, I'm sure nothing's going to happen. I don't want to shut the screen down.
Guys, I just wanted to come up with another special issue coming up soon. It's especially on PCG, and it's on the international journal of video game technology. 2 friends of mine. Sorry. This is the journal. This is all video game technology. We set up the special issue recently called their the whole list of topics. Both in more computational intelligence direction as more say graphics and modeling. And these are the deadlines we have. So it was led by Tiago and we are so we are very open to get not workshop records of course, but extended versions of the workshop. As usual, you do need some sort of minimal and personal original material. Okay, that's it. Thank you very much. Really?
As long as it's got an internet.
Oh, that's here.
Yeah, the PC is also HDMI adapter. We have those.
Which one is it?
PC is PC.
I'll pass around the showing. Yeah, so I've been kind of interested. So many of y'all know me. I'm pretty confident. I make a shit ton of generators. The smaller term. So I make a ton of generators. A lot of them are actually pretty good. A lot of them make really interesting stuff. Some of them have overall high quality. Some of them have overall very low quality but interesting high points. So I'm kind of, and I work in a game called Spore, which was also had some really interesting generative stuff. And I'm kind of interested in this question of how do you actually design for infinite content? A lot of the times we like build our big generators, and then once we got a generator, we're like, oh well, we won. We can generate things. It's like no, you don't win at that point. You just have a generator. So there's this kind of thing that I'm exploring recently that's, I'm calling it the paradox of value in infinite PCG, which is the better you can generate something, the lower value it is. It becomes a commodity. It becomes a faucet that you turn on. You don't like name every water drop that comes out of your faucet. If people know David Koch, who is a UC professor who generated really like phenomenally excellent Bach pieces that were indistinguishable from like mid-level Bach, orchestras wouldn't play his pieces while he had the generator running. So he deleted the generator and saved off a number of pieces, and then orchestras would play the pieces. And it's really fascinating as like I have an art history background, and there's a famous essay called something. It's value in the age of mechanical reproduction. It's like yeah. Huh? Yeah, it's like value in the age of mechanical reproduction, something like that. It's like, what do you do once everyone can have a Mona Lisa? Does the Mona Lisa have less value? And strangely, it seems to. So I'm trying to figure out, like, okay, how do I put value back into PCG? I'm exploring a number of different things. So I'll show you one of the generators that I've got. Actually, yeah, so I've been working on, if you actually have to save seeds, so a lot of times when we're like, write papers on the news, we save the seeds, the good stuff, kind of discard the rest. So this idea of curation, that there's a vast quantity of bot ore and we're mining for the bot gold within it. And by taking out one thing and discarding the rest, somehow we say that that thing is more valuable. Like digital stuff is always less valuable than physical stuff, so as soon as you bring stuff into the physical realm, suddenly it gets more valuable. So I've been experimenting with actually printing out some of my digital objects. I've been passing around these scarves at conferences. This is my last one because I was at an earlier AI conference where I was passing them out. But people seemed really excited that there was like a digital thing in the real world. And suddenly, like as I was handling these physical objects, my art became more meaningful, even though these were just like 10 of the top like 100,000. Well, let's say I was watching some TV while I put through the like 1,000 or so seeds. And yeah, suddenly, like, because I printed these out, these 10 seeds had more value. So I think that's kind of an interesting pattern. Somebody pitched an interesting idea that they were thinking about, like, he was also thinking about a similar, like, physicalizing. Oh, so it's time to go. Yeah, anyway, limited edition. He was talking about, like, you have to pick out your seed and you don't get to see what it generates. You just have to, like, commit to that seed and you order that thing. So yeah, it could be interesting. Anyway, asking more about, like, that. Okay. Buy a shirt.
Yeah. Awesome. Lunch is outside, so we won't go far. We'll be back here at 2 o'clock for the
regardless. I want this card.
I mean, not like candy.
Hey.
This or how?
All right, hi everyone. One from Clark, and then we have 2 from Mike. Didn't announce this earlier, but if you're tweeting hashtag PCG16 is the official. You can see that stuff. Anyway, why don't you go ahead and go away?
Okay.
Oh, sorry. I'll give you 10 minutes and then 5 minutes.
Right. Yeah.
Okay.
Yeah. Okay. Thanks. So this is exhaustive exploration strategies for NPCs, and this is work done with my grad student Muntasir Chowdhury, and I'm Clark Verbrugge. Muntasir can't be here today, so you get me. We're from McGill University in Canada. So the idea of this is we're going to explore exhaustive exploration, so multi-exploration here. And I found out that not everyone seems to be aware that this is something interesting and important to do, at least in some game contexts. So I'll give you a little bit of background. So in role-playing games, particularly roguelikes, it's very important that you actually do look everywhere inside the level. You don't have to in every case, but if you're the kind of obsessive player that most people are who play roguelikes, then you want to look at every possible space to make sure you don't miss any treasure, you kill all the monsters and so forth. And in general, to try and eat away at that fog of war so that you can see the entire space. From the other perspective, in terms of generation, if you wanted to build an NPC that would actually walk around, like a guard that would go to every single spot inside there and make sure that they see everything, that's also a place where you might need exhaustive exploration. So in this case, this is 2 guard routes, and they don't actually exhaustively explore in that environment. So if we want to think about exhaustive exploration, there's a couple of questions that come up. How do we guarantee that whatever we do ends up being exhaustive? That is, we see all the possible spaces inside there. Ideally, cheaply and easily, because this can be a very hard theoretical problem if we want to make it one, but we want to make it something somewhat practical for use in a game context. If we do find a way of doing this, is there conditions that make one route better than another route, other than if they're all equally exhaustive? Ideally, of course, we want to be short. We want something optimal. That's usually what we want out of any kind of pathfinding. Also, non-repetitive and interesting might be a property that we might be interested in looking into. So if we want to make sure that a route, a path through there is seeing new things as it goes along, that's not so important for NPCs perhaps, or for guards. But if we want to simulate a player or have an NPC actually lead a player through a place, we don't want to see the same things over and over and over again. And if we start generating these things or trying to figure out how to do these things, maybe there's factors in there that we have to consider as to what might change the quality of the result. So there's a roadmap, a little bit broken, but we'll get there. So you've seen some motivation. Going to go through how we guarantee exhaustiveness. This is going to imply something about creating kinds of tours throughout a game level. Look at some quality metrics, tell you about some of the maps we used, show you some graphs in some experimental results, and then way off in the distance, conclude. So for exhaustiveness, it's actually a very simple idea, and it's, I think, one that's seen before in other contexts. But we're going to leverage an old computational geometry problem, the art gallery theorem, Schwatel's ancient problem from the 1970s, where the idea is you have a simple polygon, 2-dimensional environment, and you want to find the minimum number of cameras that actually fully covers that space. So you want to protect an art gallery with cameras cheaply, right? You assume each one of the cameras a 360-degree view, infinite range. And the basic result, the art gallery theorem, is that for simple polygons of n vertices, floor of n over 3 is sufficient and sometimes necessary. So there's polygons for which you need n over 3, and n over 3 should always be sufficient. And the proof of this is actually the basis by which we're going to build our graph. So I'll tell you about a fifth solution for this that demonstrates that this property is true, or this theorem is true. So here we start off with a simple polygon. The first thing we do is we triangulate it. So we add in all these diagonal edges or internal edges to the polygon to divide it up into little triangles. So that's pretty straightforward to actually do. And then oh good, colors show up. Then the somewhat cooler part, we actually try and color this. That is, we add a color to every vertex inside here, such that no 2 vertices that are joined by an edge, whether it's an internal edge or one of the actual polygonal edges, share the same color. And the neat part of the theorem is, of course, that for triangulated polygons, you can actually do this with exactly 3 colors and guarantee that you can preserve this 3-color ability of it. Now, one thing we notice about this is that if we 3-color this, since triangles have 3 vertices, every triangle has every color as a representative. And if we put a camera at any vertex of a triangle, of course it's convex, we can see everything inside that triangle. So inside here, if we just chose a particular color and we put our cameras on there, we see the entire thing. So over here we might notice that there's 5 blue vertices, 4 red ones, and 4 green ones. So we choose the lowest number. In this case we have a tie, so we could pick either. And I picked green, and there we go. There's our cameras. So all we need to do for this is now to go and visit each camera, and we've guaranteed an exhaustive solution. Right? Okay. So inside here, what we're going to do is we want to make sure this is just an illustration of visiting each camera, which got me to let you use some animation things. So there we go, done. Now we've exhaustively explored the space. Right? So we don't necessarily have to go directly to each camera, we just have to somehow end up at each camera, and then we get an exhaustive exploration. Now there's a few complications to this. Of course, even if we think of just 2D levels or 2D overhead views of game levels, they're rarely actually simple polygons. Usually they have obstacles of some form, which show up as holes inside here. So the aggregate gallery theorem, as I just told you, doesn't actually apply inside here because we can't necessarily 3-color this and so forth. Fortunately, there's an easy fix to that. Sort of standard thing to do. We just carve out conceptually infinitely thin channels from our obstacles out to the exterior, and we're back to a simple polygon. And now we can actually do our coloring and get our camera locations. Now in doing so, we'll notice that we end up with some vertices that have 2 cameras. This is really the same vertex, this is the same vertex, this is the same vertex, and so forth. They actually have 2 cameras on there. If the camera is the same, if it's the same color, we can throw away one, of course. But other than that, otherwise we do end up with a little bit of potential redundancy out of this. Right? So inside here, we'll end up with 1 extra camera, I think, maybe 2 with the greens. So what this gives us is not necessarily an optimal solution. There are going to be some unnecessary cameras inside there, but it is quite easy, very straightforward, and very efficient to actually do. Of course, we need to visit each one of these cameras, right? We need that path, that little orange dot went zooming along. And this is the idea of trying to construct different tours. So we're on to the next step, over the big rock, and off we go. So if we want to construct tours, there's 2 major factors we need to think about. One, we need the path find between the cameras. That's kind of basic stuff. And the other thing we need to do that's slightly harder is we need to figure out the order in which we're going to visit these camera points to make our tour and see what impact that actually has on everything. So for the pathfinding between the cameras, this is just basic pathfinding, so pretty straightforward kind of stuff. Most games, of course, are going to use some flavor of roadmap to do pathing between things, just because it's easier and makes things a little bit more efficient. So we want to try and use a roadmap as well in this context, so take advantage of that and also make sure that we're respecting the behavior of the character inside here that might be using that roadmap. Even in using a roadmap, we have a couple different choices. We can try and look for optimal paths between things. So if we built what's called the shortest path or visibility graph, I haven't seen that used quite so much in games, but anyway, then we can get an optimal pathing between things. Or we could use a heuristic roadmap, so a probabilistic roadmap, or in our case, since we have triangulation anyway, we can just use a triangulation-based roadmap. And I'll show you some quick examples of this. So there's our shortest path visibility graph. This is on a level from Call of Duty. So it doesn't show the vertices inside here, and unfortunately it's a pixelated screenshot, so it looks a little ugly, but those are all the edges. All the green things are edges inside there. So with the visibility graph, we get a lot of, or the shortest path graph, we get a lot of edges, not actually all that many nodes, in fact, inside there. But the idea here is that we connect a starting point and an ending point onto the graph, standard roadmap stuff, and then we do an A-star search or Dijkstra or any kind of pathing, shortest pathing search inside there to get a route from one place to another. And then here's our triangulation-based roadmap on the same graph. A lot less busy, of course, but it also ends up with a lot more edges. There's also a few little gaps between things here. This is from our infinitely thin channels, which meant the triangles didn't connect, so our triangulation roadmap didn't actually do that. We could have joined those, I guess. We didn't. So there's a few artifacts from that, but that's the basic idea of it. All right, so now we can get from one place to another. So now we need to figure out the order in which we're going to actually do that. Now, if we want to do this optimally, we're into a very, very difficult problem. It's basically some flavor of traveling salesman or salesperson trying to get from one place to another, making sure we do this in some optimal kind of manner. Instead, we're going to use a bunch of different heuristics. So we came up with 5 different heuristics here, yes, to try and decide what order we're going to do. So at each point, we're going to say that we've visited so many cameras or so many points inside the graph. Now we need to decide what the next point to actually do is. Well, how should we do that? What's our decision process? So the first one here, the nearest, is the kind of obvious one. It's just a basic greedy approach. we find the closest one, right? So we see which ones we haven't visited, choose the one that's closest in terms of path distance. Euclidean's not so useful in dense environments, and then we just go for that. Sort of dual to that is the idea of looking at the farthest. So rather than choosing the nearest point, we go to the furthest point. That's not going to minimize distance exactly. It's going to kind of make that really bad. But on the other hand, it's not necessarily such a silly idea, because we think that maybe if we want to cover things, if we want to see new things inside a level, then if I go way across a level, I see lots of new things, right? So that's actually potentially an interesting and good way of doing it. And if nothing else, it gives us an idea of the spread between nearest and furthest, right? Or farthest. So it's one you could do. It's not necessarily one you have to do. Right? Slightly better inside here or other kinds of heuristics that try and think a little bit more about the actual coverage that's happening inside here. Nearest non-visible is an easy one to do. The idea here is that rather than going for the nearest, we go for the nearest one that is not actually visible from the current one. So nearest unvisited that is not visible from the current one. And the idea is that that is certainly going to guarantee a change in our visibility. What we see from that point is necessarily going to be different from what we see from our current point, which hopefully will lead to an increase in coverage of some form, rather than a point that might be nearby that sees the same things we already see, if we're unlucky. Right? It's still easy to compute, just using basic line of sight to detect that, so it's still very efficient. We can go a little bit further and start thinking about the actual coverage areas inside here. So maximum union, inside here we start computing visibility polygons, or two-dimensional isovis, as I learned today. But actually building the whole area, not just projecting with, or not projecting with rays inside here. But the idea is that we keep track of how much area we've seen, the subset of the polygon we've actually seen so far. We look at all the other points out there that we haven't visited. We calculate what we can see from each one of those points, and then we see which one increases our current coverage most. So then we aim for that point. And a sort of companion to that one is the maximum union distance, where we think, well, if I have to go way across, or I could go very near for more or less the same thing, I should go for the near one, right? That's going to reduce the amount of distance that I have to travel. So maximum union distance tries to take into account, or strike a balance to some degree, between the travel distance and the amount of coverage increase. So something where you go very far away but don't see very much new, it's going to be rated very low. Something close by where you see lots, it's going to be rated very high inside there. So those are our 5 different heuristics. So let's talk about quality metrics as the next way of doing things. We'd like to measure quality on here in some fashion. So total distance is sort of the obvious thing to do. Shorter is better, usually, maybe not necessarily, right? We looked at furthest as well. But the more interesting one, and the one that actually started off trying to do this research, in fact, was thinking about the reveal rate, which is the rate at which you see new things inside the level. Since the idea being that if we wanted to think about what a human being might do inside here to model a better creature moving around the space, or have someone lead a player around, then we'd like to try and make sure that that path is always kind of interesting along the way. So to try and measure that, the first thing we came up with was this idea of trying to look at the amount of coverage we actually increase at each possible step. So I have a nice little graphic here, a little happy face. So there's our character in our old polygon without the holes, and our 4 cameras inside here. And the idea is here that when we see new things, that is good. When we don't see anything new that we haven't seen before, that's not so good. And we can make this into an actual continuous kind of scale by looking at the amount of extra coverage that we introduce. So as our character moves around, this one I step through, right? Everything's happy. We're seeing new things as we go around. Look at all that new coverage, all sorts of cool things happening, right? Ooh, lots of new stuff, so very happy here. But then as we start moving forward, this one over here, there's not very much difference, right? If I go back and forth, whoops, we can see that there's very little new. We are changing it a lot, but we are not adding on new. We're only adding on that tiny little sliver basically inside there. So maybe that's less fun and less interesting for a player or a character or whatever we want to try and make do exhaustive. So then as we move forward, see a little bit more, see a little bit more. And at this point, now when we move forward towards that camera at the top center there, things are not going to change very much because we've seen all the area that can be seen by that. So that seems like a lot less interesting as far as a movement path goes inside here. So we can start basically modeling the route through here, figuring out how much area we're seeing. Does this make us happy or sad in terms of novelty, right? There we go. Unhappy at the end. That's always true. So in the end, we can produce a graph like this where we can say distance traveled versus percentage of the area covered, or we can do it on an absolute scale, whatever. And the interesting parts inside here, when we go up vertical, that means we're seeing lots of new stuff for very little effort. That's kind of neat. When we go across horizontally, that means we're moving, but we're not seeing anything new, kind of dull, right? So we can build little graphs like this to try and figure out what a tour is actually doing. Now, we're actually going to compute all this visibility stuff. We're computing this with point visibility. So we're going to, at specific points, we're going to calculate what's actually visible inside that, or from that position. That means in order to figure out coverage, we're going to have to do some polygon merging. So there's little algorithmic steps for doing that. There's a lot of other factors we have to start thinking about inside here. We're aiming at camera points because we have this idea that if we visit all the camera points, we've seen all the space, but there's roadmap points inside there. Maybe visiting some of those roadmap points would be a good idea, and then we don't even need to necessarily go for the camera points, right? So towards the end there, we didn't need to actually continue. There's also issues of granularity. If I'm sampling these, if I'm computing visibility at individual points, well, if I compute visibility at more points along the way, along a particular segment, then maybe I see more inside there. And as I go on to the limit of that, then I'm computing weak visibility, which is very expensive. So granularity is a little toggle or a dial you can switch to make it more or less expensive. And other questions like, where do I start inside a level? With a particular game, that might be fixed, but if I'm generating a route for an NPC guard moving around, is it better if they start at the center? Is it better if they start at the edge? Does that change how coverage evolves inside here, or the amount of distance that they need to travel? All right, so here we get to an echo of Adam's talk. We needed maps, right? So the very first thing we had to do is come up with maps. We wanted continuous vector-y kind of maps. We didn't have access to your stuff, so we had to do our own here. So what we did is we found maps online. You can find lots of maps online, images of maps that players have done or assembled or taken out of games. This is from Game Maps. This is for Pillars of Eternity, one of their dungeons. It's an isometric view inside here, but we can take this image and just a trivial kind of process. We put it inside a drawing program, Inkscape in this case. We drew on top of it. Now we get a nice vector polygon, throw away the background image, and we've got our map. Of course, there's a slight complication that this is an isometric view, so we need to do a bit of a correction for that. And we might be missing some bits because of some obstacles and so forth that are too small or hidden behind walls. There's a little bit of fuzziness to this, but at least it gets us a map. So we did some manual heuristic rotation or fixing up of the isometric view, transformation of the isometric view. So in the end, for this, we had 6 maps. We have 3 from Pillars of Eternity because it's kind of a cool game. So we have Raedric's Hold, and we wanted to get a range of interesting things, and we're thinking mostly about roguelike environments, so this is a good example. Demon Manor here was sort of neat because it's actually a multi-level map. It's technically connected by stairs. Here we mimic the stairs by making basically a tube, which has a very similar kind of property in terms of the amount of visibility. As you go along, you start to see more of the upper level and less of the lower level, or vice versa, right? Copperland Catacombs is another one with a kind of weird-looking structure. We also had the Palace of Azima from The Witcher 3, which came from a games website. Call of Duty Crash, which you've seen already, is a first-person shooter with lots of obstacles, places to hide, all those points that are interesting in terms of characterizing maps. And finally, Arkham Asylum, Arkham Mansion, which is a nice big map with big areas inside of it. All right, so overall summary. What we're going to do is we're going to read a level, treat it as a 2D polygon with holes. We're going to solve our art gallery problem or slight variation on it. Then we're going to construct a tour with some of our heuristics. We're going to measure it, evaluate it, figure out whether it's a good tour or a bad tour, and try to figure out some of the characteristics of this. We did do this, by the way, in Unity 3D. We built the full path, the full pipeline inside there, inside Unity 3D. However, for doing lots of experiments, turns out Unity 3D, that's not really one of its strong points. So we did end up, at various points, sending things out to external tools for things like doing polygon merging and so forth, and then bringing it back in. So there's a little bit of fuzzing there. All right, results. So these are graphs, but I'll show you some of the results. This is our sort of matrix of all the different options. We have 2 different kinds of roadmap to consider. We have 5 different kinds of tour heuristic or next point heuristic. We have 3 different ways of choosing where we start inside the level. Do we start at any possible camera point? Do we start at something close to an edge, that's the extreme, or somewhere close to the center? So there's some heuristics there to decide those. Granularity, do we divide up each edge or not? Do we keep each edge inside the roadmap just as it is, or do we try and divide it up into smaller pieces, double or triple divisions? The target, do we want to aim purely at camera nodes, or do we want to consider the roadmap nodes as possible targets as well? And finally, we have our distance versus coverage metric on all our 6 maps. Now, that's a lot of stuff, and we don't have that much time, so I'm not going to tell you about most of it, actually, but I'll tell you about the interesting bits. There's a couple of things that were kind of surprisingly not interesting. Roadmap didn't seem to make much difference. I mean, it makes a difference in terms of the actual path you do and the length of it and so forth, but it didn't change the characteristics of which heuristics did what and how they actually overall performed relative to each other. The starting point adds some noise. We choose which one inside there. It certainly adds a bunch of different noise, but it didn't do anything interesting as far as characteristics. So I'll talk about the other features, only showing you a very small sample. So first of all, with the reveal rate, this was actually one of what we thought was initially cool ideas about it, but it ended up being not quite as cool as we thought it would be. This is actually graphs of our nearest, furthest, nearest non-visible, maximum union distance, rates of distance traveled versus coverage, starting from 2 different cameras on the same map. I think this is Copper Lane Catacombs. And what we see inside here is that there's actually quite a amount of variation, in particular with respect to where the flats and the verticals actually go. And as we started looking at all these different tours inside here, we started to see, well, there isn't really a lot of correlation. There's not a lot inside here where I can say that nearest non-visible always has these very long flats and so forth, except for furthest. Furthest turned out to be probably what many were thinking, that intuitively, not such a brilliant idea after all, right? Basically, because you are going furthest, you get a lot of coverage initially. You front load all the interesting coverage. And then as you go all the other ones, you're just doing lots and lots and lots of redundancy. So it doesn't even fit on the map here because it grows so gradually. So that one turned out to be not so exciting. So mostly we ended up looking at tour distance as the more interesting thing. And here's some violin plots, which look a little weird, but anyway. So here's our tour. This is looking at tour length, and this is specifically for Copper Lane Catacombs. Here's our nearest non-visible, maximum union distance versus actual length inside there, absolute values of length in whatever units they were in. And this is somewhat similar. We get similar results for most of our levels out there. Basically, nearest to nearest non-visible tended to be neck and neck with some extra amount of variance, usually with nearest non-visible. Maximum union would sometimes be better, sometimes a little bit worse, or sometimes a little bit worse, sometimes a little bit better. The clear winner overall, in pretty much all cases, though, was the maximum union distance, which makes some sense, right? It's the one that's actually thinking about how much benefit I get at each point and how to accelerate that. Target set, do we look at camera points or all points inside here? Here we do get an interesting distinction between the ones that look at distance and the ones that actually look at coverage area. Okay? The ones that look at distance, looking at all points is actually a bad idea, whereas the ones that looked at increasing coverage, looking at all points is actually a good idea. And again, that makes some kind of amount of sense, because if we want to increase coverage, then having lots of opportunities to find the best increase in coverage is a good idea. If we're looking at distance, then if we have more opportunities inside here, we're going to tend to go slower increments along the way. We're going to end up making a longer path. So that didn't seem so bad. Granularity, not quite as exciting. We were hoping that we'd see a nice slope inside here, that as you do things, more granularity, you get better results or worse results or something like that. You do end up with a fairly tiered approach inside here. So you see in many cases, like here for maximum union, with regular granularity we do this. As soon as we go to double, we get much better, but going to triple really doesn't buy us much more. So we tended to see these sort of strata show up in this case. And furthest is actually being shown there. It shows the same kind of result. So finally, we get to conclusions, almost on time. Best combinations, maximum union distance, probably not, probably what you would have expected at the beginning. Interesting granularity plateaus, so you do not always get better for more work inside here. Lots of interesting extensions that we could look at, limited fields of view, full 3D ones, try and use some of that 3D kind of visibility perspectives, thinking about lightings, thinking about unknown environments, Changing the paths in a way that we can since we now know a path, we know characteristics of a path, can we alter a path to make it harder or less hard in terms of how much visibility it uncovers at different points? We'd like to evaluate the visuals a little bit more. It'd be nice to know what people actually want out of this. We think that people want to see novelty, but probably people want to see novelty. Well, they don't necessarily want that, but they should see some familiarity and some novelty. There probably should be some nice pacing inside there, which would make more sense. And I think that's it. And this is my new favorite ending slide for all my talks.
So I think in addition to like seeing what people like, I think it'd be interesting to see if like there's a method that is close to what people actually do if they're taking a tour, so that if you wanted to like use this as some sort of proxy for what a human, like the path that they would take through, I think that'd be very interesting.
Yeah, that'd be really cool. I suspect people, you're going to follow left-hand rules and things, and it's going to depend very much on the map, but it'd be really neat to get some data on that. We need more player data. As well as maps, we need player data. Right?
Yeah.
To kind of follow up on that as well, that the maps that are being used have completely different gameplay functions. So you were looking at Arkham Asylum, which is a non-linear story-driven game, and then you've got Crash from Call of Duty, which is a cyclic, which is built as a giant circle. Run around that and pick people off, and you're very seldom focused actually on looking for things other than for things to kill.
Yeah.
So there's an interesting thing here in terms of the function of that gameplay space and how players will interact with it.
Yeah, and we originally wanted to look at hundreds of maps, but it turned out making maps was painful because we were thinking, Call of Duty's first-person shooters probably got a very different characteristic to how someone would explore that if they chose to explore it than something like an RPG. Unfortunately, we don't have enough examples to say anything interesting there, but yeah.
Have you tried looking into some solutions to traveling salesman problem? For example, because it shows the performance of just taking the nearest node.
Yeah.
But I can imagine a decent solution, maybe not perfect, but a decent solution to a traveling salesman problem implementation could be an improvement. I'd be interested to see if that could actually outperform looking for the node that has the most discovery.
I expect anything better there probably would, right? Because the simple little things, we were able to see some difference already. We didn't actually delve into that in any particular detail, but that would be neat to do, yeah. Sorry, way up there.
I wonder if you've thought about kind of reinforcement learning approach to more formally model what is good for this agent in this space idea. Because at the moment it's like one metric, right? How much I've seen.
Yeah.
But as these guys were saying, I think it might lend itself to something more complex of a model.
Yeah, we thought about it. We haven't done it. But that would be really neat to do because there's certainly more interesting things going on in there than just seen or not seen, right? Yeah. Michael?
I had a question from the stream, which was, have you tried to, do you think that it will be possible to relate some of these measurements with things like player frustration or player competence in games or anything like that? Or they said, like, do you just need more data for that kind of thing? Or?
We haven't thought about that or done that, but certainly, I mean, I've seen papers on showing that newbies move very differently inside games, depending on the game genre, so that would certainly be something that should be evident in there. But I haven't really thought about that. That'd be kind of neat.
I had a question I wanted to ask myself as well, which was, I guess your system knows the extent of the actual level.
Yes.
So I wonder how different it would be if, you know what I mean? Like maybe if they knew the limits, like the total limit of the area the level could be in, but they don't know exactly how much they've explored, because that's often sort of guides the way that they.
Yeah, it's some partial information. This is why we're thinking about it aimed at NPCs, because then we know we can cheat and we know the entire level, right? But if we actually want to try and model players, they're moving in an unknown environment, unless they're playing it again, right? So then we get different behaviors. But that would be kind of neat to do. But those are a whole different set of algorithms for addressing that kind of stuff. There's some stuff done in robotics for that. That'd be neat.
In terms of like user studies, I think maybe amusement parks.
Sorry?
Amusement parks.
Amusement park. Oh.
Or IKEA. Might be an interesting way to kind of think about these visibility problems, because like they're certainly laid out in these sort of ways, right?
IKEA, Now they force you into a route and then you can't get out of it. So I don't know. That's less of an exploration and more of an escape kind of problem, isn't it? But amusement parks, actually, that's a really cool idea, because then people do probably look around pretty much everywhere, right? Because they want to see everything in there. But then it's, I guess they're kind of, well, they're bounded at least, so they're polygonal in some sense.
I think there's something about like where the castles and the points are set up, so you can see them from all locations, so you know which directions to go.
Yeah, so some guidance that way.
Quick follow-up on theme parks. Maybe you could try roller coaster-like games and stuff where you actually build theme parks. Compare the performance of players to maybe real that.
It'd be kind of neat for filling in the NPCs in there and getting them to actually move around the space.
Maybe based park rating based on how well the people can explore the whole.
Well, that's what we wanted, was a quality metric in the end. I mean, we didn't quite get there, but.
Thank you.
I'm afraid you have an hour of me now. I know. I'm just saying, if you want to leave now, it is too late. I've locked the doors. Yep. I assume that these are for us?
Yes, for you.
Okay. It's for me specifically. Because I am going to...
You're in fact required to try.
Sure. Okay. Highland Spring, north of the border, is a euphemism for something alcoholic.
So we'll treat it like, do you want to do it like 2 calls, or do you want to do it
Or do you
want to do it?
How do you mean? Oh, you mean for time? Yeah, that would be good. Yeah. Let me know as if it's, yeah.
Looking at this one first? Or
The other one first. Thanks, though.
Okay.
This has really saved me.
We need to do plugged in.
Oh, yeah. Wise man.
Are you doing this as 2 talks?
Yes.
Okay.
Yeah, you get...
So I'm going to have because I need to leave halfway through and I'm going to leave that.
Okay.
No, you cannot.
Oh, no, there'll be a nice break. There'll be a nice break.
Yeah. I don't want to be the person who's like,
You won't notice the difference.
Well, you can slam it down and be like, I'm done with this shit, and then just, yeah. Some of my, oh no, this is your laptop. I was like, some of my USB ports are a bit funny. That's okay. Don't worry about it. I'll just use the old keyboard.
Use it tomorrow. Sorry.
I was thinking of doing
What is this thing?
meta commentary on your laptop. So on the stream, just remarking how great your own
That one's plugged into this machine.
Oh, okay.
So you have to
No, it's no problem. I will just walk back and forth. Okay.
Sorry about that.
Tommy, can I just, sorry, one thing. Okay. Do as you wish now. That's okay, no problem. Right. I have 2 talks. Before I start, if you're watching on the stream and the stream goes down, I can't like fix it or anything. I'm recording it locally, so because we have had problems with the Wi-Fi today. So I've got 2 talks. I'm doing this in this order because one of them is a tools talk. So that's like the sort of, it's like a vegetable stew where one of the vegetables in it you don't really like, but you're going to have to eat it anyway. And then the talk afterwards is about games, and it's just like solid games. So that's your dessert, okay? So I'm going to try and make both of them as interesting as possible. But my name's Michael Cook. I work at Falmouth University with the Games Academy and the newly founded Metamakers Institute. And I'm working with Simon Colton. And some of this work was also done with Jeremy Gow, who's an old colleague of mine who works at Goldsmiths in the University of London. And I want to talk to you about Danesh, which is a tool I built in Unity for working with procedural generators. So this talk is going to talk about a little bit of motivation, so where Danesh came from, why I wanted to build it, an overview. We're going to sort of step through the various features of Danesh. I'm going to try and make it interesting, but it won't be because it's a tool. No one here wants to see this. I realize it, but there's going to be pictures, and the pictures will sort of get you in there. I'm going to tell you what I'd like to do in the future, and then I'm going to ask you to do it for me, and that's going to be the talk. So let's start with some problems. I think I feel personally that procedural generation is sort of, it's like it has really great fringes, but in general I think the field is a bit of a mess. And when I say procedural generation, I mean sort of more focusing on games. I think maybe the generative space in general is still quite good, but games in particular has some problems. What kind of problems are they? Well, these problems are highly subjective. Some of you may disagree. The reviewers had very good and opinionated feedback on this, and they did disagree with me on many of them, but we can talk about it over a beer or an iron brew later. So first of all, I think PCG is really in danger of stagnating. We see it repeatedly used for the same things in games over and over again because it's really good at those things. But over time, I'm seeing more and more think pieces and tweets from people and blog posts about procedural generation is dying, procedural generation is dead. A lot of people are saying that they're worried that there'll be a backlash to No Man's Sky where it's not what people expected, and that kind of kills procedural generation in their minds forever. None of these things are really true, but I am worried that we're sort of doing the same things over and over again, and we should be doing some of the stuff we've seen today. We should be branching out more widely. I also believe that we're lacking tools to help people develop procedural generators. Things like, I can open up Unity, I can't write shaders, but Unity will help me do that with absolutely no knowledge at all. I can click a button and add a physics engine into a game. And that can be the basis of an entire game. And I'll talk about things like that in the next talk. But a physics engine makes a game like Angry Birds, but you don't need to understand anything about writing physics engines to build a game that have them in. But building procedural generators is super difficult. And procedural generation tutorials often encourage people to copy and paste other people's systems, and often explicitly just say, if you want to do something different, just fiddle with the numbers until it works, or something very vague like that, including tutorials that I've written. I almost quoted myself in one of these papers. And that's, all of these things are subjective. They're not all as awful as I'm making them sound out to be, but they are problems that bug me, and I wanted to, I don't know, I'd like them to be fixed, and what I've done hasn't fixed them, but hopefully you can see where I'd like things to be. So now let me tell you how those things influenced where I came from. So I organize an annual event called Proc Jam, the Procedural Generation Jam. The projector's nodding because it really likes the jam. It get about 100 entries. It's run 2 years now. It's really great. We get artists, game designers, people who've never done procedural generators before, world experts in it. Lots of the people in the room have entered, and it's really wonderful. And one of the objectives was to try and get people who've never done procedural generation to have a go, because that's how you get new blood in and new ideas. But I found that was really difficult because tutorials are difficult. There aren't good tools. It's really hard to get engaged. The other thing that I've really been doing a lot of lately is designing Rogue Process, which is this game I'm making about breaking into buildings at high speeds and hacking things in slow motion. And building a game that is very, very big without much time to do it in has made me realize, really made me appreciate how difficult it is to use procedural generation in a big game context. And while I was making the game, the game generates these skyscrapers, and it generates them according to various rules about where rooms should be. I mean, these are very bare bones, but each of these rooms has a function. Their proximity to other rooms is set by the generator. And I wanted to know things like, that I need to know what percentage of these generated skyscrapers have a particular feature about them. And so I started sketching my own tool that would generate lots of skyscrapers and analyze them and tell me 60% of them have a chief executive office on the first floor or whatever, the top floor. And as I was doing this, I was thinking there should be, I wish there was a generalized way of doing this. I wish I didn't have to make this so bespoke, because it felt like I was over-specializing. And the other really key part of inspiration for this, and a lot of what people find most cool about Danesh really comes from this work, which Tommy's thankfully already mentioned to me earlier today in his talk, is based on Gillian Smith and Jim Whitehead and others, I believe, work on not necessarily Launchpad, although Launchpad is a great tool for designing and analyzing platforming levels based on this rhythm-based schema, But in some of the papers, they write about expressive range. And expressive range is a really awesome idea. And Tommy showed you very nice, colorful diagrams earlier of his application of expressive range to sure-footing. But in case you didn't get that, or in case you weren't here, you have some metrics, like linearity here and leniency, that you can give a level and get a score back, like how linear is this level, how many pieces of treasure does this level have in it, or whatever. That would be a pretty weak metric. But this expressive range analysis samples your level generator many times, and every time it plots, like it increments one of these marks every time a level is evaluated as having these metric values, you know. So you get 0.2 linearity and 0 leniency, and this data point here becomes more intensely white as you get more levels associated with that data point. And what you see is like a cluster around the shape of what this procedural generator is doing. This was amazing. This was such a good way of visualizing what a generator was up to. And so all of these things came together, all of these problems that I had, all of these tasks I was working on and things I'd read. And one day I sat down and I was looking for a research project. I sort of suspended my work on Angelina and things temporarily, and I needed something new. And so I started working on Danesh. Danesh, by the way, is a Farsi word meaning knowledge. I speak very little Farsi, but that's one of the few words that I know. And I built this. This is actually, believe it or not the first version of the user interface. But one of the, I didn't expect that to get that big a laugh, actually, but it really must be that bad. But I'm not a user interface designer, and one of the big problems with Danesh is that it needs one. But what I'm going to do is, even though this looks like garbage, we're going to step through Danesh bit by bit, and I'm going to show you what the different parts do. So the first thing you do is, this is built as a plugin to Unity, so it opens as like a nice window in the editor, and that's at least 20% of the reason why it looks garbage, because Unity looks garbage, at least its user interface does. So you load a generator in, and then you can click Generate Content, and it will show you examples of your content. At the moment, you have to tell it how to visualize your content, but that's normally fairly straightforward, and in some cases, we'll have just written that visualizer for you. So if you generate text, it just displays it as text. So that's quite simple. So that's nice, very basic. And the way it does this is it uses something in C# called attributes. So this generate level function has the word generator in square brackets over the top, and that is called an attribute, and that can be used and seen in code. So Danesh can look for the generator attribute in a class, and it knows that this method is something it can call to get something that is a piece of content. And similarly, you can tag parameters to your generator with another attribute, and you also give it like a minimum value and a maximum value and a plain English name. And once you've done that, you load them into Danesh, and it gives you these sliders, and you can change the sliders, and you can click Generate Content, and it'll change the map again. And so far, this is pretty much, you can do this in Unity anyway. This is not new. It's convenient, for me at least, because my generator was hard to isolate. But this is pretty basic. This is pretty ordinary. So then we step into the world of expressive range, and we start to add metrics to Danesh. So I've got my generator, and I've plugged its parameters and its generate function, and now I'm going to write some metrics. So this is a density metric. We use another attribute with a plain English name. And this one, like for these 2D maps that I'm using in this example, the density is like the number of solid tiles divided by the total number of tiles. So it's like a percentage of the map that's filled. And right now, defining and writing in code the metrics that you want is like a major knowledge bottleneck. There's two major bottlenecks for using Danesh, and this is one of the big ones. This is one of the big two. Because first of all, it can be hard to think, what do I want to test about my content? What will be meaningful, what will give me good insight into the generator. And the second is how to express it in code, which if you're not a programmer, that's really, really difficult. But I've got some ideas about how we could maybe work on that. So once you've told Danesh to go and look for your metrics, the little functions that you've tagged as metrics, it loads them all in. And every time you click generate, it uses your parameters to generate some content, and then it runs them through the metrics, and it tells you, oh, this is 98% connected, and it's 36% solid, and it's got a wall distribution of 0.393, and presumably that means something to you because you wrote that metric. Or maybe we find these magical general metrics that work for platformers or work for first-person shooters and things like that. And that's okay. That's nothing super special. But now what we want to do is we want to make these beautiful expressive range histograms. So there's a little button in the bottom right-hand corner, and you tell it how many samples you want to make your expressive range analysis. And it produces this nice histogram, and you can click and select the two metrics that you want for each axis, and it will produce this nice display. And what you can't see here, but I'm going to show you in a minute, is that if you hover your mouse over one of these squares, it will show you an example of a piece of content that exists in this space. So you can see here, we can see that there's an indication of a correlation between these two metrics. They're fairly tightly grouped, and like most of this space is unexplored by the generator. We don't really know what's going on there. So the expressive range analysis is useful because it shows you what your generator is currently doing, but it's kind of hard to appreciate that unless you know what your generator could be doing. So this is like an ERA that is based on these parameter values. So these could be any parameters and it could be any generator. But the point is it shows you what is Minecraft doing right now when you generate a world, or what is Sure-Footing doing when you generate a series of platforming levels. What I thought I had come up with a great idea, it turned out that Gillian had actually already thought of this and I just hadn't found the publication, was the idea of randomizing the parameters while you're taking an ERA. So Danesh, in addition to showing you what your generator is currently doing, it can also run a randomized ERA. And what it does is, when it's taking its 500 or 5,000 level samples, instead of using the same parameters every time, every single time it randomizes the parameters between the max and min values that you gave it, and it takes a new sample. And what you see, and I don't know how well this is visible towards the back, but what you suddenly see is you suddenly see the shape of the whole generator reveal itself to you. And you can see that there are no data samples from this area of the map, and there's none from down here. And the reason that's useful is you might be thinking, I really wish I could maximize both of these metrics simultaneously. And you might have sat there all day changing parameters and trying to get up here. But in actual fact, it just wasn't possible. And the RERA kind of just reveals to you which areas of the expressive space you can actually get to. And it also reveals cool, like weird anomalies. Like this place is very dense for some reason. And maybe that reveals something to you about the nature of your algorithm. Like there's something weird going on here in that there's much more data in that area than it should be. And on its own, that might not be super meaningful, but once you hover your mouse over these things, you can see, oh, this makes sense because this is like 100% open. There's basically no walls. This one is kind of interesting. Maybe I want to explore up in this area some more because there's like lots of cut off areas. And this one, like what is going on here? And you hover your mouse over and suddenly you see that there's this weird, almost like QR code style broken up map. And you might not have realized that your map generator can do this, and maybe it's totally useless to you. Maybe it actually doesn't give you anything at all. But it's useful to know that these things exist because maybe you want to make sure that never happens, or maybe you want to make sure that that is like a special generator setting that the player can unlock, or maybe you just were curious about what on earth it was. So far, what I've done is I've re-implemented Unity's parameter editing, and then I've tacked on Gillian's expressive range analysis, and that's it. So it would be nice to actually contribute something to this. So to recap, you can load in a generator, and you can analyze what it's currently doing. And then you can use an RERA to see what it potentially could be doing. And in theory, you could just sit down and change parameters all day and keep running ERAs to confirm what it's doing next. And it would take you a very long time, but you could, in theory, adjust your generator to be doing whatever. But what we'd rather do is we'd rather tell Danesh what we want the generator to end up doing and ask it to work it out for us. Because you see, the problem with changing parameters is that you're changing the input to a black box in the hope of getting a specific output. But it would be much easier if you could just specify the output that you want and ask it to find the inputs. To ask it to say, I want to make sure my maps are 100% connected, and I want to make sure they're 60% dense. And maybe that's not possible, but you want to get as close as possible. So with this area of the interface, you can say, OK, here's what I want. You tick the metrics that you're interested in. So I want 100% connectedness. And then you tick the parameters you want to allow Danesh to change. So it might be that you don't want Danesh to affect the enemy density because you've got it in the sweet spot where you like it, or you just want it to be more constrained. You just want it to only affect other factors. So you uncheck parameters, you check whatever metrics you're interested in, and then you click go. And there's a bunch of different approaches. We've got a paper at SIG about different approaches for auto-tuning. At the moment, I believe the best one is sort of like a randomized hill climbing approach, but that's mostly because the metrics and the generators we're using are relatively simple, and I believe that once we start building in beefier generators and more complex metrics, we're going to need a much more intelligent optimization system for searching for parameters. But it lets you do stuff like, this was like a walkthrough example in the paper, it doesn't really work in a talk, but you start off with an ERA up here, and this is like, you want it to maintain the same amount of density, but you want the wall distribution to be much lower, you want it to be more maze-like. And so you run an ERA, you ask it to auto-tune downwards, and now you can confirm what it's done afterwards by running an ERA afterwards. So it's not just that the auto-tuner goes away and does something and you just hope that it's correct. You can use ERAs to confirm what the auto-tuning has done after the fact, which is really nice. So this was like the first stage of implementing Danesh, and it's got some genuinely useful things. And the problem is that you sit down and you immediately think, oh, but it could do all of these other things, and it could do X, Y, Z, and we could do X, Y, Z with it. These are a couple of ideas that I've had from talking to people, ideas that other people have suggested. Obviously, we need studies. I'm very lucky to have had about 50 indie developers sign up, and they want to use Danesh, and they want to try it out, and they want to give us feedback, which is great. I've been really lax with getting it sorted, but we will do it at some point. Me and Jeremy are on top of that. One of the big problems with Danesh is defining these metrics. So I know lots of people who are interested in machine learning. One of the things they've suggested is allowing the user to provide positive and negative examples of something instead of writing a metric in code, and say these things look like levels that represent a high level of this metric. These are levels that represent a low level. And the machine learning system tries to understand what this metric is without it ever being explicitly defined. And I think that's a really interesting direction to go through, because it's a much more newcomer, I guess is the word, friendly approach to this sort of thing. The other thing is that subspaces or styles of content can be identified using this tool. So right now you can auto-tune the same generator twice, and it will find the same region of the ERA space, but the content it generates will look very different from both auto-tunings. And that's because it's possible to have very dense maps that are all narrow, winding mazes, and also very dense maps that are just one very small room in the bottom left-hand corner of a map. And what would be good is if we can use, we can have Danesh identify these subspaces without knowing anything about the content. So something that doesn't come across always when I talk about Danesh, because I focus on map generation because it's a very easy example, is that Danesh knows nothing about your content. It knows absolutely nothing about it. All it knows is that it can call a function to generate some content, and it can call metrics to get a float value that estimates something about that content. That's all it knows. So it's really difficult to do things like analyze or cluster content, because you know very little about it. You know very little about how the parameters affect the generated content. So these things are interesting challenges, but I think they'd be really useful to people just starting out. Now, here's the thing. There's a lot going on. I did this work about 9 months ago. Since then, I've actually resumed work on a version of Angelina, as I showed in the lightning talk section. I'm working on row process. ProcJam is coming up. There's too many things going on. I don't know when I'm going to work on Danesh next. Jeremy's very keen on doing it. We do want to work on it. But from the beginning, I'd always intended it to be a project that was very modular. The design of the plugin is extremely modular, so you can have a tab that is, Adam Summerville's Machine Learning Funhouse. And if Adam wants to download and fork Danesh, you can add a tab to Danesh, and that will have all of Adam Summerville's cool tools in it. And maybe instead of adding features, you want to use it in a study. That would be great. Or you want to use it as a teaching tool. Or you just realize that it's just complete garbage, but it's got one bit of Unity code in that might be useful to you and that you can put in something actually good. And I'm down with that as well. The point is, this whole thing is online at github.com/games by Angelina. And if you think it is useful, please go and either add to it or take from it whatever you want. I'd love it if it incorporated things from you, but I'd also love it if you took it and used it elsewhere. Regardless of what you think of Danesh or whether this project goes anywhere, we really desperately need better tools to help people teach procedural generation, to help assist developers in using it to its fullest extent, and also to help people get into it for the first time. I think there's a problem of there's this notion of generative literacy that we've all picked up passively over the years, where we understand a generator and we understand spaces and we understand distance between different states. And these things are completely opaque to someone just starting out, to someone who only has the web to Google for tutorials, who can only do a little bit of coding. They're not going to have anyone to really teach them these ideas. And I think we should do more to try and help people. So how am I doing for time? That's okay. That's not too bad. Yeah, I'll save this and I'll moan at you about it in the next talk. But if there are any questions about Danesh, I can pause there. And yeah, we can have a break. Okay. Julian, in case you have to leave.
So, I'm trying to think of how to form it. I wish you'd called on me second so I could have finished forming it.
Tommy, I believe I went to you.
Oh, right. Go to time.
So it's interesting because we've been trying to solve the same problem in surefooting. I actually have my own build in the branch of Doom, which is the expression modeling. It's not as rich as Danesh is. There's actually interesting things in terms of you were using the RERA to establish these are the areas that we're not using yet. And you can see that a lot in my talk. There was a whole area of the expressive range that we're just not touching. I think one of the things that would be interesting is if you consider trying to see if it could quantify with context of the problem space what that area means. So you can actually have English interpretations of a particular subspace.
Yeah, so the question for the stream was these missing areas of an ERA, these areas that the generator isn't in yet. Is there a way of communicating to the player, to the user, what that is? It's really difficult. So one of the problems is that with Danesh, we've given this arbitrary constraint for ourselves that we don't want it to know anything about the content, and that's so that it can be as general as possible. So it doesn't know what your game's about, and that makes it harder to describe things in plain English. But it would be good if it could, like I said, it would be good if it could cluster things together and say, this area that you haven't explored, it's a bit similar to these to this 5% of the area that you do explore. You know these levels that look like this? They look a bit like that. So even if it can't relate it to something external, if it could relate it to something internal, if it can use current examples that you know, even that might be useful, but it's a difficult problem.
There's also, you can even look at it like a profile set. What if I was to interpret this map as a platformer? What if I was to interpret this map as a dungeon?
Yes. Also, one thing I am hoping is that over time, in an ideal world, we might build a catalog of common metrics and common renderings and common representations. Because ultimately, a lot of people will be generating the same kinds of content, or they can benefit from each other's analyses, hopefully. Yeah?
So have you given thought, and I think this is somewhat related to what Tommy was talking about, but I'm not sure. Have you given any thought to how to handle situations where the style of control that the designer has over the generator is not tunable parameter on a slider, but is more what input data am I using, or what geometry have I already told the generator to hold constant. So this is something we struggled with expressive range analysis on Tomeria a lot, where some of it is probability of enemies showing up in platformer level, but a lot of it is actually I've told the generator that these specific sections should have this specific piece of geometry. So it's not something that you can scrub back and forth easily to see how it changes. So have you thought about?
Yeah, that's interesting. I haven't thought about that specifically. The closest I came to it was thinking about how Rogue Process generates corporation names and slogans, and that uses text corpora.
Right.
And I was like, how? That doesn't even make any sense.
It's not a parameter.
Yeah.
It's
and it's also very hard to write metrics for those as well. And at the moment, I'm wondering whether you can write metrics that talk about the corpora as well. So corpora that have these properties are more likely to produce, but then I don't know if this is a molehill of corpora, of metrics that you end up in, metrics all the way down, basically. Yeah.
The idea of applying it to the corpora.
Yeah, because then it allows you to, if you do have data from the web, for instance, that you really know nothing about, then you at least, the system can at least know something in advance before it starts using it, or it can, tell you, if the player input this is the inspiration, then probably it would go this way. Right. But I don't know. I don't want it to, it's difficult. I don't want it to become this mess of I don't want to overgeneralize it, but I do want it to be general if we can. So I don't know. I know that didn't really answer the question.
No, it helped.
I should probably start the next talk, should I? Oh, well, you're the organizer, so if you say it's okay, then.
You have 4 more minutes of questions.
Okay. I'll go with you, and then, yeah.
So I think, again, to start with something nice, and actually, yeah, it's a very nice initiative. I hope people sort of, join into this thing, and I think it's necessary. It's needed we get these metrics that cut across games. However, I think that some metrics, some of the best metrics will always be simulation-based. You need something to play the game to get to it.
Yes.
Would that be even in principle be possible to integrate?
Yes, it would be, but it would slow Danesh down a lot. So for instance, really nice, I would say a really nice expressive range analysis needs maybe 250 samples right now.
Yeah.
A good random one needs like 2,000 samples. You could leave it overnight running, but like it would take a long time to compute those if it had to do some playouts. But it's definitely feasible.
A big part of the problem here is Unity. Unity is the game engine that we all work with, but it's idiotic, ridiculous, random limitation of how much you can speed up.
Yeah. So I meant to mention in the talk, but one of the reasons why I chose Unity was because I wanted to target people who are newer to game development, and that's often what they're starting. But I agree with you. It's a nightmare. I use it for literally everything now, but it is a nightmare.
It's not like most games. It's not made with simulation, but it would be cool to have it. It's like have tags that this is how you would play it.
Yeah. That would be actually great. Yeah, that would be another way to generalize across games, where you could contribute a general game player to this thing that would be really good.
A question from the stream.
Lovely.
Martin O'Leary asks, have you tried plotting the expressive range of the edges of the parameter space to try to find out whether empty areas of the expressive range are because the parameters are being capped artificially?
No, that's a good point. That should probably be part of a random ERA, actually, because, sorry, this was the question from the stream. Well, I guess they'll know because they asked it in the chat. That's a really good point, because when you do an RERA, you're kind of just assuming that the edges will be capped. But, obviously, the extremes of the parameters don't always guarantee that will be like the Pareto front or the edge of the space, but that's a really good idea. I'm definitely going to add that in. Thank you. Yeah. You, and then we'll move on, maybe. You, sir.
Just real quickly, can you give a taste about how you actually search the parameter space?
So at the moment, it's a hill climber. So the key thing is that you know the maximum and minimum values set by the user. You take some random values, you nudge them by a particular increment. The increments can be set. At the moment, I don't allow the user to set it because I added it in and it felt like it was too technical a thing to give them, so I just chose something that was relatively optimal. And it will nudge it a little bit. If it improves the average distance to the metrics that the user set, then we keep going. If it doesn't, then we reset because we assume we've hit a local minima or whatever. And it searches it searches every nudge it could make. It searches from where it is. So it's fairly intensive.
When you have 2 parameters you're trying to optimize for?
When I have 2 parameters,
you're trying to optimize for, how do you know which way to go?
So you just look for whichever one improves the average distance between from the targets. Yeah. We tried more complex things like an evolutionary system, for instance, and it's just not appreciably better. And so we removed it, but I have a suspicion that if we put in more complex metrics or more complex generators or lots of parameters, we'll definitely need something better than hill climbing. It works really right now because these problems are relatively simple, but we'll need something heavier duty, I think, in the future. It's actually a cool problem in and of itself, I think. Yeah, the SIG paper is more about that kind of thing. It's like this process of auto-tuning, whereas this is kind of like a, hey, this exists. This is more of a general talk. Okay, shall I move on? Oh, thank you. That's okay, don't worry. All right. Well, if you thought that one was fun, this one's got videos. So, my name's Michael Cook, blah, 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 blah. I want to talk to you about 2 games today. One is called Clay, and one is called Tombs of Tomeria. Sometimes this is an O, sometimes it's an E, because I made up the name and then I forgot. The game's lore is so rich that I just forgot which one it was going. Yeah, right, quite. So yeah, these are 2 games I made when I wasn't making Rogue Process. and I'm going to take you on a journey. And this journey begins in Darkstall last year, where a bunch of games researchers got together in a castle in Germany. A mini castle, not like a proper, like a thing. But like, it was very cozy, it was very great. It was one of the most productive and exciting weeks of my life. And one of the things I got exposed to while I was there was the cold, and also the notion of AI-based games, which it was a previously existing thing. I believe the paper is just called AI-based games, and it's got people like Mike Traynor and Miriam Alatari, I think, on the authors list. I can't remember exactly, but if you Google it, you'll find it. But at Darkstall, they were kind of sort of extending the concept, and I got to be part of that work group. So physics-based games are games where the fundamental interactions with the world are done through a physics engine. So Angry Birds is Angry Birds because there's a physics engine pinging the birds all around and making them do funny things. AI-based games, so the definition goes, are exactly the same, except it's AI driving the game experience. So, for instance, in Black and White, the AI functions as like a trainee, and your role as the player is to teach the AI, this machine learning system, how to be good or bad. And while I was at Darkstall, the way we extended it was, and this was actually a group led by Mike Traynor, we talked about patterns. So what kinds of patterns could you reuse? Like the AI is a co-creator, or you visualize the AI. So that was a game called Third Eye Crime, where you could see the AI's pathfinding and then predict where it was going to go as based on that. And I really got into this idea. I thought it was really cool. Obviously, there are lots of games where you interact with the AI. So, you know, your average shooter, you have the AI as like an adversary, and that was one of the patterns we identified. But what we're more interested in is where the player really feels like the purpose of the game is to interact with an artificial intelligence. So like Alien Isolation was one of the standout examples for me, where we described it as like a pantomime villain. The role in the game is not really for the AI to win, it's for the AI to almost win and scare you out of your mind every single time. And your relationship with the alien in the game is what's really important. It's not about, you know, bashing down millions of enemies. It's just this one AI system. A couple of months after Darkstall, Alex Zook organized the AI Jam 2015, which was a game jam where the idea was to build an AI-based game, essentially. I don't think we used that term, but I think that pretty much was Alex's intention. And I really, really wanted to enter it. It ran for a little over a week. One of the standout games, if you have a chance, is Sarah and Sally. I really liked that entry. And that was about that they wanted to look at AI assistants in games and make one that wasn't annoying, so it helped you solve puzzles. Anyway, I didn't have very long, and I really wanted to enter, so I built a game called Clay. I had like one day, and I built it in a game engine called Flixel, which already had a cellular automata generator in it. So I was like, this is like half of the game already, because I had the game in my mind. Because when I was sitting in this AI-based game workshop, I was like, why aren't there, I couldn't think of any games, or many games, that use procedural generation as their AI-based game concept. So I had this idea, and I built this game called Clay. So if you don't know what a cellular automata is, don't worry about it, but the idea is that there's some variables in your generator that tweak how the game will end up looking. And so this is Clay, and I'm going to talk you through this little video of it, but you play this little spaceman. And your objective is to find these drones and activate them. So the idea is that you're in this asteroid field and you're searching for the drones. And eventually, the level generator will produce something that you can't get past. And so you have these terraforming tools that allow you to shape the way the world looks. So this blue ghost is what the world will look like if you make this change. So I'm going through different changes, and when I find one that I like, I hit R, and it changes the world permanently. And now I can go around and access this drone. And the player's got like 4 different buttons, Q, W, A, and S, and Q and W affect one variable. They increment it or decrement it by a notch. A and S affect another one. And that was pretty much it. Like, that was pretty much the game. You could pick up like jump boost packs, and you had to activate as many drones as you could and then get back to your ship. So there was sort of like a little bit of strategy in conserving jump boosts so that you could get back to the top of the map. So, as I mentioned, the environment hinders your exploration. Cellular automata, like, I didn't have time. The generator isn't intelligent because it doesn't need to be. Who cares? Like, the player can edit it. You just carve a hole through, and then you solve the problem of bad level design. A bit like the way Spelunky gives you bombs, but like a more fundamental like power that you have, because you're actually editing the parameters of the generator. When you press Q and W, you're changing what the generator is and what the generator does. So I put Clay out. A few people played it. They seemed to really like it, but they had like fairly consistent feedback. The first of all is that even in a game that is science fiction and has a completely invented premise, it's really hard to explain why you're able to edit the world, and also why the world is changing in such a strange way, because you're not even intentionally terraforming it. Like these random changes would happen that would sort of be, you could maybe sort of understand what was going on, but not really, and it was really hard for the player to understand why they were able to do this. Also, the player is incredibly powerful. They can edit any obstacle in their way if they have enough time, and it's really hard to sort of direct them or stop them. And as a result, this sort of leads into this other problem, which is that it feels a little bit empty from a game design perspective, because it's really hard to give the player a sense of progression, to challenge them, to understand the level of challenge that they're facing. And so I really liked Clay, I really liked the idea behind it, but I spent quite a while thinking about these problems. And then by chance, one day, I stumbled across a sprite pack on itch.io that was inspired by La Mulana and sort of Spelunky, which was also inspired by La Mulana, I guess. And there was I mean, other than the sprite pack being amazing, there was a sprite for a lever. And because of the way Spelunky's fiction is, you know, it tells you that the walls are shifting when you start playing the game, I thought that actually, one of the ways to solve this problem would be to experiment with like fixed point changes where you can make alterations to the world. So instead of being able to change the world wherever you are, you can only change it where you see a lever, and then you pull the lever and it alters one of the variables. So this had the benefit of, it would slightly reduce the player's power because they could only change the world in certain increments and only in certain places. And also, it made sense. Like, you're in this sort of weird tomb, and as you change levers, these traps trigger and the walls are moving. So, like, it still doesn't make a whole lot of sense, as you'll see in the game, but it makes more sense to the player, and I think it made it easier for them to connect to what it is that they're doing. And at least that seems to play out when I showed it to people eventually. So here's what Tombs of Tomeria looks like. So you play this little guy. I didn't do any of this art. It's actually a pack on itch.io. It's extremely cheap and really good. Like, it's such a great sprite pack. But yeah, as you can see, my objective here, instead of like collecting drones or anything, you can collect coins, but they're basically optional. My real objective is to get to the exit, which is indicated by this red arrow. And I need to flip as many levers as I can, or at least levers that are important to flip. So you'll see as I flip that one, some blocks disappeared. There is one thing that's consistent about the levers, which is flipping a lever to the left generally reduces the number of blocks in the world, and flipping it to the right increases them. And you can see I'm sort of making my way through this tomb. This is the exit behind this block here, this little cup. And I won't show you because I make a bunch of mistakes now and get stuck for a bit, and it's really boring. So again, I've just showed you this, but this is just a really obvious explanation that now when you pull this lever, you're editing one of the variables, just like you were before in Clay. But it's by a fixed amount, it's by a hidden amount, and you can only do it once. You can't repeatedly change it because the lever can only be flipped back and forwards. So this introduced a few major things. First of all is that you can't preview what you're going to do. You have to pull the lever and change the world. And from a gameplay perspective, it doesn't change much right now, but later on, if there are like creatures hiding away in shut-off areas, or if there's like lava in a cavern above you and you pull a lever and the blocks underneath the lava disappear, this is obviously going to have a little bit more of an impact. You also can't tell what the lever's going to do before you throw it, although you may get a sense over time of which levers are making major changes and which ones aren't, because the two variables have slightly different effects on the world. And as I mentioned, we keep the direction consistent, so players over time will hopefully realize that moving things left reduces blocks, etc., etc. The benefits to doing this is that I've already mentioned that there's a much more obvious explanation for what's going on. But also, changing the generator is now much more thoughtful and discretized because there aren't many places you can do it. So instead of just having this infinite power, there's like a few places where you can make an important difference. But the really important side effect is that actually you can now compute every possible state the game can be in because you know which levers the player has access to and you know how many of them they can flip. And this was really important because what it means is that you can start designing levels, or you can at least have the levels generated be evaluated. So for instance, from this starting point, the solver that I've written knows that the player can find a lever which will open this route to an extra room. And it knows that in this room, there's a lever that opens this particular passageway here, and from here that the player can get to the exit. So now, instead of having this like random collection of asteroids or whatever with randomly scattered drones all over it, like this one-day game I made was, now the level generator can give you a rough estimate of difficulty, how many levers need to be switched, how many alternate paths are there, how many difficult jumps are there that need to be made. And this was like, I think this is going somewhere. Like, I would like to work a bit on this prototype, but rogue processors are like at the forefront of my mind right now. But I'm hoping to make this actually maybe an element in my research, maybe in the near future. So, in building these two games, and there are other prototypes coming in the PCG-based game area, there were a couple of things that emerged to me. First of all, that when we use procedural generators in games, we're usually using them for, like, we're giving them root privileges to edit the game design. So Diablo's loot generator is affecting the progression system through the game. And your dungeon or world generator is affecting the difficulty level of the game by changing what the player is going to encounter, how long they have to travel. And so as soon as you let the player edit that, you're now giving the player very, very huge scale power over how the game is played. And that can be really cool, and I got advice from game designers that I should amp that up as much as possible and not worry about the consequences, which is definitely one cool idea. But you need to be aware of that. Like that's like, it's a challenge when designing games with this. The other thing is tractability. So in Clay, it wasn't particularly processor intensive to regenerate the world when the player pressed a button. But in Tombs, when we start the game, we have to compute every state the game can be in. And in general, when you're allowing the procedural generator to be edited by the player, that might mean that you have to run the procedural generator many times at runtime. And most applications of procedural generation, like Dwarf Fortresses, for instance, they're designed to be run once. And that's because in many cases, they take a long time to run. So they run at the start of the game, and then the player plays in the generated content. So that may also be an issue if we're allowing the player to change things that will require regeneration. And finally, one of the most important things is understanding. No one mentions their generator in games usually, and the reason is because they don't make any sense in any real-world scenario. So explaining to the player that A, this generator is a concept in the world, or that this process is a concept in the world, B, that the player can edit it in some way, and C, even allowing them to think about things like generative space or possibility space or parameters explicitly or implicitly can be really difficult. And I think that's a big challenge. I want to expand Tombs into a fuller game. I think there's more to be done with that particular idea. I mentioned things like having consequences to opening up areas. I think there's some puzzle stuff that can be done about thinking about which levers to pull in the right situation. Right now, it's very early prototypey stuff. But we'd also like to do playtesting studies where we ask the players to talk about what they think these levers do, or what they think this generator is doing, or how it works. Partly because I want to see whether players can understand it enough to play the game, but also because I'm wondering whether we can use games like this to explain procedural generators to players. So if you let them fiddle with levers in a playful context, I'm wondering whether they will actually gain an understanding or build a mental model of the generator. I also, in general, feel like this area is quite rich with ideas and quite untapped, and I'd like to do more with it. And basically, like, just ask more questions of, like, what if we use this procedural generation technique as a game mechanic? This is not a particularly novel idea, I don't think, but this is another prototype we've got going where the player basically writes, like, little context-free design grammar kind of things, and then iterates them a certain number of times, or as many times as they want on the game world, and then, in this case, they've, like, solved a little puzzle by building a staircase to a key. And this might be old hat, or it might just be not very interesting, but I'm hoping to spend a few more hours fleshing that out into something that is actually interactive and works. Right now, this is very, very early stages. I breezed through that one. I told you that one was a bit shorter. Before I finish, by the way, both of these games are free to play online at this website, along with some other stuff. I'd love to know feedback, particularly on Tombs, because I would like to take it forwards, or any other ideas you have. Before I finish, I did mention the seeds before, but I would love you to enter ProcJam or tell your students to enter ProcJam. It's a really great and laid back. It takes over 9 days, including 2 weekends. You can start early, you can finish late, you can bring half-finished projects. You can start and finish the next May. Some people tweet at me like in June saying they've just finished their proc jam entry from last November. Like, we're super laid back. This is not like a jam where you stay up all night eating pizza and kill yourself. Like, it's really, metaphorically, I mean, this is really like relaxed and good feeling, hopefully. That's how I hope it is. I should also mention that on October the 21st in Falmouth, we're going to have a day of talks that will be streamed live. So tune in or come in person, and that's going to be a really good time. Proc Jam itself, the jam will take place in November. And yeah, contribute to Seeds as well. We'd really love to tell the world about what you're doing. But yeah, if you want to ask any questions about either these games or the concept of, I don't know, fiddling with PCG as a game mechanic, let me know. That's it. Thank you. It's always, sorry that you get the same speaker back to back. It's always a bit of a, slog. Are there any questions? You, sir.
Well, it's more of an idea than a question, but for this game, you could maybe try adding different color levers for different effects. So, for example, you could play with the direction in which the CA is run. So yeah, you can run them like vertically, so you get really stripy terrain.
That's a nice idea. Yeah, that would be very cool. I like the idea of color coding them as well, so the player can maybe learn in advance, so that they're not punished too much for experimenting. Yeah, that's good. One of the game developers I spoke to said that they think I should open up every single parameter I can, including stuff like the size of the level. Like, they should just be able to edit everything, and you should just worry about it later. I like the idea. Yeah, that would be very cool.
Have you thought about like working sort of the same sort of stuff with games that are basically playable ontologies, like Scribblenauts, and also like how people do exploration of stuff in Minecraft, where they don't actually, Minecraft doesn't handle any of the exploration to help you, right? Minecraft just presents you with the world and says go. It's all of the sort of tools are actually community created via Wikipedia and stuff. So just giving people tools, and then some enterprising player at some point, you can count on them, they're everywhere, will like do all your work for you, rather than having to be very careful about it.
Yeah, both of those ideas are very interesting. I think the Scribblenauts comparison is interesting as well, because in Scribblenauts there's also, like with Clay, there's always a way to like short circuit your way to the exit, but those games are still considered valuable for their exploratory potential. But I like the idea that actually these are like problems to solve. Like, this generative space is something that players might collectively gain an understanding of. Yeah, that would be quite cool. Kate.
Something I tried a long time ago with a generator in game designs that did not actually work out at all, but the one good thing about it was I had an adversarial generator that was controlling your access to different tiles around this island. And I gave it a personality. And so the idea is that you have sort of an adversarial generator. You can imagine like an evil genie or a monkey's paw, where it still has to obey your commands, but it can be adversarial about it. And so that starts getting people, it's kind of like the alien in Aliens. As soon as you give it a personality, or like the island in Lost, as soon as it has a personality, you can start doing theory of mind stuff about what people think it's trying to do. And that gets them to try to understand its rules, even if they're like weird alien rules. So that seems beneficial. I don't know if
Yes.
like interesting things to explore there, or things that are going to sandbag you later on.
That sounds very interesting. It sounds like it might work better for a generator that was more interesting than this crappy Stellar Automata one. But I think reading, I'm generally interested in players' responses to this. So adding a personality to that would be an interesting thing to study. Yeah, I kind of like that. Yeah. Yes. Did you have a question? Okay, Tommy.
An observation I had playing this is that this is now good. My comment is actually based on what I thought you'd done and you didn't, so I'm now going to do it. You've got the tile set, and you've got these different tiles, particularly that are just darted around randomly. I thought at first that the tiles were actually a reflection of the potential manipulation space of the cellular automata. And I think there's a really interesting thing there in terms of visual language, that if you could identify different tiles, whether one lever will manipulate the space versus what happens if two levers are going to manipulate the same tile, or three levers are going to manipulate the same tile, that you can begin to subtly transfer knowledge to the user. And maybe they're not going to pick up on it explicitly. They might. But I don't know, I mean, I think that's...
Yes, I think that's a very cool idea. I remember someone mentioning, one of the difficulties is it's quite easy to, so someone mentioned putting cracks in some of these to indicate a similar thing, although I see what you mean, like it would be very clear to use it with the existing tile set. That's very cool. One of the harder things is indicating when a tile will spawn, because the dark background is needed for readability. But yes, I would like to look at like visual or like more subtle indicators. That would be very cool. Yeah.
So what happens when a block appears on top of the coin?
Coin gets obscured. I will tell you, they can't appear on top of levers. Levers are holy; they're protected. But I think it just obscures the coin. I was actually, in the video I showed you, that was the first time I'd had the exit be obscured by the level. I'd never seen that before. So I hadn't accounted for that. I mean, it's really like the coins were like an idle thing I added in. They don't even have any function right now, really. But yes, I'd like there to be, like I wanted this monkey that followed you around randomly pulling levers, like that kind of thing. I wanted there to be more of a sense of a system in place. But right now, not much happens. But it is an interesting thing because obviously levers means that the player can't squish themselves, but there might, like the more objects that I add into the world that are not the player or levers, the more questions there are about like how do you edit the world in a way that is consistent and doesn't blow things up. Yeah, it is a bit of an issue. Is this a?
We've got a stream question.
Okay.
From I'm going to try not to butcher the name. Vitaly Balanenkov was asking, have you thought about meddling with AI-driven parameters?
AI-driven parameters.
So AI
yes.
Parameters of the game.
Yes, I guess that slightly ties into what Kate was saying about like adversarial AI and things like that. Yeah, I think that would be really cool. One of the AI-based game design patterns is AI as co-creator, where the AI can make edits as well. And one of the things I've been talking with Rob Saunders, who's now a colleague of mine at Falmouth, and also I think Kate and Jonathan, it may have come up in the past as well, is a game based around, so Rob Saunders' PhD work was about creative communities, so these bots that sort of share ideas between each other, and I believe we're going to hear some more about those things in the next session. And we talked about a game where you sort of, yes, basically, is that there are generative systems that both you and an artificial intelligence system are interacting with. That's above my pay grade. I prefer to mess around with stupid, simple stuff. But I think that's a really interesting place, especially because then it's got that nice thing, almost like Twitter bots have, where the human player and the AI system are working in the same medium, which I think is very valuable. How are we doing for time, Aaron? Should I? Yeah?
All your levers are changing space. Did you think of having associated time or a temporary effect to them, to the changes?
As in they would turn back after a number of times, or they would affect something temporal?
Or it switches to yet another, not back, but to yet another. So the effect you provoke has a timeout.
Yes, that would be really cool, especially because then you would be able to squish yourself basically by. Now that would be very interesting. No, I think that's definitely good. I like that idea. Or maybe like pressure plates, where if you can put a rock onto it, then you're fine, but otherwise you've got 10 seconds. Yeah, that would be really cool. Yeah, sorry.
Yeah, do you think it would be possible to design the cellular automator rules such that you could use it specifically to trigger sort of little sequences to tunnel through or to achieve specific ends?
So you mean
by clicking on a particular square, for example, yeah.
So you mean like from
So say it has
you mean from the designer's perspective? Because this is very neat. Like this example is so perfect. Do you mean like this or from the player's perspective?
So
yeah.
by choosing the right square to click on, the rule would then, given the environment, trigger an opening or trigger something.
That is difficult, and I one of the problems with CAs, at least, like I've been using CAs because they're just so easy to start going with and fiddle around with, but one of the problems is they are unsatisfying to edit, because it can feel very aimless sometimes. Like this is one of the nicest examples that's ever come up, but it's just stupidly perfect. I don't know. I have a feeling it would be nice. The player would. Yeah, I would like a way to do it. I think the player would appreciate a little bit more direction, although there is something fun about the exploratory nature of it. The thing with with this and with Clay is that the feeling of hitting new world in Minecraft is really satisfying, and this lets you do it as like a gameplay mechanic. Like every time you pull a lever, the world changes slightly. But sometimes you don't want it to be totally undirected. You're like, I want to get into that room right now. And like, it would be nice if there was a way to plan ahead in order to do it. I don't know. I would like to do it, but I don't know how yet. Yeah. Are there any more questions? Yeah?
Maybe another idea for indicating what tiles will be filled or decayed. Instead of making the world out of dirt, you could make it, for example, like a fungus. And spores coming out of the blocks where new blocks will spawn.
Yes, yeah.
More than dirt.
Like a little bit of visual juice. Yeah, that would be good. There are sprites actually for very similar things to that in the tile set. The tile set owner was very lovely. They said that they would extend it, like they would be available for a little contract to extend it. So it would be fun to add something like that in. That would be cool. Yeah, that's a good idea. Or even, I mean, even dust coming from the walls would be okay, but something visual that tells the player there's something happening.
On the side of the blocks where
Yeah. Yeah.
Thank you.
Thanks very much.
You're mic'd?
I'm mic'd.
Okay. All right, we have 2 more papers, and Amy and I were successfully able to find cocktail. Drinks. Yay.
Yay.
But let's do some papers first, and
Cocktail alcohol drinks.
you will find out in an hour.
I'll generate some for you, don't worry about it.
Also contributed by Jonathan?
Recipes can be generated, but that's not this talk, unfortunately.
See who you pull off.
Yeah, so, further I have to talk about other things first. So, I'm Jonathan Pagnutti. I'm a PhD candidate at University of California, Santa Cruz. This work is I was helped immeasurably by both Kate Compton and Jim Whitehead, who are also in my lab in Santa Cruz, and also several other people that I couldn't fit all their names on the slide template that they told me I had to use. Other fun things about this talk, this was originally a ProcJam project. I hacked in Jim's house for like a weekend to get this to work, and then we decided not to use that after all. But ProcJam gives you papers. So what are we talking about? We're talking about art bots creating and judging other art in a little social commune. It's really, really cool. And if we have time, I want to actually show some art bots doing their little creative judgment thing and getting mad at other art bots and getting sad and stuff. But first, a quick preamble. I'm a computer scientist, and I'm about to talk about art. This is generally a ground that you don't want to get into, so I'm going to be very, very liberal with things like the phrase, the artistic process, creativity, and criticism. So expand those definitions of those words very generously for me, please. Overview of the talk, we're going to talk about some art bots and how sort of PCG, especially in games, is very similar to sort of the bots we see on Twitter and other art bot locations. And then we're going to ask the very key question, can we inspire an art bot? And we're going to go into some past work of other sort of social communes about creativity. And then we're going to kind of break down sort of the 4 parts that we need in order to get an art bot commune running, which is a way to make art, a way to make artists, a way for artists to look at art and hate it, and a way for them to tell other art bots that they hate their art, please stop making art. And finally, some future work we'd like to take this. So art bots are basically just a generative method, but they have some interesting constraints in that they have to be reliable and trustworthy enough in order to continue to run unsupervised. A good bot is something you can leave alone for a month and come back and be all like, oh, that was neat, which occasionally doesn't always work, right? Microsoft had a Twitter bot fairly recently that they left alone for about 2 seconds and was immediately terrible. And so the last thing is that you kind of we want to be able to come back and say it was neat. You want to be all like, oh, I left you running for a month and that was boring. So there is some little bit of novelty that we sort of look for and hope for in our bots. So the bots that I've pictured here, first I've got a pair of physical bots. These are called brush bots, and they twitch on a page and they hold a pencil. So they're not bots you want to leave alone for too long, because then they're going to start like twitching off the page and onto your desk or something you enjoy and cover it in graphene. I also have a poetry Twitter bot here, just to say, as well as a sort of color ramp Twitter bot that also makes little sort of 3-color palettes to pick from. And bots also make games. I don't know if you know this, but there are Twitter bots that come up with game ideas. I've got 2 pictured here. One of them is more AAA sort of game ideas, and the other one's more indie and interesting game ideas. Oh, did I say that out loud? And finally, so to continue on with this idea is that all the bots that I've shown so far are all one way. These are 2 of my bots. I've got my cocktail generator on the right, which comes up with new cocktail recipes based around sort of different ideas or different sorts of ways to mix cocktail drinks together. It's got a couple of classes it works for. And on the the left, I've got a Twitter bot that unfortunately is not up right now because I broke the server that it was on because of the project that I'm talking about. But used to tweet sort of wine pairings wines to go with your academic literature that you were reading. And all of this, we can kind of see all this, and I'm stealing this idea from Will Wright when he was working on Spore, because Kate Compton worked on this with me and has great metaphors for things. But this is sort of an artist in a box, right? We're trying to sort of encode the virtues and vices of a good, heavy air quotes here, artist in sort of a executable algorithm so that when we hit a button, the good artist will make us an art. And that's not terrible, right? I mean, that sounds terrible, but it's not. When we look at sort of this output, we can kind of see the expressive sort of range and potential of something that isn't quite human. And it lets us sort of look at this interesting sort of, PCG-like aesthetics that only come out of doing this sort of process. You don't normally see this stuff. You can do it by hand, but bots are way better at it than you are. But that isn't to say that all PCG is one way, right? PCG does get reactive. So bots do react to input. Canonically, chatbots require you to say something before they're going to get any sort of interesting response back. The Cleverbot picture is a thing I quickly generated last night when I was annoying Cleverbot. But also there's this whole idea of experience-driven PCG, which a lot of people in this room have worked on, which sort of is a art bot that makes sort of levels or game designs for me. So I guess it's more of a game design bot. That's based off of how good I'm currently playing the game. I've got pictured the blocks are from Spelunky level generation from Stammer, Gunther, and Pruis. That was an ED PCG that made sort of Spelunky levels based off of how good you were doing. And there's also mixed initiative, right? I'll take a turn in the creative process, and then you'll take a turn. And so together we'll make something. And that's another way to sort of react with art bots, right? Pictured as Julian Smith's Tanagra. And so you can kind of see this about, we're kind of cracking open the box here. Not a lot, but we're letting the artists sort of react to things that we normally don't let them react to. So either it's some art that we've made and then they can say, oh, I know how to make it better, try this. Or I'm going to make some art based off some actions you took. But what if we could open the box even further? Art bots inspire me all the time. They're awesome. The cocktail bot came from a conversation on the beach that came from sort of other recipe generation bots that are out there, mainly Hipster Cocktails, which is an awesome Twitter bot that makes hipster cocktails. I don't recommend drinking any of them. And so what if by interacting with our bots, we could change their artistic philosophy much like how bots change mine? What if, I can inspire bots as well as bots can inspire me? But humans are terrible sources of input, so we're just going to talk about bots inspiring other bots. Some prior work has kind of been done with this. This is some pictures from Rob Saunders, the Digital Clockwork Muse, which is all about sort of these communities of artists interacting with each other, and they essentially rate different little arts based off of hedonic response, which is a complex novelty curve. Complex being like complicated, not in the complex plane. And so essentially bots like stuff that isn't too similar to the stuff that they make, but also not too different. So if the sort of art that they're looking at that they want to judge is like way out in left field, they've never made anything like this before in their sort of artistic practice, they hate it. If it's identically to sort of what they've made in their artistic practice, they also hate it, it's boring. But if it hits a sweet spot, then they really like it. And it turns out when you have sort of this, as well as you let bots take art that they really like and put it into their population that they're going to use for the next round of a genetic algorithm, bots will naturally kind of coalesce towards little artistic communities. And that's really, really cool. But we'd like to go a little further too. Mainly, that's not what's on this slide. I transitioned way too early and now I'm not going to go back. So mainly that these bots all sort of privilege their own creative process a lot. They love what they make. And that might not be true, at least not in sort of practical art applications, right? When I try to make art, it's awful. I'm terrible at it. And so we'd like to encode that other thing too. Another sort of thing that's similar to what we're talking about, but not quite the same, is when several agents all come together to kind of to be a single creative process together. Hofstadter's Letter Spirit is a lot like this, with all of its codelets, and it's sort of simulated annealing of different codelets firing until the system finally cools down enough to where it's coming out with a grid font. And also procedural level generator uses sort of many agents that all come together to make levels inside of an inner loop of a genetic algorithm. So all these agents are sort of mirroring the push and pull of maybe an internal creative process. But for our bots, they're all unique. Or each sort of bot embodies its own creative process. So we're talking about ethical free-range art bots, right? In order to get this idea of inspiration, bots need to be able to associate with other bots. They have to hang out with bots that they think are cool and reject bots that they don't think are cool. They need to have freedom of opinion. Bots need to be able to rate art, including hating their own art, in order to sort of try to figure out who I'm going to learn from next so I can make art that I enjoy. Bots need to be able to change their practice. We need to be able to have bots change the way they generate art based off of other art that they've seen or other creators that they've talked to. And finally, we want bots that have the freedom to produce or not to produce work. Bots, if their bots aren't feeling it today, they don't have to make art. I don't want to slave a bot to the button. Even though the demo I'm going to show totally does that. There's a typo. There are 4 parts to an art bot commune. As I said earlier, we want to be able to generate art, make artists, we want to evaluate art, and we want to talk about communication between artists. So to start, how do we make art? Well, we use a tool called Tracery, which I'm sure you've heard of. It's a context-free grammar language by Kate, and it does amazing things, including making SVG art. And so we basically just type in a JSON of sort of art, and then, or how we're going to make art, and then the result of expanding out this grammar is always an SVG picture. So that's easy enough. Now we have to sort of make artists, right? We need a way to generate a lot of these potential SVG grammars so that we can have different art generators talk to each other. And so we use tracery again. We make meta generators, or these are generators that generate generators, which I'm going to refer to as artists from here on out. And this creates sort of an art academy, so what's pictured is a language generator from tracery. But the idea is that these sorts of tracery grammars, when they finish expanding, are a tracery grammar. And then we can take that tracery grammar and that's an SVG grammar, and then we'll make art that way. So here's some example grammars that come out of sort of our meta grammar. Here's a bunch of little arts. There's sort of the relevant symbols. There's some other ones that aren't pictured here that are being used. But you get sort of these little abstract SVG arts, which is what we've been playing with. But there's no reason to think that for perhaps other implementations, we'd have to constantly stay within the realm of tiny little SVG art. It's just useful for right now. So evaluating art, right? How do bots look at art? And unfortunately, this is, like much other work we've seen, kind of old. And I want to show a little bit of the work later. So I'm going to actually talk about both versions, which is the version of how we did when I wrote the paper, or we wrote the paper, and the version that it is now, which is kind of way better and basically superior in all ways. When we did it, the old way we did it is that we said, okay, so an art is just a particular trace through a tracery SVG grammar. We can pass that trace around from bot to bot, and we'll look at that trace when we're evaluating art. So when we then just look for a particular rule expansion inside of the tree, and if we have it, then we know that we like that art is good. And this might not be a rule that we actually have in our grammar. This is actually separate from that. But so we might not be able to make art that we like, but we can still see art and be all like, oh, there are triangles in it. I love triangles. Triangles are the best. I wish I knew how to make them. How we do it, a picture to kind of see how this works. So I want to tell a parable about Gray Hat Bot. Gray Hat Bot knows how to make gray triangles, but Gray Hat Bot hates his work. Gray Hat Bot would really like to be able to make sort of magenta circles and can look at sort of Pink Hat Spots who can do that and rate Pink Hat Spots works very highly because that's the expansion. Those are the expansions it's looking for. It doesn't actually see the pixels on the page. How we do it now? We look at pixels on the page. Now, why do we want to make this change? Because if we look at sort of art this way, we can't meaningfully self-prune. So an artist can't look at their grammar and be all like, I'm going to take this symbol out or that symbol out, because they can just sort of look and say, hey, do I have the symbol I like? Great. I will prune everything out except for those symbols. Alternatively, I don't have the symbol I like. There's no way for me to get better until I learn that particular symbol. And that's a binary distinction we don't really want in this work. So how we do it now is that we actually look at the pixels. We look at sort of hue distributions of the art. We have an edge detector. We run an edge detector kernel over them to come up with sort of a rating of edginess. Contrast scores, which just look at the lightest and darkest parts of the image and then try to figure out a score for that. And maybe even more. There's plenty of ways we could evaluate art, right? There's a great thing we want to do in the future, I think, is to run a machine learning algorithm that looks for cats and then have a bot that tries to find and make cat art. So how does that look these days? Well, it looks like this. So we can see that artist 0 has a bunch of art they've made, and artist 0 really likes the color orange. And the more orange he or she, it, sees in the art, the happier they get. And the less orange, the less happy they're with that art. You can actually do this for any colors, and everything looks really beautiful, especially sort of visualizing out these hue distributions. And sort of hues are a really cool way to look at this stuff. But they're not the only way. We can also use really awesome puns like art edginess, which just runs an edge detection kernel over the art and then rates it based off of how many edges it found. So the more edges, the more I like it. The less edges, the less I like it. That's when I'm looking for edginess. So you'll see that this bot has a favorite edginess. This scale maxes out at 1 of pretty high. It's looking for edgy art. And when it finds it, it gets very happy. But if that number was lower, it would have rated the high edge thing there with all the squares, the 2.09, very lowly, and would have really loved these sort of dab squares that are just sort of blotches of color. So bots can evaluate art. We have a way to make artists. We have a way to have artists make art. So how does one bot tell another bot that its art would be oh so much better if only it used blue? And we do this in the real world by offering critique, right? We say, I look at this art. I think it would be better if you did this other thing. Or actually, there's a slide for this. Haha. So in the real world, we talk about sort of critique as in, I like it, I hate it, right? I can give you sort of this weird value judgment on sort of your art that you've given to me. I can tell you how I might have done it if I was going to make your art, which you should never listen to because I can't do art. And I can also say the sort of vague, I don't really know why I don't like this, but if you pass me something I like, I'll definitely be able to tell you that I like it. And we can actually sort of operationalize all these options. So I like it, I hate it, turns out to be pretty easily contained as a numeric score. You know, I would have done it like this. I'll share part of my generator with you so you can mix in that part to see, to try to like make art more like how I'm telling you to make art. I know when I see it, I can give you some of my evaluation code so you can try to see the world through my eyes to understand what I'm looking for when you go back to give me more art. So there are two ways, and we kind of have good solutions for two of these. The evaluation code is still very much up in the air. It's a workshop. I'm not really sure how to do this yet, but I think there are probably some good ideas out there. So how do we do this, right? The first part's pretty easy. We can just pass a numeric score around. But when we're talking about grammar, we're talking about sort of passing generators around. How do we do that? Well, luckily, all of our, the way we make art is always an SVG grammar, and it's always based on tracers. So we can just give you a bunch of tracer symbols. You can just mix them in your grammar. And if you get results, if it works, that's great. That shows us that we get sort of emergent behavior. You might not even really understand these symbols. It's totally opaque to you. But you can actually sort of look at which parts of this black box you like and keep that part, and then trim out the parts you don't like. Which is kind of similar to Danesh, which we talked about earlier, where there's this black box function called generate. I don't know how it works. I don't care how it works. I just want to make art with it. So then when we go to try to figure out what we like, we just use a generate and trust strategy, right? We generate a bunch of art. We then change our grammar rules, either based off by asking other bots how they might have done it, or by just freely exploring the space ourselves, since we can look at the full alphabet if we want. We can add rules, we can remove rules, we can exchange rules, and then make a whole bunch of new art, and then evaluate that. And if it's better than the old art we made, that's awesome, keep the change. If it's not, don't. This wasn't working for us. So as a set of images then, this process with Gray Hat Bot, who I'm picking on today, Gray Hat Bot currently makes gray circles, and Gray Hat Bot does not like the state of affairs. Gray Hat Bot does see, however, that he likes magenta triangles. And in sort of the old version of the system, he was allowed to just look at that tree and pull those symbols out. In the new version, he has to then go find sort of the magenta triangle creator and say, hey, can you tell me how you make art? And get some of the symbols that he likes. And he can incorporate that into his own grammar and then start making some stuff that now has magenta circles in it, or maybe gray triangles, but has some of the things he's really looking for and gets more happy about his artistic output. So there are sort of really important operations, and you get sort of this thing. Pruning a grammar is just removing symbols, and this is really good for increasing consistency in your artistic output. As you sort of get your grammars wider and wider, you get more variance in what you're doing, and so you can zoom back down to sort of concrete ideas. You can either do this undirectedly, just prune some random stuff and see what happens, or you can try this as sort of a directed search where you sort of prune, generate to see what happens, and if you like it, keep the changes. If you don't, then just re-roll and prune some other stuff. Finally, you can sort of incorporate other ideas from other people in this sort of ducky way, right? So this art bot, every single color of symbol comes from a different artist. So the red stuff was the stuff we started with, and then we looked around, asked some artists for how they were making art, and this diversifies our grammar and gives us more ways that we can expand and changes sort of, our potential expressive space of what we can generate, and then we can prune back down to get sort of optimal art. That's all well and good, but I actually want to kind of show off some of this stuff because I think I've got some time. So if there's a tab, here we are. 1 second to, I extended my, my monitor so I could get presentation view, and then I didn't think about the, here we are. Hey, now I can't see what's going on, but it's fine. We have some art bots here. We also have some really rough resolution problems, but that's cool. So essentially there are two windows in our current system. This window, which is sort of how we can generate lots of different artists and look at sort of their artistic output as well as the grammars they're currently using. and also this sort of test evaluate, which is let's look at some potential critics and how they're evaluating, potential ways to critique art and how it's evaluating art. So I want to start with sort of test evaluate. Let's look at this one. And then come back here. Prototype. We can see that there's a sort of favorite color. We're looking for what looks like green from this angle. We're looking for a low amount of edginess, if I'm, again, reading that number right. And we're looking for a high degree of contrast. And we can see how we score on these things. So our edge detector is really happy. There isn't a whole lot of edges that it can pick up in this art, so it's super into it. We don't see a lot of green, so we're not particularly happy with it, but we do have some yellowish color that we're kind of okay with. And we can see that for contrast, we're really just not happy at all, right? There's very little contrast in this image, and the contraster detector just doesn't like it. And we can explore different colors to see how they're going to change on particular images. So we can see that purple is really, like, definitely not great. To make sure that these sorts of things work. Red scores a little better. That particular shade of red scores really well. We can also do this for sort of edginess and contrast by, again, just clicking on these numbers to sort of see how our evaluations change, which is great for debugging. And we can also load in a different art once we realize. We can also see this for very many arts, which gives us a good test bed to make sure that our evaluators are working how we think they should be working. But the main attraction really is this bot window, which lets us sort of look at different bots and how they're interacting in our current commune. And right now, all of this is based off of button clicks, but there was an implementation until I broke it very badly based off of a really hilarious logging bug that was just running on its own via several different node processes that were just communicating with each other. And then I had a 10 gigabyte log file and overwrote everything in my server and crashed it. But until that point, it was going great. These artists were kind of working on their own and exchanging art when they felt like it and not exchanging art when they didn't feel like it. But for right now, let's go back to this. So let's see, you're a bot that seems unhappy with your life. Your current happiness seems to be poop emoji. And so this bot's looking for green. And currently, the art that this bot knows how to make is very blue and very yellow and very angular. And I'm just showing off the color sort of things right now because they have they're the easiest to see and the most exciting. That's the one part about demos. You can always pick the part of your system that you like the best. So when I find my mouse, I can have this bot learn from a random teacher, which will incorporate some random symbols into the art it makes. And now we see sort of more difference in sort of the art it's making. And this bot, I think, got a little happier, but I can't actually read that number from here. Let's see if I can get it. Yeah, there we go. I don't know if that went lower or higher. Let's see, can you get a little happy with your life? All right. So this bot's learned some stuff that he's into. But doesn't like his whole art, right? Because he's made so much, he's got so many different ways to expand that sometimes he seems to be striking gold, but other times he's just not very satisfied. But he can try to prune back his artistic practice by generating a bunch of test images that I'm not currently showing. This takes a little while. And then seeing it if pruning out his art if he feels like it. Right now, this artist, when he did some sample prunings, didn't come up with anything that he liked more. But if I have him prune again, maybe this time he will. Give it a second to see if it's going to load. No, this BartBot's decided that this is what I'm making today, and you are not. I am not changing my grammar for you. Probably because so many of the symbols are not particularly valid, so the test prunes that we're making aren't showing up any better. Let's see if I can take a bot that's currently happy and make him unhappy. Let's see if you'll prune out some of your stuff. No, you're pretty into it. Let's see. Actually, I can also change their preferences if I want. There we go. So this bot was like not super into his art, right? We gave him some symbols that turned out to be let him make art that he liked more, and then we can prune back sort of the symbols that he didn't like once he started generating and testing his artistic framework. So now back to the slides, if I can recover my cursor. So that's all really cool, but you'll notice that I haven't done anything like figure out how to evaluate the system. Or we'd like to do other things where we can actually sort of have bots change the things that they like based off of what they're seeing. And that's still future work for now. We'd also like to wrap up a lot of these interactions into a single critique message, which helps for message passing when we want to start letting the commune on its own. I'd really like to design an authoring interface for this because essentially whether we talk about it or not, every single one of these art bots encodes an artistic philosophy. And so if we really want to get to like awesome sorts of great art, we need to be able to have, we need to be able to let anybody make this, right? Because it's your worldview that you're going to be encoding a little bit into sort of an art bot. And so by providing an authoring interface, we get more people to make these, which will diversify our commune, which will help sort of better idea transfer. And the best way to do that is to provide a good interface. And I'd like to extend it beyond domains other than SVG art. I have, that's definitely broken and not working, but I have a little set of bots that learn sort of recipe semantics from the Milk database, which is a tagged corpus of 400 recipes with semantic tags. And then they pass around little recipes, but then they can't figure out how to evaluate them, which is unfortunate. But yeah, that is my talk. And I can take questions. And thank you for your time. How badly am I over?
Not at all.
Great. Yeah.
I like it.
Cool. Aces.
About the evaluation, I was discussing
Sure.
your feedback mechanism.
Mm.
If I would do it, the evaluation sharing,
Yeah.
I would probably look into doing it into a weighted sum and then have the weights change based on feedback you get, for example.
Yeah, so one of the things that we don't have right now, because we're only looking at one part of the art, but one thing that we want to do in the future, I just wasn't able to hack it right before this talk, was essentially having each bot have several little critics that they're looking at, and then have them keep an internal weighted sum of how much each of these things matter to them. And then you can tweak the weights, which tweaks how the bot looks at art. But you also want to tweak sort of what they're looking for too. Yeah. Julian.
I like it too. But putting a lot of pressure on the next question asker here. No, but so I think, I mean, it seems like when you're looking for the next domain, as you're talking about, I mean, it seems important that there's a big difference between how easy you can generate something and how easy you can measure it.
Yeah.
Because you want these bots to do something that you want them to try but fail a lot. So
Yeah.
It's very clear that, you know, in this domain, the SVG images, I mean, the whole potential is obviously not coming out. So you want something with like a very complex genotype to phenotype mapping, or very complex something.
Yeah.
Sort of. So in a way, the more possible, the better to some degree.
Yeah, no, that's true. And I think that something we have to look at, and there's a lot of research on this already, right? But just good sort of phenotype mappings of stuff that we can very quickly change and tweak, and then we can like push back out. So.
But then it's a very non-linear sort of change.
Yeah. Yeah, so stuff like, I don't know if James is here, but James Ryan's languages that he talked about earlier, right, where he's got like these whole sorts of conceptual ideas encoded in a bitmap, which would be great for something like this. Adam?
I hated it, by the way.
That's fair. That's actually what, yeah. I'm glad you're honest.
No, since I can't make a suggestion that
Yeah.
doesn't involve machine learning, I want to see machine learning involved in this. Like, I'm sort of like, in a way, it reminds me of like the generative adversarial networks where you have like, you know, one side that's trying to discriminate and one side that's trying to generate.
Yeah.
And I'd be interested in seeing sort of similar types of things where, you know, you try to generate towards a specific goal, but then that helps inform your own process to then update how you're going to generate and things based on like, you know, sort of doing the back propagation and getting like, oh, I see that this now improved my happiness by 5, so like I now have a better idea of how to do it, as opposed to the sort of maybe more random pruning and stuff to help sort of guide the generation process.
Yeah, definitely. And I think one of the things that will really help is once we get a good sort of interface for this sort of stuff, because it would be really awesome if you could just sort of plug in your generator, your evaluator, because they're completely separate in code, and then just watch your artbot go. The tricky things about some evaluators, and again, it's not something we've solved yet, is how do you share part of a machine learning algorithm with another bot so they can try to see the world through your eyes? And maybe you just have to share the whole evaluator. You have to just be like, well, I'm using this, and I'm just going to pack up my entire evaluator to you, and you're going to like run your own machine learning. You know, because nobody actually uses computers. We just leave them running overnight to solve problems. Yeah, I don't know, but I think that, yeah, a good interface will help with sort of integrating with machine learning techniques, and that would be really awesome to do. Jillian next, then Mike.
I have mixed feelings that I could do a deep critique of, but overall I love it. But I am curious, like, how far down the rabbit hole you're interested in going on the critique thing, because the way that humans do artistic critique is very much framed around our own experience, around a shared mental model of the world, right? You can look at something and say, oh, you know, this vase feels really heavy to me. Why does it, like this
Yeah.
one of the vase you did feels very heavy to me. Why does it feel heavy? And it sort of like calls on common experiences we all have about like what it means to feel weighty in the world. And with abstract art, it's often about like, you know, the process that the artist was following combined with like the stories that we read into the piece. And like obviously this is now like beyond AI complete. But like there is more to critique than like the three. Obviously, there's more to critique than the three things that you had on your slide, and I'm wondering if that's a direction you're interested in, and like how far you want to go.
So I think that that's great. Like as I said in the talk, I'm still struggling with part of just getting those three operations up, and I think it might be, and I think it might be a good starting point. But again. What might be really cool, and I actually gave a very lightweight version of this talk to a bunch of my roommates, where I sort of, one of the things they came up with was, oh, it would be really cool if people could specify communication channels too. Because right now, all communication happens through art. So there's like, you pass an art and then you get some sort of critique back. And then from that critique, you can change your generator to see how you're gonna generate new art. Having sort of back channel communication where bots can talk about like, oh, I'm just going to give you my generator, and maybe you like critique that. Or we're just going to like talk about what sort of shared parts of our experience are and then modify our generators that way. Might be really cool, but definitely feels really hard. But I think that, having some easy way to author new channels might help with sort of other researchers tackling that particularly tricky problem.
Okay, thank you very much.
All right.
Yeah,
If you want to hear more about it, buy me a beer. Sure.
Do you want to ask your question, Mike? Well, Tiago setting up?
The stream wanted to ask whether the danger of sharing evaluation functions is that they'll eventually converge and everyone will want the same thing.
That's probably yeah, good job, stream. Yeah, I think that's probably a problem. What might help is that you can sort of you can add sort of heuristics where bots don't want to change very much. They get very stubborn, and then they'll only change a little bit. And maybe as time decays, they'll be willing to open up for more change. That'll slow down the eventual decay. But what really you need is you just need a lot of authors that are willing to write bots and then inject them into the Commune. So the stream can definitely offer some bots to help that problem.
Hello, my name is Tiago. Ivan Bravi and Zhuang are my colleagues. We worked together in the Shopping for Game Mechanics. And Professor Julian Togelius and Professor Andy Neeling are our advisors. And we all are from the Game Innovation Lab at New York University. So, in the essence, the Shopping for Game Mechanics is a recommender system that suggests game mechanics. And speaking about recommender systems, they are very common nowadays. You have recommender systems for almost everything that you can imagine, but the most common cases are friends, suggesting movies or videos to watch, suggesting books to buy, games to play. And what does our system do? Let's suppose you are trying to develop a Tetris game. So if you are trying to develop a Tetris game, this is our rhetorical question. In which column do you think that you will find good references for a Tetris game? Actually, it depends. Maybe if you are trying to do a Tetris clone, maybe that column is a good column to get references. But if you are trying to do something new and try to cause a revolution in the matching tile games, maybe you should try references for games completely different from Tetris. And so this is what our system do. It looks for patterns in a game library, patterns that matches with the game that we are trying to do, and suggest mechanics from those games. So the main purpose of this project is to serve as an AI-assisted game design tool, like we saw in projects like Tanagra, Roposon, and Sentient Sketchbook. And in this case, to prototype this idea, we use the video game description language. For those who never heard about the video game description language before, it's a game description language. It's very simple. It is divided in these 4 sets: the sprite set, level mapping, interaction set, and terminator set. This sprite set is just about defines behaviors of the visual elements that you have in the game. The level map allows you to represent these visual elements as characters in a TXT file. The interaction set, as the name suggests, explain what happens when 2 visual elements collide. And the termination set defines if you win or lose a game. And as our recommender system is for game mechanics, in this case, in this game description language, the core of our system is the sprite set and the interaction set, because they represent the core mechanics of a VGLC game. So, before to do the recommendations, we need to do some transformations in the VGLC tree, because if you look for the sprite set, it is a depth-first search tree, and if you are trying to compare a sprite in a game that you are developing with a game with another game previously created, if you have something like that, a sprite that has no information, it will be very difficult to get some similarity about something that has nothing. And navigate the tree will take too much time to see if something is similar or not. So we have to shrink the tree to something like that below. And by this way, we have all the sprites and preserve all the parameters, so we can do the comparisons. In the instance is everything about similarities. Is everything very straightforward. Just get a sprite, looking for sprites similar in other games. And speak about sprites, in VGDL, a sprite is not related only to image. Sprite in VGDL means a behavior of a visual element. So if you are trying to do an NPC or object, a wall, a door, a key, you have to you need to have an image, but you need to specify the behavior of this image. So, how to measure sprites? First, you have to see the types, if the types of the sprites are the same. If yes, calculate the vector distance of their parameters. Otherwise, return a minimal default value. The interaction set is pretty similar, but in this case, you have to look for, first you need to see if the types of the sprites in both interactions are the same. If they are the same, you compute the vector distance of the parameters as the same way as we do in the sprite similarity. So these two similarities allow us to do high-level comparisons, like a game-to-game similarity. So if you are trying to develop a Space Invaders and we are trying to see if a game like Zelda has something to do with Space Invaders that we can use in our Space Invaders, we'll use the similarities that I talked before, but in the context of our game. So for every sprite in this Space Invaders game, compute its similarities with every sprite in the Zelda game. If the result is bigger than a threshold, you will compute the same thing, but in the interaction set. And of course, you will store the computation if the value is bigger than the current value that you already have. And the last similarity is when we want to see if a particular sprite will fit in your game. So for example, this arbitrary sprite, let's see if it will fit in Zelda. So we look for the sprite, and for each interaction, we isolate this sprite and we're looking for the other sprites that are in the interaction. So if the Zelda game has these other sprites, these other types with similar parameters, it means that it's a good sprite to fit in the Zelda game. I have a video to present the user interface. Okay. So this is a simple game, a very simple game. The only thing that the player do is escaping from the monster. I don't know if you are seeing if it's good to see. So yeah, this very simple game, and now I will try to asking for recommendations. So in the original game, the player has no weapons, and when I asked for the recommendation, they suggested me 2 weapons. And yes, you have 2 recommendations, and you click on one sprite, and you can see all the information that this sprite has. So you can accept the sprite as it is, but if you want to, you can change the parameters. In this case, I accept the sprite as it is. So let me move backwards. So I select the player. The player is the sprite that represents the player. And now I have a sword in my sprite set. and I can use it in my game. Oh, sorry. So now you don't need to just escape from the monster, you can fight him. So, yeah, this is the shopping for game mechanics. As a contribution, we believe that is a good AI-assisted tool for recommended mechanics. And there are another things about this system. I would be very glad if you come to visit me and I can show to you. And as future works, first, I think we need more VGDL games because most of the games in this set, I don't know if I'm sure about it, but many of the types of the sprites are oriented avatars. So when we are trying to compare, many of the times the system selects a game as a puzzle as a similar games about every other game. So we're trying to get new recommendations, but it ends suggesting the same recommendations over and over again, and you have to edit a lot to see something new. So it's some kind of disappointed. And we also need to perform a user study to validate the quality of suggestions, and maybe to get feedback and improve our system with new policies based on the users' feedbacks. And of course, suggest termination conditions, because if you have sprites and interactions, you now have all the sets to provide ways of finishing your game. Yeah, that's it. Thank you.
Really nice talk, and I think the tool is really nifty, the user interface. I have a question about the distance, though. Do you somehow sanity check the distance or have some weights? Because it seems that having a score increased by 2 or 3 is not the same as speed dropping from 1 to 0, and then you become immovable.
Yeah, in this case, it's like a Euclidean vector distance, but we are not using weights. And there are some parameters that we exclude from this distance because, for example, there are parameters that is just the name of the sprite. So the name doesn't mean anything about behavior.
Yeah, I really liked it a lot and was interested in the topic. 2 questions. The first question is, so right now it seems that similarity or dissimilarity is essentially the quality criterion by which you think game designers make decisions. So I'm wondering, the moment that I'm as a game designer interested in something else in similarity or dissimilarity, how can you work with this system? So the moment I'm interested in, well, how much does the user like it? Versus similarity or dissimilarity. So to what extent, what's the quality that you're essentially shooting for? And the second one, is sprites and interactions necessarily the right level of granularity for suggesting game mechanics? Just when I hear mechanics, I'm expecting something else, just label-wise.
Okay.
And I think there is an argument to be made why things like game atoms or mechanics might be a better level of granularity for designers than sprites.
The first question, we provide 2 suggestions, because when we are doing the comparisons, we assemble a ranking of the sprite similarities. So we provide the most common sprite and the least common sprite. So by this way, we are providing the similar, the most similar, and the dissimilar one. And the second question is about granularity, right?
Yeah, if that's the most useful level of granularity to look at.
Yes, we are not suggesting just sprites, but also interactions. So I don't know if maybe I showed the video too quickly, but when you select the sprite, you can select interactions, also interactions about that sprite and the game that you are trying to develop. I don't know if I answer your question.
Well, the question is if interactions is closer to game mechanics, depending on how you define game mechanics. But I wonder if that then, so just verbs, basically verbs and objects, if that's the best level of granularity, or if you want to go for a higher level of granularity, like what's a complete mechanical system around a certain type of challenge.
I see. Yeah, I think it's because in VGDL, it's the only thing that you have to provide mechanics is the behaviors and the interactions.
But I think a related question is, then you can make attack a verb that both the master and the hero can use, because then it becomes a fighting game. You share mechanics, and if it's tied to a sprite, then it's very much what that specific sprite can do.
I see. Yeah, you can do this because when you add new elements, you can add also new interactions. You can change. It's up to you. You don't need to accept everything as it is suggested.
So I might have missed how you created these descriptions in the description language. I guess it was manually in this case, but for a system like this, I guess the important thing is to have as many games as possible described. So do you have some way of generating these descriptions from public available sources? Or would there be other description languages which you could use which might not be as good or descriptive, but you'd have more stuff, so you can use the recommendation system more? Have you explored what other alternatives you can recommend, or how to automatically do it?
Yes, we have other game description languages. I didn't explore it yet, but about the games, there is a framework, the General Video Game Framework, and this framework has about 50 to 60 games already created. So most of the games, actually all the games I took from this framework. And now I am also working on a game editor based on this framework. So you can work in a visual environment to create more games in video game description language.
So I have a couple questions and suggestions. So sort of to reiterate what Antonia said, it seems like perhaps Euclidean distance maybe doesn't capture a lot of like sort of very meaningful things, like movement being perhaps far more important than like score value or something. So it'd be interesting to either weight the vector, or I'm thinking that like maybe doing some sort of like dimensionality reduction to try to capture like correlated things or things like that might be useful in terms of like generating things, and even doing some sort of dimensionality reduction and perhaps in a sort of fuzzier way, so that you're not limited only to the things that you have seen before, but can perhaps learn to sort of interpolate within that space and not just like the discrete points that you've seen before. Might be sort of interesting things.
Yeah, totally.
Actually, I do have a question. I forgot it. It was how do you handle like, so I don't know my VGDL that well, but like I know that like some of the like say like avatar movement behaviors, it's like, you know, it can move in cardinal directions or move in cardinal directions and like change facing. Are those treated as entirely separate, or is there some sort of distance between like those, or is it that they are like how is that handled?
Yes, they are separated because every kind of avatar in VGDL, they have a set of parameters. So the set of parameters provide us this differentiation about the avatars.
Okay, so it's entirely, so it's like two discrete sets that are,
Yeah.
So there's not like, oh, the avatar that just moves in cardinal directions is pretty similar to the avatar that moves in cardinal directions and turns the facing or something.
No, they're two different descriptions.